everyone, welcome to this course on data analytics with Python. Ever wondered how Python can be the secret to unlocking valuable insights from data? Well, this course is your gateway to master data analytics with Python. So whether you're just starting out or looking to build an existing knowledge, this course will guide you step by step through the essential tools and techniques needed to excel in data analysis. Why is this course different? Because instead of just learning theory, you will be working on hands-on project from the start, including real-world applications and step-by-step instructions. You won't just understand Python's role in data analytics, but also how to build your own data projects using the most popular Python libraries like NumPy and Pandas. So here's what you will learn. First, we will dive into the basics of Python programming and the essential role in data analytics. You'll get familiar with core concepts like functions, debugging, building a program step by step. Next, you will learn numerical Python NumPy, the go-to library for handling arrays, performing matrix operations, and applying statistical functions like mean and variance. Then we will move on to data manipulation with Pandas, where you will learn how to manipulate data, filter data sets, handle missing data, and work with JSON data. You'll also explore how to perform aggregates and clean data effectively. Finally, you will explore data visualization using Python plotting libraries to create bar charts, box plot, visualize key data insights. With a focus on practical industry relevant skills, this course will equip you to tackle real-world data challenges and develop the confidence to work on advanced Python projects. So are you ready to transform your understanding of data and programming? Let's get started. So before we get started, here's a quick information for you. If you're interested in becoming a professional in the world of data, you should definitely check out this Data Analyst Master's program. Now, this course is specifically designed to help you focus on Tableau, which is one of the most powerful tools for creating visual stories, interactive dashboards. So whether you're a beginner or looking to upgrade your skills, our syllabus covers everything you need to know. You will start from basics of Excel, SQL, moving on to Python, R programming, mastering data visualization. The biggest advantage of this program is that it's not just about theory. You will be gaining hands-on experience by working on real-world projects like crime analytics, sales tracking. Plus, when you finish, you won't just have new skills, you will earn an industry-recognized master certificate from Simplilearn and official certificate from Microsoft. So this is your chance to join a field that is adding millions of new jobs. With our expert-led classes and career support, we will help you get noticed by top hiring companies and land your dream job. So here's a quick quiz question for you. Which Python library is used for numerical computing and handling arrays? Your options are Pandas, NumPy, Matplotlib, or SciPy. Let me know your answers in the comment section below. So without any further ado, let's get started.
So now we jump on the next part with Python, which is your data analytics, right? So data analytics is generally like most of the companies are doing data analytics, right? So first we try to understand like what is data analytics and like how we can use this data analytics using Python. Okay. So first of all, like we have understood Python, right? And then there are some libraries in Python we can from where we can do the data analytics part, right? So Python libraries such as your Matplot, right, and your NumPy, your Pandas, right? So these are some of the effective tools from where you can do the data analytics very effectively, right? So we will touch upon these libraries, and the main agenda of this session is that we will try to look these libraries and do a practical, right? As we have done the practical demonstration of Python. So here also, like we will be doing the hands-on practice. So we will first touch upon some of the basic concepts, right? Why we are trying to do data analytics and why we are trying to learn it. And then we will try to quickly jump in the next later half of the session with the Jupyter notebooks, and we will try to touch upon these libraries. Right? Understood? Right. Okay. So why Python is used for data analytics, right? Because basically it simplifies data task and ease and effectiveness, right? So basically Python along with some utilities such as your Matplot, your Seaborn, your Pandas, right? So these are some of the libraries which can do the data analytics task for you. Okay, right, right. And it also not only can work on small data set, but also with large data set, So as you can see that now the era of data is is very huge, right? So as you see that lots of feed are being generated by your Instagram, your YouTube feeds, right, your Twitter feeds, right? So these are being data, right? Your IoT data is also considered to be data, which is your real-time data, and this data has to be analyzed in the real time, right? And then Python is the library. Python uses some libraries which can effectively leverage this data and effectively use it for the data analytics. Let's say you have your smartwatch, right? And the data is being your it monitors your heartbeat or your blood pressure, right? And this data is being constantly stored on the servers, and then it will try to analyze something, and from the basic trends, it will try to give you that okay, your heartbeat is being rising, or you have some threat in your body, right? Some kind of analysis it will try to do, and it will try to inform the user about that. So this is the practical implementation in which the data is being fed to the servers, and from the servers, some sort of data analytics is being done using some Python code or using some machine learning, right? And some algorithms have been also be written on the top of that, which will try to tell or predict what are the chances that the user can get a disease or user is likely to get some disease, right? So these are the things which they can predict. So these is really useful by using your Python, right? So capability, it manages large data set efficiently and with and also scales it with demand, right? As soon as the data gets increased, like more and more it tries to increase, right? It will try to manage the data, it will effectively try to clean the data, and then try to do some prediction, right? And it also have the versatility, it adapts to diverse data, right? So the diversity means your data could be collected from various sources. It can combine that data, it can clean that data, it can transform that data, and then effectively it will try to analyze some tasks or do some decisions, informed decisions, right? And the why Python is gaining importance nowadays is because of the community also. So Python community is very strong. The developer community is very strong. Even if you can get some error, you can just go to the Stack Overflow or your Python org, right? And there some other developers are also facing some issues into that programming or some error, so they can guide you. Okay, so internet has lot of support in terms of Python. Some packages is not working, some frameworks is not working, right? So you can get effectively very good support of it. It is not that like you are using alone, you are using Python. It is millions of subscribers and the users are using it, and some of them has faced some issue in some versioning or in some particular program. So they might have written that code and posted on the internet. And the Python community or the developers which are working in the Python community, so they have solved that issue. Okay, so as compared to some newer languages, let's say Golang or your Swift or some other languages. So in some parts, like there, the community is not so active. Okay, so now the Python community has grown bigger and stronger. There you will not face any kind of an issues or difficulties while using it. And also it is open source. You can also contribute to it, right? So this is the main advantage of using Python. And in terms of data analytics, in terms of machine learning, in terms of AI, right? So as we progress this course, right? So now we are trying to learn why Python is effective for using data analytics. In the next session, we will try to learn why Python is effective for using your machine learning, right? So this we will try to cover up. Okay. So now we'll talk about what like is a library, right? So as earlier also I stated, like there are some packages or modules which we call it, that is your library, right? So Python is alone a language, right? So you have started working with Python, and we have seen that there are some data types in Python, and there are functions, right? And then we can use that functions and these data types and using their if else statement. So we can just make some small programs, right? Okay. So let's say if we wanted to do some sort of analysis, right? There we need to have some Python libraries. Okay, so what are these libraries? So considered in this manner, you are trying to construct a house. When you try to construct a house, so there you need a plumber, you need a carpenter, right? You need a painter to paint your house, right? So these are being referred as to external contractors, which will try to do the job for you. Okay. So similarly, in Python also, these as you see in the screen, these are some external libraries like SciPy, Pandas, Matplotlib, Seaborn, NumPy, or Stats model, which has some pre-written code that can be imported and used to perform some tasks which you have a requirement. Let's say I wanted to do some analysis of some data, right? And I need to do have I have huge data. I need to do some mathematical computations. So there I would use NumPy. I will store the data into a NumPy array, and then I'll try to do some matrix multiplication. Or else, let's say I have a CSV, and the CSV there is a long like a record of CSV, right, which are around 30,000 records or 50,000 records. So these CSV, you cannot manually try to see each and every record and try to do some manipulations. However, you can do it by using macros and some these Microsoft tools has given us the advantage. But in terms of programming, so it is very difficult for you to manually see it. Yes, CSV could be an Excel also. CSV is basically a format. So Microsoft Excel, Microsoft CSV, right? So these are basically or a PDF also or TXT also. These are various formats of data in where we have stored some data in the tabular format, in the row and column structure. You are right, Deepak. So this is what I am trying to refer. That CSV is mainly refers to the XLS or the Excel part, right? Okay. So there you wanted to analyze something, but the data is so large and so huge, so you cannot manually it will be a very troubling situation for you to just analyze it manually. So what about like you have external library called Pandas? So there you can just see the records and you can just interpret, give me the unique records which are present in the CSV. Give me the records or the names of the students which are scoring let's say greater than 80 marks, right? So I want to do some data manipulation, right? So these way the pandas is the excellent library, or you have tried to call that library and try to use its functions and methods, right, from that pandas library. Okay. Then after doing the manipulation or interpretation or cleaning your data, right? So you wanted to showcase it. How you can showcase it? By use of some uh, charts, graphs, right? Because visual representation is best, like in terms of explanation, in terms of storytelling. When you are trying to represent your data and you have wanted to convey your information to some other external third party, so visual representation works best, right? So that visual representation could be in terms of your charts or bar graph. Okay, so let's say I give you an example. Let's say we all watch news every day, right? So we all watch weather forecast news. Okay, so there they will try to give you a graphical representation and in which area the rain is likely to occur, right? And this is how how much rainfall could be recorded in these areas. The winds are blowing at this speed, right? So they give a graphical representation. So, however, they could give it by numbers also, but numbers don't appeal it to you, right? So the graphical or the visual representation appeal it to. So they show it by the graphs or the bar charts, that how many percentage of voters are being listed in this constituency, right? So this candidate is winning or losing by how much percentage, right? So these are the things in which we can just show them the data analysis by using some kind of a tools which is called as Matplot or Seaborn. So Seaborn and Matplot libraries are used for the data visualization. NumPy for numerical Python. Numerical Python means storing the data in which we can use this large storage of data effectively, and we can do some matrix multiplication also, right? So these external libraries we will be doing in practice. Okay, so I'm just giving you the building up the context in which how why we are using it and what these libraries offer us, right? And Pandas collectively is a very effective library in which we can use these for taking the CSVs or the Excels or the TXT part, right? And try to do some manipulations on the data, right? To find some records, right, to that data. And SciPy and stat models include your models or your algorithms or doing some statistical analysis, right? So what you wanted to find the mean, you wanted to find the standard deviation, right? You wanted to include some of the ANOVA tests, right? So these we will try to learn in our coming lectures. But I'm trying to give you a context that these all the libraries we will be trying to learn it via practical, right? Okay. Okay. So now, as I already told you, so these are some of the libraries which are being broadly divided into three parts. So one is your numerical computation, another is your data manipulation, and third is your data visualization. Right. So numerical computing, they provide your array objects and your mathematical functions to perform your computations. Right. So in the end, right. So when you are trying to do some analysis of the data. So you wanted to perform some arithmetic operations or mathematical computations also. So there, NumPy and SciPy libraries work best. Okay. So these data has been converted into a NumPy array. From there, you can perform the functions, which is the inbuilt functions. You don't need to write any code. You don't need to write any complex algorithms where you can perform some operations. So you have an inbuilt function. You can just call that function and then perform that operation on that particular data set. So for that, you need to just import these libraries, such as your NumPy and SciPy, right? So we will try to look upon it. Okay, right? And for the data manipulations, so we need to modify some of the data. So we have some datetime libraries, your pandas library, right? So these are used for your data manipulation. And for the data visualizations, so we can have your plots, diagrams, right? So these are the libraries which your Matplotlib, Seaborn, or your stats model. So these are your data visualization, right? Okay. So let us try to see first datetime library module. Okay. So datetime library is one of the most basic data manipulation tools in Python. Okay. So let's say we'll try to give you a like every day we are trying to work with data, and that data is to be date specific, right? Let's say I wanted to get the uh, uh, analysis of the previous data, right, which falls under so and so years. Okay. Or basically for the futuristic data also, let's say we are trying to have a real-time data occurring, and we can just make some uh, checkpoints. Let's say on the month of February or on the month of March. So let us try to analyze the data with respect to the user which has well, maybe a male percentage or a female percentage, right? Or maybe with respect to some goods also. Let's say consumption of rice like happens to be majorly during the festival season, it increases, or in the northeast region, so there are mostly people eating rice, right? In the south also people generally eat rice, but in the north they generally eat wheat, right? So based on some trends, we can just use this datetime library, and according that we can just leverage it, right? So it is a standard built-in library in Python, and it also offers classes for manipulating date and time, right? So let us see. So this datetime module is being divided into six parts. So first is your date, then it is your date time, then it is your TZ info, time delta, and time zone. So date, it will have only your year, month, and day, right? And your date time, it will be a combination of date, time with year, month, and hours, minutes, seconds, microseconds, and also the time zone information. So TZ means your time zone information attributes, right? Okay. And also for the time and time delta, it also will give you the time. Basically, it will only give you the time in hours, minutes, or seconds, or microseconds, right? And time delta will try to give you the difference between two dates or two time periods. Okay. So now we will try to do a practical also, like how we can try to calculate the age of a person, where like you try to give the age, and from your age and your current date, you wanted to calculate how many number of years or what age is of yours, right? Okay, so we'll try to cover it practically. Okay, right. So let us try to see this in practice. Okay, okay. So I have already opened it. So you also open it, and let me create a new folder, and I will say Python, and I will create a new Python notebook. Okay, try to create a new Jupyter file. Okay, okay. So what we are trying to do is, so this is your date time. Okay, so from datetime is a complete package. We are trying to import date. Okay, so I have also written something like this from datetime, right? Okay, so let's say this datetime consists of some, let's say if I say datetime dot, okay. So you can see that. So this C is a class, right? So we are trying to import date. So what we are trying to do is, so from date time, we are only importing the class date. Okay. So C stands for class. Okay. And these are your instances. I means your instances, right? Okay. So here you can see that. So in this datetime module, as we have seen earlier also in this slide, so we have your date, date time, your time, time delta, time zone, and TS info. So these are all the like six classes which we have seen in this slide. Okay. So this we can import. And these are your instances. So these are your instances and these are your class. So every module or every library follows this kind of a structure. Okay, you just need to know the name of their library. Okay, don't need to go to the internet and try to search for it. But in some cases, we just need to search for it also, right? Because we don't know, we cannot check each and everything. Okay, so this is how we can see that from date time, we are trying to import only date. And here in the line number 4, what we have written is import date time. This means I have imported all the classes, whether I am only working with date, okay, but I have also imported date time, I have also imported time, time delta, time zone, and TS info also. Okay, but these may not be useful. Whatever is useful, you only try to import that date. Okay, is this what you are trying to say is, like you are trying to hire a carpenter. Okay, so carpenter comes with a bag full of his tools. But when you hire a carpenter or call a carpenter, so he comes the tools of the painter also, right? May, we haven't hired the painter, but we haven't called that painter, but the tools is bringing with this. So similarly, from the date time, we only need the date class or the date module. But we are trying to import here all the modules in when we are trying to call the date time. Okay, fine. Okay, so I've shown you this thing. So this is the practice, right? So if you are trying to work with your data, don't try to import blindly. Okay, right? Try to call that module whichever is required only, because it will try to generally increase the memory of your code, because you are trying to import lot many libraries and calling, but here you are trying to call only those libraries. What will happen is that when you are trying to run this code, first it will go to your date time. From that date time, it will only import this date module. But when you are trying to write this thing, it will go to your date time and import all the modules. Okay, then it will be loaded into your memory and it will try to increase your, it will slow down your Python program. Okay, so I will not try to write something like this. Fine. Okay, so let us try to see this. Okay, so date dot. So in this date, we have tried to import that class. Okay, so now you can see that from this class, so these are some functions and these are some instances. Function, if you have function, you need to put a bracket. And if you have instance, you need to put a day. So no, you don't need to put a bracket. Okay, right? So this you need to understand. Okay. So let us try to give some date. Okay. And if you use some previous lecture, so there we have the signature, right? So there by the shift and tab, we can just see that what kind of a signature is that. So doc string is your date, year, month, and day. So in this date, we can just specify the year, month, and date, and it will try to give us it. Okay, so let us try to see that. So I will say 2012, 3, and 12. Okay, and I will try to see that, like let's say this is your date. Therefore, it could be a first date or something like that, right? And I'm trying to print that. Now you can see that. If you wanted to get a day, so you will try to get a day. Okay, day dot birthday dot year. You can get the year. Day dot right day. Month also will be there. Yeah, month is also there. Right. So you can get each and every information. So this is how you can convert any of the day into your birth, day, and year. So from the date time module, we are trying to import some date. So date is a class. So class, okay. So from that class, we have some functions or some instances, right? So these are some instances. So day is instance. Instance means some kind of variable. And we can also have some functions associated with it. Okay, so if I try to write date, time, birthday dot, and I could put a tab, so you can see that C time is a function, day is an instance, right? Is of format, from time is calendar, is of week, right? So these are all these things, right? So strip time is also a very good function. Okay, so this is used for styling basically. Okay, I just want to let me put some it is invalid. One second. Okay, so I'll tell you about this in the coming slide. Okay, so have you done this, guys? So I'll talk about the strip time in a later. Okay, so this was the datetime module in which we are trying to have some date, right? Okay, so the next part, right? So the today's date. Okay, so let's say from date time. So we are trying to import the date and we are trying to get the today's date. So date dot today will give you the today date. Fine. So this also we'll try to see it. Okay, so just quickly just see if you try to have the date dot today, what will be the output. So let's say I will try to date dot today and I will try to have today underscore date. Then I will say print today underscore date. Okay, so now you can see that today underscore date comes into this uh, thing. So it is throwing error when we enter date or month with leading zero. Date or month, yes. So actually, Deepak, date or month could not be zero, right? So it will give you error, right? So date is being expected from 1 to 31, and your month is between your first and your 12, right? So that is why it is throwing error. Understood? Okay, 03. Yes. So 03, it will not be given, I guess. So if you try to give it date, yes, leading zero or decimal are not permitted. Okay, so it is a syntax error basically. Okay, so basically, like it is giving you error, so it is saying that. So it is designed in such a manner you cannot give zero. Okay, so you just need to make sure that you don't give 03. Only 3 is allowed. Okay, so the leading zero in the decimal integer is not allowed by this library. Okay, so basically this library I have not designed it, right? If someone has designed it, and when he or she is designing it, so they have made some constants. Okay, so they have placed some constants. Then these constants you need to follow along with it. Okay, and make sure that if you are trying to give some date to it, and the syntax are proper, the validation are proper. If the validation and syntax are not proper, so it will give you error. Okay, so you just need to make sure that zero is omitted, and then you try to print that. Is this clear? So have you tried today's date? Okay, so we have tried to do the birthday date. So you can take the birthday date, and here is the today's date. Okay, so now I'm building some intuition. So you just need to have a program written in which you try to take the birth date of the user, and you need to compare it with the today's date. And from there, you just need to calculate what the age of the person is. Am I clear with that? So you just need to write the program, and here in the as we are I'm trying to explain you the slides and we are trying to do it. You just need to make a program, and like in the end I will try to check you need to take the date from the user, which is your birth date, and then you need to compare it with the today's date, and then you need to tell me that how many years that user is age is. Fine. Okay. So this is how we are trying to build some intuition in which we are trying to learn some programming. Right. So today's date, dot year, month, and day. Right. So as I already told you, so these are some of the things I've already discussed with you. That the what year is this, what month is this, what date is. Right. So we can perform some date time operations on the date, the basic this thing. Right. Okay. Yes. So now we try to do some practical. Okay. So I give you 5 to 10 minutes, right, to calculate the age using the datetime module and in Python. So what you need to do is, guys, okay. So here, uh, you just need to write a program where you will try to take the user date, this date, okay, in the form of some input, right? So you will tell the user that enter your age, enter your month, enter your year, enter your date of birth. So this is what we are trying to enter in the websites also when you are trying to fill a form. Okay, and automatically, like at the background, we they are trying to calculate the age according to today's date. Let's say you are trying to build some form which is your let's say some student registration form, and the age is permitted only 30 years. Okay, and if they are trying to calculate your birth date, and if the age is less than 30, so they then you can fill the form, else you cannot fill the form, so there is a error message. Okay, so similarly, at the background, they are trying to calculate your age, and if the age is permitted, so they will proceed, else they will not proceed. So this kind of application you need to do it. This kind of application you need to form it, in which you would take uh, the data from the user, and then you will write some functions, and on the top of that you will try to call that function, and then you will try to return the number of years, that how many years are there. Is it fine? Clear? Okay, I'll give you 2 minutes, and after that I will try to do it along with you. Okay, so that you can also think and understand like how we are trying to make a program. Okay, so I will also guide you step by step. Okay, first, what is the first thing you will do when you are trying to build a program or write a program? Okay, first you need to gather the steps. Okay, then you need to just write some functions. Then you just need to make sure that that function is being called, where that function is being called, and then if the error comes, then how to debug it. So this, by using this demo, what we are trying to do is we are trying to just write some Python program, and then we are trying to evaluate and try to debug also. So I'll try to write some steps, okay, and then we will try to make some. Okay, first step is take the input from the user. So the first question is that what input we will take? We will take the year, we will take the month, we will take the day. Okay, so three inputs we need to take it. So what function we will use? The input method or the input function we will try to use. So this we already seen in the previous session, right? So from the input we will take it, right? So when we take it, now we need to convert it in the date format, right? Using your date function, your date library. So this we already see birthday date, right? So you take the input, you place it here, place it here, and you place it here. The year, month, and the day, you make it a day birthday, right? So you now have your birthday date. Understood? Right? Right? So first you need to do it, right? So let me know once you have completed this task. So we will try to break down this task into simpler steps. First, we'll take the input from the user. Then we will try to convert this input into a date, which is your birth rate. Then what we will do is we will try to write some function where we need to calculate the age. Okay, calculate age, it would be a function, right? So in this calculation of the age, we will try to pass the birth date, right? Then this is your argument. Birth date is your argument, right? So in the function, we will try to pass this argument. And inside your function body, what we will try to calculate, we will try to see, or we will try to first uh, will store some current date, right? So current date also we have seen. So current date, date dot today. So this is our current date and this is your birthday date, right? So now simply you just need to subtract it and just need to evaluate how many years have been passed, right? Okay. So for that, what we have done is we have written basically take the input, you can divide it into a function also. This you need to make it a function also. So basically there are two functions which we have written. One is for calculation of your birth, calculation of your age, and another is taking from the input. Another is your taking the input, right? So these two functions, you first try to take the input, then you try to write some logic, and then you try to give the age, right? So now the thing is that I'll give you like, do you want guys time or let's give you 5 minutes, right? Start try to do it, and also like in the meanwhile, I'll also join you, right? I also start typing because what I want you is to think, right? Because the thing is that your brain should start working. That how if you try, I have given you some program. So this is a basic simple program. Okay. So in the industry, there could be complex program where you need to just gather the requirements. You need to take down these requirements, note it down, and then you try to break down into steps. That how you will try to formulate these instructions or requirements into program, right? So my task is that, like I have given you a simple program in which you need to take the input from the user in terms of your year, day, or month, and then you need to try to calculate the age. Simple, right? For that, you just need to make or break down that statement so that if any user try to write the age, right, he or she must give the birth date. He or she must get the age of it. Okay. So I'll give you 10 minutes, right? Or just try to start practice or try to do some programming and just let me know what are the errors and where you are stuck. Because this activity is really very needed because to understand you that how we are trying to do some programming and in later stages, so it will be a complex programming also, right? So just make use of your brains and try to just write or type and come with some errors if there are. Okay, it's fine, right? So now the input which you have tried to enter is in the string format, but we don't want to have it in the string. So what we'll do is we'll try to take typecast it to the integer part, right? So similarly for the day also, and for the month also, we just need to do it. So what I will say here, I will try to say month, then I will try to say it here day, right? And then I will say here enter the month and enter the day, right? Okay. So now what I will do is, so once it has been entered, so what I will do is I will try to have a date, which is your this date, okay, from data import, and then I will try to put the year and month and day here. Fine. Okay. So right. So this is your date, right? And I will try to find and convert it to the birth date, right? Okay. And then I will try to print it. Fine. Okay. So I hope this is clear. Okay, so I will try to enter it. Enter the year, let's say 2012. Enter the month. So I've entered, let's say, 4th, and day, let's say 21. Okay, so now it is giving me the birth date as 2012 for 21. Okay, so now there is another thing. So let's try to check for the errors also. Let's say I've tried to enter the month as 13 and day as 2. Right? Now what will happen? The month must be in the 1 to 12. So we have written the program. Okay, so this everyone has written it. But the thing is that we just need to provide some exception handling also, right? That that the thing is that like if you don't provide the exception handling or the thing, so it will try to give some error. So that error will doesn't look nice. Okay, so just we need to include the error also. So what I will try to do is I will try to include some try and accept block to it. So let us try to do some try and accept, and then I will say except exception, right? Okay, as e. Okay, then I will say print, enter the valid date, and right. Okay, so now let's try to check again. I will try to enter the month, right? So now it has say that enter the valid date month must be in 1 to 12. Okay. So earlier, what we were trying to see is we have seen errors. So error are bad. So if you are trying to showcase the error to the user, so this doesn't look nice. So let's say you are trying to go on the Flipkart or Amazon. Okay, suddenly some error pops in, right? So it will be a loss of the business for the Amazon guys, right? Okay, so I need to, and you will not ever go to that site again because you have encountered some error. So when you are writing some program, it must be validated and it must be exceptionally handled so that you will not get any error. Okay. So now what we have written is we have written with the try and accept block so that any kind of an error it occurs, then it must be handled properly, right? So this is very important in which you just need to enter the valid dates and it must be validated, right? So now we'll try to more refine this thing, right? So this code, okay, how we can refine this thing? So we can include a method. We can wrap this entire code into a method so that in future, let's say in future, some additional modification has to be done. So we will try to do the modification in this function only, right? So let's say I will try to get birth date. Okay, so try to make the function in such a manner that it will have some valid or meaningful name, right? Okay. So instead of print, I'm trying to return the birth date. Fine. Okay. So this we have written a function. Okay. So now what I will do is I will try to call that function get underscore birth date. Any doubts, any questions you are having, just let me know, guys. Okay. So let's try to now try to write the logic. Okay. So what is the logic is that first we'll try to make the today date. Okay. So what we'll do is date dot today. Okay. So now then what we will see, we need to calculate the age. Age is equal to today underscore date dot, dot year minus we are trying to calculate the birth date. So birth day dot year, right? So we are trying to minus it, right? So this it will give me the year, right? How many years have been passed? Then I will try to calculate the today dot right. So this is how we'll try to get the age. So here this, right? So now we'll try to get the age, right? So now these two things, what we will need to do is we will try to combine it in a single function. Okay, so what I will do is we will try to write a function and will say get age. Okay, and here I will try to give the birth date. Okay, then I will say return age. Fine, right? So now we have made two functions, which is your get birth date and get age, right? So here we are trying to pass this your birth get age and then okay. So now what we will do is we will try to write the main function, which will try to like use these functions, and then we will try to uh, call that. Okay. So what I will see is what I will do is I will say def main. Right. So here I will say birth date equal to get birth date. Okay. So then age is equal to get age, and here I will pass it your birthday. Okay. Then I will say print the age is right. And then I will try to run if underscore main. Okay. So have you understood, guys? So this is how we are trying to calculate the age, right, by using this inbuilt module. Okay. And we are trying to make this as a modular because we have written some functions, right? So here we can just try to include, or in future we need some modification, so we can call only this function or else this function. Okay, so this is how we can try to begin with small programs in which we can use it, and then we can just make the bigger and the complex program. Is that fine, guys? Yes. Def function. Which def function? I need to, because there are three functions. Deepak, I have written it. So one is this def get age, and this your get birth date. So what? First one. Okay. So this get birth date. So this is a function with which the definitions occur, and we have included some try and accept. So this try and accept is for the exception handling. If any error occurs, so we can catch this into this particular this thing, this exception, right? In the accept block. So this is your try block. This is your accept block. If any error occurs or any exception occurs in this block, so it will try to give. It will not give a exception. It will try to print this, enter a valid date, and it will give you that exception. Right? So now we have made some input statements where we are trying to ask the user with this year, month, and day, and we are trying to calculate the birth date. Okay, so we have used our date module, and here we have combined our date, year, month, and day to the birth date, and we are trying to return. Okay, then the second method is your get age, in which the argument is your birth, so we can pass that argument, and we are trying to calculate today date. And here is the logic where we are trying to calculate the year minus year, today's date, year minus birth year. And this, what we are trying to do is we are trying to compare, right? If the month and your birth month, right? If it is less, okay, so then we are trying to subtract it. If it is not, then we are not trying to subtract it, right? So this is the logic we are trying to follow here, right? Okay, and it will try to give me the age, right? Right? And these is the main function where we are trying to calculate the birth date. First, it will try to go into the get birth date. Then after that, it will try to get the age, So here it will try to go here. It will try to get the age, and from the age, it will try to print it. And this main function we have called in this particular block, which is your entry point, right? So this is the whole program, how it works, right? So you don't need to write your function, your program, right? You need to just break your program into three parts. First is your main part, which is your entry point. Then you are trying to write the functions, which is your this function and this is function. So this is the ideal practice where we need to learn programming in this manner. So every program has to be written in this manner only, guys, right? So this is like the ideal scenario, right? So this is the tuple basically, right? So this is the tuple. So this basically what we are trying to do is, let's try to break this down. Okay, right. Yes. So it is given as the false, right? So this particularly what it will only give you the age, right? So this we are trying to check like whether this date is greater than this date, right? So let's say your month hasn't passed it. Okay. uh, and like the days, like you are into same year, right? So let's say your 2016, right? So you have the 11th month and second, and here you are trying to pass 2020, and here you are trying to pass, let's say, 12th, right? So this it will try to compare like the 11th and the 12th, so whether it is being passed or not, right? So if it is not passed, then like you can subtract that day, subtract that month, right? So this is how the logic is being written. So this is being a tuple. It will try to compare this both these into these both these dates, the birth date and the month date, right? So you can just write it down in the piece of paper and try it yourself. You will try to understand it. Okay, fine. Okay. So I hope this is clear with everyone, right? So this is basically a program in which you can write the logic in this itself, and this is a module, right? Is the datetime module which you can see. Okay, so right. So now let's try to move to the another library, which is your numerical computing library, which is your NumPy, right? Okay. So NumPy is stands for numerical Python. Okay, so it is an open source library which is used predominantly with when working with arrays. Fine. So it uses arrays instead of Python list, which makes it more computationally efficient, right? So all we know that like we have been working with the uh, list, right? Python list, right? So Python lists are not very effective in storing information, guys. So if you have a long list of data, let's say data in terms of your numbers, right? So that you cannot store it in a list and you cannot perform any operations on the list. And it is computationally very inefficient and memory consuming. So that we will see practically also, right? But your numerical Python or your NumPy is very much more effective. And it also supports some algebraic operations which works with your 2D or 3D arrays, right? And the thing is that whole of the machine learning operations involves your metric manipulations. So your data is being stored into tensors or your arrays, right? In your TensorFlow, we call it tensors, and in your numerical Python, it is in the form of an arrays or NumPy array, we call it, right? So there you try to perform the metric multiplication, addition, division, subtraction, all these things. You can perform it very effectively, right? And it also offers some mathematical functions, your numpy.log, numpy.sum, mean, variance, right? So this we will try to see practically, guys, all these things, right? And your another library is your SciPy. So similar to your NumPy, there is an SciPy library, which is your scientific Python, right? And it also used to implement your scientific formulas. So let's say there are very complex formulas which you don't understand, and these are very challenging in which you need to perform it in terms of your Python. Okay, so their SciPy library already has done the work for you. Just need to call that function and then you provide the data along with it, and it will try to perform that multiple operations on that data. Right. Similarly, it also uses the linear algebra and the and also is very effective in optimization, image processing, and your signal processing. Right. So let's say you want to do Fourier analysis or 2D analysis, right? Or some kind of an image processing task. So SciPy library is best for you. Also in the terms of signal processing. So where there's a waves or the transforms in which we need to convert that into signal processing and do perform some analysis. So their SciPy library is also very much used. Fine. Okay. So this is the code snippet. So like we will not working on this code snippet. I will try to work with first NumPy and then Pandas, and then we will try to see it. So this is the basic structure. So this code is the basic structure. So how we can use this? So similarly, as we are trying to import your NumPy library and we are trying to import the inverse function from your SciPy library, right? Or datetime module. So similarly to this, so we can first define an array and then we can try to take the inverse. To understand this, first you need to have a look of this NP array, what it does, what it's trying to do. So that is why I argue that first we will try to see the NumPy array code and your these functions. Then we will work on this SciPy part. Okay. So this is just a demonstration or an explanation, giving you the gist that how this SciPy NumPy libraries are being used. Okay. So then another part is your NumPy. That is also an open source, which is built on the top of your NumPy, which is your Pandas library. And it is used to analyze your NumPy array or your NumPy array and analyze and manipulate that data. And it works with best with your tabular data, time series, matrix data, right? And the syntax which we can use is your this import pandas as PD. Okay. As is basically an alias. We can import pandas, right? Similarly, as we are trying to do is import datetime, right? As is alias a short form as PD, pandas data frame or pandas PD we call it. So this is the normal syntax in the industry and it is being widely used. Similarly, for NumPy also import NumPy as NP and pandas as PD, right? So this is the basic syntax. So pandas basically are well suited to perform the following tasks: your data import and export. Let's say we will try to see pandas import a CSV or an Excel. That Excel contains some data or some analysis. Then after that, when we have done the data cleaning or the analysis, we need to store the data back to our CSV. That also we can do it. Not only into the CSV, there are various file formats which are being provided by Pandas itself. We can do it in the TXT format, right? So we can have it in the JSON format, or so and so, right? So that we can do it effectively using your Pandas, and then we can use that thing or import that thing or export that thing. Then for the time series analysis, so that is also best suited. Your Pandas library is best suited, right? Right. So let's try to see a demonstration, right? So these code snippets we will be doing in the next later half, right? So I'm just trying to build an intuition that these are the some of the libraries which we will be working on practically, as we have worked in practically for this datetime module. Similarly, first we will see what are the methods, what are the functions that NumPy or your pandas give us, and then later on we will try to build a project in which we will try to see some CSV, read some CSV, and then we can export that CSV file and read it, right? So similarly we can do it. So this is a sample code snippet in which what we are trying to do is we are trying to import pandas as PD. This we are trying to import the pandas library as means alias PD, right? So this is your CSV file path. This CSV file path could be stored in your local system or into some server also, right? Then what we are trying to do is PD. So PD is your pandas dot. Dot means your function. You are using some power. As I already stated that every function, every this library has some functions. So function, it is a bracket. So function, the nomenclature is that you have a bracket, right? In the read CSV function, you are trying to give the path of that CSV file where you can read that CSV, and then you are trying to store that CSV data into some kind of a variable. right? So there the variable gets stored in the pandas or pandas data frame. We call it pandas data frame that we will try to see in future, and you can just make the analysis, right? So this is the simple code in which any file what you have, you can be easily integrated with your pandas data frame, and then you can just do the manipulations, your analysis, and then you can just store it and then analyze it, and then try to give some inference from it, right? So this is from the CSV file. Another is that you can have a read JSON function in which you have the JSON data. From there also you can do the similar operations. It is basically you are trying to read the CSV file by giving the JSON file or JSON file path, right? The functions are different, right? So this is the sample code snippet. We will try to see full-fledged is an SQL file. Can we import the Excel file? Yes. So Excel file also we can write. Similarly, for the read CSV, we have the CSV file. For the read JSON, we have the JSON file. For the read underscore Excel, we have the Excel file. So basically, the the different SQL files, different file formats have different functions that we will try to look upon, right? Okay, in the D, right? So we will when we are trying to work on this pandas model, so that there I will show you that how many file formats are being supported by this pandas. We can have the CSV also, we can have the JSON also, we can have the TXT also, right? And we have can have the XLS also, right? So that also data it will automatically import it. Understood, right? Then there are stats model. Stat model is basically it allows the estimation of the statistical models and performs statistical tests. So there are some statistical tests needed to perform on the data, right? So that we will understand and that we will see in the stat models library. That the some of the important features include your graphics, your time series, your ANOVA test, linear regression, right? So these are some of the models or the machine learning models we call it, where we wanted to perform some analysis on your data and perform that algorithms onto the data. Okay, so these algorithms are complex, and someone has written this and made a library out of it, and you can just call that library and use that, which makes it very effective for you because you just don't need to understand the maths behind it. You just need to call it. But the only thing you need to know is that how these models are working, the theory behind it, like what exactly ANOVA does, what does linear regression does, or what does statistical test does, right? And where we can these apply these models or these algorithms onto our data and on what purpose. This only information you need to know it. Once you know this information, so you can just call that library and use that. So now, guys, what we are trying to use it, we are trying to do the practical implementation of these libraries and using your Python, right? Then come the third part, which is your data visualization library. So data visualization libraries, it is very effective. As I already told you that you need to present your data in terms of your pie charts, graphs, histogram, right, and scatter plot, right? And these applications can be integrated with your GUI applications such as your Tinker, right, Qt or GTX, right, or WX Python, right, where you can effectively show these data as in the terms of your story points. Story points means visualization, right? So let's say this is some kind of a data in which this is the number of average income of your students, or this is the number of students, right? And then you can see that the average falls something like 20,000 or 2,000, right? So something like that, right? So this is very effective in terms of your explanation. And Seaborn is another high level interface which is very attractive. So these libraries, Matplotlib is not very though interactive, but Seaborn is a higher version of it, which gives you a very attractive visualization. Right? Okay. So now let us try to see the official documentation of these libraries. So which is your NumPy. Okay, I'll also open the pandas also. Then you have your Seaborn and your Matplot. Right. So let's try to understand what is the or see one by one, right? In order to understand these things, right? So let us try to first go with the NumPy, right? So NumPy stands for numerical Python, what I told you. So it is very powerful in n dimension array, and it is like very versatile, right? And it is open source, easy to use, right? And it is optimized with the C code, okay, right? And you can see that. So there are specific scientific domains, array libraries, data science. In data science, you can have the extract, transform, and load. Here you can have the pandas, right? Intake, py janitor, exploratory analysis, which I already told you, your Seaborn, Matplotlib, right? And your model and evaluate, which we have your Skykit, stats model, Spacey, right? Spacey is widely used in your NLP domain, right? And reports in dashboard, we have a dash, panel, volia, right? So these are some emerging packages which are coming to the market. Right. Earlier days there were only NumPy, Pandas, and your Matplot, but nowadays like there are extensive use of these libraries have been evolved in the market, and you can use and explore those things. The thing is that if you try to drive a Maruti car, you can drive any car, right? If you know these Pandas and NumPy, so you can just easily go to these Dash, Panel, or Volia, or any other library, and the basic concept remains the same. Understood? Okay, right? And these libraries are used for specific purposes. Let's say for data, for high data volumes. So Dash and Ray are designed to scale, right? Stable deployments on data versioning use your DVC, right? So these are some advanced concepts. So I think like these you might not be able to grasp it, but in the later stages, so you will try to see that these libraries and these frameworks are very important, right? In terms of your machine learning, right? So these like how these data you can see that. So here it is trying to use your libraries such as your Skykit, SkyPy, right? And deep learning frameworks such as TensorFlow or Python, right? And there we are trying to visualize this data. So this you can see that how we are trying to visualize this data in terms of your complexity, in terms of your what data points are in contrast reference to each other, right? So right, so this you can see that. Okay, so another library which we call it like Pandas, so which is very fast and flexible and open source for the analysis and your manipulation, right? Okay, right? So you can go to the user guide API and just you can see that like these are how the data frames, right? Grouping, shaping. So these all things we will try to see in practice, right? As the time permits and what are the basic things which we can handle effectively, we can use it. So I will try to teach you how to drive a car, right? So I will try to look upon basic operations of Pandas or your NumPy or your Matplotlib, and then rest you can just see and explore of yourself, right? So these are various like you can see that operations which we can perform, and it is increasing day by day, right? And like these guys are being according to the need, according to the data, they are trying to integrate with this pandas because this library is getting expanded day by day with terms of data and terms of your ease, right? Okay. Then we have the C1. C1, I told you that this is also a graphical data visualization library, and it is very what we call a beautiful library in which you can see different colors and visualizations, right? Okay, so it is basically based on Matplot only, right? And but it has got some rich, rich what we call visualizations, right? Okay, so here you have this matplot is a basic library in which if you wanted to use that how we can do the data analysis. So this is also very effective to use, right? Similarly, your SkyPy, right? That is also very effective for scientific calculations and algorithms, right? And your this is your Scikit-learn. Scikit-learn is another machine learning library which will use your classification, regression, your clustering, right? And your model selection, pre-processing. So these are basically uh, libraries based on specific operations. For the machine learning, there is Scikit, and all the machine learning algorithms come fall under this Scikit learning. Okay. So basically, what I'm trying to tell you, so these are some tools, Okay, so let's say you try to go for a data science, right? And these are the tools which you really need to understand first. That is why we are trying to understand NumPy, then Pandas, then Matplotlib, and these SciPy and your scientific scikit-learn libraries we will talk about in this course, in this whole series, right? 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 Then we have the stat model. So that also we are trying to have your data set and we are trying to get the summary. So this like so here the regression summary, the R square result, F statistics, log likelihood, right? So these all the things we are trying to see here, right? What is the standard deviation, right? So these are some of the concepts. So first we'll try to understand the concept and then we will try to use this library. Yes. So, Deepak, this is very good question you have asked. Like, how will we know which tool to use and what for what purpose? Yes, actually. Okay. So let's say the thing is that like let's say you have large amount of data to be transported from one place to another. Okay. So first you will see that how large is the data and what like transportation mechanism that you will use. Okay. So this you will see that okay, if the data is small, so you will use a car. If the data is large, you will use a truck. So similarly, so first you need to understand these libraries. So these are the basic libraries which you need to understand. Okay. Let's say you are trying to do some NumPy operations, so then NumPy arrays and NumPy operations that you need to understand. So that is what we are trying to learn. First, you need to learn this library, understand this library, and based on your problem statement, then you will automatically decide like, okay, so these learning algorithms we have, 7 to 10 machine learning algorithms we have. So according to your problem statement, what machine learning algorithm best fit for it, so that you will try to use that, and you try to like solve that problem statement. So this is how you will do it. So the thing is that first is you need to have an formal education or formal study that how what are these tools that I will be required to become a data scientist. Okay. After only if you try to learn that tools, then you will start working on it. So I hope Deepak you got this. So shall we move to the next part? So now what we will cover? So we will try to see the matrix manipulation by using the one file. Okay. Okay. So is everyone ready? Yes, no? Has everyone arrived? Yeah. So is my voice yeah. Now can are you am I audible? Deepak, just confirm. Okay, fine. Okay. So let's start with the second session involving your matrix uh, multiplication manipulation by using your NumPy. Okay. So what we have done, a quick recap. So datetime module is an inbuilt library in Python which gives us the manipulation of the datetime. Okay. So as we already seen that Python offers numerous libraries for data manipulation, numerical computation, your data visualization, which includes your NumPy, Pandas, Matplotlib, Seaborn, SciPy, and your stat model. Okay, so so Deepak has already asked this question that like what libraries and in which point of time we need to use it. Okay, so basically these are some tools, right? So every data analyst or your data scientist is being working on these tools and the library. Okay, so until and unless you don't understand these tools and don't know, so you cannot tell that for which problem statement, for which problem, right, these tools has to be used. Okay, now let's say we have given you a problem statement, right? So the problem statement is that your monthly spending, right, is being categorized into categories such as your food, your bills, your fund, travel, and that has been categorized, and you make a spreadsheet every month in which you try to do some basic uh, analysis that on which category I have spent most of the items, or I have like purchased most of the the expenditure is more. Okay, so So what we are trying to do is, let's say you have a spreadsheet in which there are five categories, let's say food, bill, travel, and fun. And monthly you are trying to write some expense based on that particular category. And then after that, like you try to analyze it. Okay. So you are trying to analyze, but you need some tools to analyze it. Okay. So that is tools we are working on. Okay. And then after that, you can just try to make sure that whether this expense is really needed or not. Should I cut down my expense into some areas? Okay. So let's say I have like spent much of the my income in your travel and fun, right? In food and bills, it is still pending and it is showing in negative analysis. So there you can just try to uh, do some analysis, and based on that analysis, you can just spend your saving effectively. So this is the real life situation in which all of us can do a simple analysis using these tools, right? So the learning objectives of this session is that we will try to see the arrays and your NumPy operations for data manipulation in complex and analytic tasks. And onto that, we will try to apply some mathematical and arithmetic operations, right? To to get that operations quickly handled, and that will be done, and the outcome should be some kind of an analysis and interpretation, which will try to effectively run our business, right? Right. And we will also try to experiment with array indexing and slicing, that we will try to see in terms of your data extraction and alteration. So we have also seen the indexing and slicing in your data types in Python also. The concepts remain the same, right? Is that like how you try to work on your large scale array, and which fields you need to slice it and which fields you need to index it. Okay, right? That is very helpful in which where you are trying to work on the larger data set, and only a small portion of data needs to be changed or altered. For that, you need some data indexing and slicing. Okay? Then the next part, we will try to also understand the NumPy, which will try to read the data from files, and it will also streamline the process for data storage and retrieval. So not only in Pandas, we can just effectively use our data sources such as your Excel, your CSV, your JSON, but in NumPy also we can use some of the file formats in which we can try to read it and try to process it. Hmm. So this we will try to understand. Okay. So arrays. So can anyone tell me that what are the arrays? What is exactly definition of an array? So what is an array? Set of values. Okay. Set of values could be anything. So the can you just more refine this? Like what is an array? Set of values stored in continuous similar data types. Yes, yes. Continuous memory location. Yes, Aniket and Deepak. You are all correct. So what are arrays? So array is a collection of elements which could be identified by an index or a key, right? And that stores multiple values in a single value, right? Which make the management of a larger data set easier. So basically, the array, what we call is array is a collection of similar data types, we can call it. Okay, so that is the naive definition of an array, right? And that array can be identified by an index. Okay, because like in the list also we have an index. So similarly, the concept of an array, we can leverage it in the list format also, but list in which we could have the similar data type also or dissimilar data type also, or we can have that both, right? Okay, so any kind of a data type can be stored in a list, but array is consist of an similar data type or a values which have the sort of similar data type. Okay, so the array which we store are being characterized uh, by fixed size, by the homogeneous, and by the index also. Right? As I talked about, the fixed size that can hold the fixed number of elements, right? And the homogeneous data type could be in the array must be of same type. Okay, and that item which we are trying to store it in an array has a specific position, and the index it has been ranging from or starting from 0. Okay. So basically, what are the characteristics of array? It has to be stored in a fixed size length. Okay. And it has to be homogeneous data type, means that the similar data type can be stored in an array, and also it consists of an index which is starting from 0. Okay. Index always starts from 0. Okay. So these are the characteristics which we have already learned in the list, right? Okay. Right. So that also properties holds inside your array and your list, right? Okay. Now we talk about the types of arrays: single dimensional arrays, multi-dimensional arrays, and jagged arrays. Okay. Single dimension means list of items of the same type are stored in a linear format. Okay. So we have a 1D array. 1D means single dimension, as in case of a list. Okay, so list what we saw, we have a list of items in which we are trying to store a stack. A stack means a stack operation which we store items one after the other. Right? The recent items comes at the top and the later items are at the bottom, which is a single dimensional. Multi-dimensional 2D array. Right? Rows and columns could be a 2D array. Right? And it could be your n dimensional also, maybe a 3-dimensional, 4-dimensional, 5-dimensional, 10-dimensional. Okay. So that dimension is basically harder to explain if we talk about, because we live in a plane which is a 3D plane, right? But if we talk about a 5D plane or 6D plane, it is very difficult to imagine. But we are trying to store that information in terms of an array, which is a multi-dimensional array. So that we will see. N-dimensional we call it, multi-dimensional we call it. Okay. And jagged arrays, which each row may contain different number of elements, right? So so every row has like in the case of your n-dimensional, like the 3 cross 4 or 4 cross 2 or 2 cross 3, the rows and columns are fixed, right? Right? 2 rows, 4 columns. But here, 2 rows, 4 columns, and every row or every column may be different oriented or different, having different size. It may not be 4, it may be 3, it may be 2, it may be 1, so on. So that we call it as a jagged arrays, right? So these are the type of arrays so that we will see in uh, your NumPy. So NumPy is basically a NumPy array, we call it. Understood? Okay, right? So now we'll talk about matrix. Okay. So matrix is a array which is used to represent a mathematical object or a property of an object, right? So that matrix is arranged into a row and columns, right? So in your fifth and sixth grade, we have used the terms as metric manipulations, metric operations, right? So in terms of array also, we have some kind of an matrix expressions that is being represented data in the format of row and column. Okay, right? And then it includes some arithmetic operations such as your metric multiplication, addition, scalar multiplication, subtraction, right? Okay, so these are some kind of an operations which we have already seen. So addition and subtraction we have already seen. But in terms of metric multiplication, scalar multiplication, right? So these you will see, right? So these can be easily done by using your NumPy arrays, right? Okay. So now we'll move toward the fundamentals of NumPy. So we also, as we already know that it is a numerical Python and it is free and open source and used primarily for mathematical operations in your data, right? Okay. So what is NumPy? So NumPy is efficient multi-dimensional container for generic data, and it uses arrays instead of Python list. Okay. So the advantage of using NumPy using your Python list is that NumPy arrays are fast, lists are slower. Okay. And the another advantage of using your NumPy array is that you can perform metric multiplication, addition, subtraction, or arithmetic operations in a very effective and a computational manner, as compared to your list. So that holds lot of memory, and it has additional challenges. It cannot store large amounts of data. But NumPy arrays can effectively work because the underlying principle of your NumPy array is your C, right? So, so the underlying, because like in the top of that Python wrapper is being built where you can use your NumPy array. That is why it is very effective for data manipulation and handling, and for computationally also it is very efficient. Fine. So NumPy is effectively used for processing of large data sets, and it is widely applied in the fields such as your data analytics and your scientific research. Okay. Okay. So NumPy arrays which we call it as n-dimensional. N means n could be a number which could be one-dimensional, two-dimensional, three-dimensional. So the n-dimensional means that it is trying to stack your array into multi-dimensional. Let's say this is your uh, first matrix, so green one, which has 3 rows and 3 columns, right? Another, you have another array, which is array 2, which is in yellow, which also consists of 3 rows and 3 columns. And another, which is in this orange, which is your 3 rows and 3 columns. So together they combine and form a multi-dimensional array, right? Okay, right? So it is like that, 3 rows, 3 columns, and 3 dimensions, right? Right. So third is your how many dimensions? It has 3 dimensions, and in one dimension you have 3 columns and 3 rows. So this is what the implementation says in your NumPy array. So here you can see that how your data is being stored, right? So this considered in this manner. So this is the data of one of the customer, right? This is the data of another customer. This is the data of another customer, and likely it could be end data which could be stored in a effectively in a NumPy array. And now you can think about it that how you are trying to store that data, and when you are trying to store that data, and if you wanted to do some operations on it, how fast and effective would be. Okay, if I tell you there are 10 CSVs and you need to give me that all those information from that 10 CSVs and find me that the number of customers who have purchased the wheat or rice in your month of January or February, right? So it is very difficult for you to just dig that information from 10 CSVs. But when you are trying to put that information into your NumPy and leverage it using pandas and data frames and your this thing, it will be very fast and effective, right? So now you are trying to see the real picture that how the data is being stored, and from that storage, how that effectively you can leverage that information and use it for the analysis part. So now let's try to do the practice, right? Okay. So what I will do is, so let's guys try to open up your uh, Jupyter notebook. So let's try to create a one-dimensional array, right? First, okay, 1D array, we call it. Okay, then we will try to effectively create 2D, 3D, and so on. Okay, fine. So let's try to first import this library. So what we will try to do is import numpy as np, right? So as means alias. So now everything would be referred as np. Okay, so let's try to do a dot and try to see. So now you can see that. So these all functions you are trying to have, right? So they are very large in number, guys. See, okay, some of these having a class, module, function, right? And then right, copy, conjugate, concatenate, compress. So some of these are modules also. Okay, right? So this is a very heavy and a powerful library. Okay, but you cannot just try to memorize and try to see all the functions and the methods. Even I cannot also teach you. And if I need to teach you each and every function, then that it would take like some months to complete this, right? Okay, the basic thing which you need to understand is that, let's say you are trying to drive a car. Okay, whether you know Maruti, like you can drive any high tech or a complex uh, vehicle, like which consists of some lot of functions. Okay, if one function you try to understand, then you can just see and search and go through that another function, and then you can use it. The only basic thing is that like how you are trying to use this library for your own purpose. And even I also don't know each and every function. Okay, when it comes to the practical implementation, when we are trying to work on some data or problem, so first we try to see that is this NumPy is using any function, and if NumPy provides some kind of an function to it, then we can use it. Else we try to find like we can write some our own function and then try to leverage it. Okay, right? So you can see that. So this is a long list, and we cannot use all these things in practice. But the thing is that we can just use and we can just understand like what this library works do, right? Okay. So let's try to use the first function, which is your numpy.array. Okay, so here we are trying to put some random number, and let's say array at 23. So this is your let's say a single number. We are trying to convert this to a numpy array. So let us try to uh, name it as array 1. Okay, I'll try to delete this. It is creating confusion. Okay, right. So now I will try to print array 1. So now you can see that it has given us the array 1. Okay, if I try to put the type, let's say type, I wanted to check what the type of this array is at. So you can see that numpy.nd array, right? So this is your numpy. So we have converted your number to a numpy array. Okay, so this is creating a scalar value. So this we are trying to give a scalar value to our numpy array, and like it has been converted effectively to the numpy.nd array data type. So this is basically a data type. As we have seen in Python, that we have a list data type, we have a tuple data type. So similarly, we have converted our one single element to a ND array or a NumPy array. Right? Similarly, we are trying to create a one-dimensional array. One-dimensional array. So let's say array2 equal to np dot array. Here we are trying to provide a list. So list is a one-dimensional. Okay. So this is basically a list. So now this operation, what it is trying to give us, we have a list of elements and we wanted to convert this list into a NP array. This we are trying to effectively calculate, convert. So let's say I'll try to say print array 2. So this is your list. So it will try to give similar to a list, right? But if we try to check the type, it is NP NDI. Okay. So now the question arises. So by seeing these two things, right? This is also a list and this is also a looks like a list, but it is not a list. It is an ND array, and that was a list. Okay. So we have seen that like the list are slow, but your NP array or ND array are fast. Right? Right? How we can see it? Like until and unless you don't know, like you don't know the difference, that how you can just come to the conclusion that why this are uh, slow and your ND arrays are faster. Okay, can we just have a practical demonstration of it? Yes, of course we can have. So let us try to see. Let's say I will try to uh, make a list. I will say range, and like let's say a 10,000 objects. I will try to have it. So you can see that I have made a list of range of 1 to 0 to let's say 1000, right? So this is a list, right? Okay, so there is an time module, time it module in Python, right, which will try to give you the time, and I'm trying to sum this list and it will try to give me the time. So what it will has given me, So I'm trying to sum this X, which is a list, and the time taken to sum this list, how much time it will take. So it is taking about 2.75 nanoseconds or microsecond. I guess it is microsecond, right? Okay, time it is taking, right? So we are trying to compute some operations on your list and trying to calculate the time on it. Okay. The similar part, what we do, we will try to compute the similar operations on a ND array, and also we will try to see the time. And we will try to compare which one is faster, and then we will try to a conclusion. Okay, because we wanted to check. So as in this deck says that the ND arrays are much faster for operations, then how we can just see. So this is the practical demonstration in which we are trying to see that why ND arrays are powerful and effective to use. Let us try to convert this to np.array, and here I will try to give the X, which is your list, okay, and converted it. So I will try to say that time it, I will include percentage, and I will say that np.sum. Okay, so I have used an inbuilt function called np.sum because for the np for the nd array, your normal sum won't work, because like we have converted it to NP array, and NP operations will work. So I'm using your inbuilt NP operations to work on it, right? So I will try to put a Y to it. Okay, then we'll try to check. Yes, right. So now you can see that it has taken 1.23 microseconds, right? So it has given the 7 runs, right? And the 7 runs, and in each run there were 1 lakh operations, 1 lakh loops for it. But here you can see that the loops has increased, right? And the time also took it slow, right? So this way we can prove that like your ND arrays are much computationally faster, right? And also effectively storage also. Yes, Deepak, what do you want me to repeat? Okay, so what I have done is like I have tried to make a list. Okay, this is a list, and from in the list I have tried to add this list data, right? Sum is basically an inbuilt function where we are trying to add the elements of list, and we are and this operation, how much time it will take. So this time it is an inbuilt method in Python which will try to give that how much time that this particular operation is taking. And now we can see that when we are trying to have a list and we are trying to use a sum function, so this took about 2.75 microseconds, right? And the similar operation we did it on the NumPy array. We are trying to convert the list into a NumPy array, and using this same time it operation, we are trying to calculate the time. But here the operation was np.sum instead of sum, which is numpy.sum, right? And it took us lesser time as compared to the time which the list operations took. So this is a smaller number. It could be ranging to 10,000 or a lakh or a million, right? But here you can see that small demonstration in terms of that how why this NP are faster, right? So now what we have done is we have tried to create a ND array which is your one dimensional, right? Similarly, we can create a 2D array also, right? How we can create a 2D array? Let us try to see it. So array 3. So you can see. So this is like if you try to give one bracket. So this is your one dimension. But here the brackets are two. So in the end also the brackets are two. So this is the how you can see that whether your data is two-dimensional or three-dimensional. So by using this or analyzing this, you can easily see. So in this two-dimensional data, right? So you have your 2 rows and 3 columns. Understood? So you have having your 2 rows and 3 columns, and then you are trying to convert your data into your NP array right here, right? So let us try to see NP array 3, right? So this we have tried to calculate it, right? So let's say dot, right? In your this NP array, in your ND array, So you can just see the uh, n dimensional, nd, right? So n dimensional or nd will give you the dimensions, right? It will give you dimension that it is two dimensions, right? Let us try to see array 2. It is one dimensional. So array 2 was one dimensional as we already seen. So this is your 1D array. So this is your 2D. Okay. I hope everyone is clear. Okay. Right. Okay. So let us try to see one array. Let's say, so this is our 3D array. So let's say I will try to see a 3D array. Uh, okay. And let me copy it. So basically, this is a 3D array, right? So in this 3D array, so you have one, two, right? So this could be seen in this manner. Okay. So, right. So this way you can just interpret it, right? So let us try to see the shape also of this NumPy array. So NumPy array dot shape, right? So this means that 2 is to 2, 2 rows, 2 columns, and 3 are the dimensions. 3 dimension it is having. Fine, right? So this way you can just interpret it. So the third column is for your dimensions. How many dimensions? So here, if I try to see the array 2 dot shape, you can see that it is your one dimension only, right? Okay. And if I try to see your array 3, it is 2 cross 3. Fine, right? So this way you can just interpret, right? You can convert any of the data into your n-dimensional space or n-dimensional array. Fine. Okay. Now another thing is that you have your data and you wanted to give your desired number of dimensions also. That also you can do it. Let's say I have a list and I wanted to convert into a n-dimensional. Let's say I will have array underscore 5 is equal to np dot array, and I will try to provide you a list. Okay. And in the bracket, I will say and dim and equal to, I will say 5. Right. So you can see that 1, 2, 3, 4, 5. 5 brackets are there. This means the dimension is 5. Okay. So this way you can convert any of your data type into any dimensions. Right. Okay. Yes. So Deepak, these braces. Okay. So these braces is basically how you are trying to store your data. Okay. So basically, like as I already explained you in this thing, right? So this is the data of one customer. This is the data of another customer. This is the data of another customer, right? So you wanted to store each and every data in the form of one data. Array one consists the information of one customer. Array two contains the information of second customer. Array three. So now in this part, let's say this is the information of first customer. This is the second customer. This is third. This is the fourth. So there may be n number of customers. So in n number of customers means n number of dimensions. Okay. And then you are trying to convert into an NP array, and then you are trying to, let's say, store that information and process it effectively. So that is why there is a need of storing that information. And dim. Yes. So and not and dim. I was also trying to, is it nd min? Nd min. Okay. So it is nd min. I also got the same error. Okay. Okay. So this is good, right? So you are trying to learn it. Okay, so there could be your purpose was right, that and and dim, right? But here they have used another nomenclature. Okay, in that way, like what you can do is just put a this comma, question mark, and then shift and tab. Okay, so here you can see the doc string. Okay, so now here you can see that the in your Python data type doc string, so the doc string was less, but here you can see that. Okay, so there each and every explanation has been effectively explained. Okay, so they have also given you examples also. Okay, fine. This way here, right? Ending, right? Okay. So basically, like this like you as I already told you, you cannot learn each and every or cram each and every method or function. But what you can do is just understand the concept, that why we are using, on what purpose we are using, and if we wanted to look at like how we can use it. Okay. So this also says that C also empty like ones like zero likes returns the array of zero with shape and type. If you wanted to create a element or a zero shaped array, so and np dot zeros, np dot ones, so that also can be used. Let us try to see that array 5 or say array 6 is equal to np dot ones. Okay, right? So let us try to first see the documentation. I also don't know, right? So we need to provide the shape. Okay, so np dot 1 5, np dot 1 5, right? So np dot 2 dot 1, right? So only it will try to create the arrays of let's say ones with the shape, right? So this is also very important when you're trying to create it. So let's say we try to give it a shape equal to, let's say 2 cross 1, and we'll try to give it. So we'll say print array underscore 6, right? 1 cross 1. So 2 cross 1, right? Right? So this way we can do it. We can also give it like something like this. Now you can see that the dimension has been changed, right? So this is a basically we are trying to learn Python and in this properties, like what are properties are there. Okay. So now the quick check how to create a NumPy array from a Python list. So what is the option, guys? A and NumPy dot array, NumPy dot create, NumPy dot convert to array, or NumPy list to array. So quickly, guys, tell me how to create a NumPy array from Python list. Yes, A. A is the answer. Right. Okay. Right. So important attributes. So attributes are the keywords that store basic information about the array. So we have the ND, NDIM. We already seen that shape. So item, size, data, dtype, and size. So these are some of the important attributes. So let's try to see quickly one by one. Okay. So if I try to see array, any array you take two, right? Array two is not defined. Array underscore three, right? So okay. Rod size. So size is 6, right? So size is 6 in bytes. We are trying to calculate here the size of, we try to take the D type. So D type, it is int 64. So all the elements in this array is of integer 64, right? Okay, so we can also convert this data type to some other floating point values also. Yes, Deepak, scroll the notebook above. Uh, one second. Yes. However, I will share this notebook. Okay. Right. Okay. So this is your D type. Uh, then your item size, and item size, let's try to see the item size also. Array 3 dot item size, right? So 8 is the item size, right? So what is item size does? Let us try to see it. Item size, right? Uh, it is your, okay. So this is basically we are trying to give the item size, and okay, then data, right? So this is having some kind of an information that this data is being stored at this memory location. Right? Okay. So, however, these functions you might not get encountered, right? So, because and name, shape, and your d type. So these are all the attributes which you really care about, right? So this is for educational purposes only, that how the data is being stored and what data size is present in that data, right? Okay, we already covered that how fast is that. So if you like uh, can also see that why lists are complex to storage also, right? So they take more space to storage as compared to your NumPy data type also, right? Okay. So now we'll take the number of axes or dimensions. So I've already told you. So this is your axis. So here axis 0, right? Row 1, row 2, row 3. This is basically your axis 0, and this is your axis 1, right? The columns, we try to iterate through each and every column, that is your axis, right? Okay. And these iterations uh, through your rows, right, is the axis 0, right? Iteration through your rows is your axis 0, and through your columns is your axis 1, right? So this way we can just uh, talk about it. Shape, we already seen that, like it could be a 2 cross 3, it could be a 3 cross 2, and it provides us the length, right? That it has 2 rows and 3 columns, and it is a tuple which will provide you that the first element consists of the rows and the second is of the columns, right? Size is the product of the shape, that is 2 cross 3 or 3 cross 4, right? It will give you the size, that how many elements are present, right? Right? And the data type, as I already told you, could be your integer 32, integer 16, or floating point values. And these are the data types which is being stored in your NumPy, right? Ndim slide, okay, yes. So this is the ndim slide, which provides you the number of axes, dimensions of the array, right? So two-dimensional array has two axes, which consist of arranged in rows and columns. So the axis 0, which is basically iteration through your rows, right? So rows, along the rows, you are trying to iterate, there's the axis 0, and along the columns, which is your axis 1. So this way you can just interpret it, right? Then item size shows the length of one of the item size in bytes. So as I already told you, that for the different floating point, right? So it is been trying to calculate for the float 64. Like we are trying to divide it by the 8, right? And the size is 8. If the elements 8 is the number of elements which are being stored in an array, and the type is your floating point 64, then 64 divided by 8, and the 8 is the item size. And if the item size is complex 32, and the items are the complex 32, and the item size could be 32 divided by 8, which is your 4, right? So this is how you are trying to store the items in your get the item size, then your items are being stored in your numpy array, right? Okay. Important attributes, right? So we see the shape, size, and storage, and your item size, and right. So these already we have seen. Okay. So I guess you are also done this activity. Okay. Then the another aspect is that reshape, right? You wanted to reshape your data into some other type. Let's say it is 2 cross 3, you wanted to flip it to 3 cross 2, right? So based on that dimensions, right, the underlying dimensions won't change. Let's say 2 into 3 is 6, 3 into 2 is also 6, right? But if you wanted to change it to the 8, right, so the 8 won't match these items and you cannot reshape it. Okay, so let us try to see the reshape also. So I'll try to see one, what is the okay. So let us try to see this numpy array. Okay, so dimension is 2 into 2 into 3. So 4 3 are 12, right? Okay, so what I will do is I will try to say reshape 4 cross 3, right? So now you can see that the data has been stored into the 4 cross 3, right? The same data, right? This numpy array, right? Which is having the dimension as 2 into 2 into 3 has been reshaped to this way, right? So now the another important thing to understand and to see is that in this reshape, you are trying to reshape, but the original data still remains the same, right? The original data still remains the same, right? Until and unless you try to give it that is the reshape NumPy array, right? Then and only then this change will take place, right? So now from this 2 cross 2 cross 3, we have effectively reshaped to 4 cross 3. Okay. So let us try to do some operation in which it doesn't match this reshape with your 4 cross 4. Let's say I want to do it 4 cross 4, right? So it has given me the error that cannot reshape an array of size 12 into the shape of 4 cross 4. So 4 cross 4 is 16, but we are trying to reshape into a size of 12, which is not possible, right? So this we need to make sure that our data could be only reshaped into that format in which we have that dimensions multiplied. Understood? So that reshaping is important. So item size. So item size, it shows the length of one of the elements in bytes. So let us try to see the item size. Okay. So let's say this is your, I'll try to take a simple example, array underscore two, array under, right? So this is your normal array, right? Okay. How many items are there? Four items. Okay. If I wanted to see item size, okay, it is eight. Okay. So basically, first we try to see it, how this eight occurs. Let's say I will try to cover D type, D type. Okay. It is 64, right? 64 divided by 4. How many items were there? 64 and 64. So items are four. Yes. So four items are there, and every item is taking 2 byte space, right? And then we are trying to divide 64 divided by 4 twos are 8, right? Now we are getting 8, right? So this is how we are trying to calculate the item size. So every integer type, it is taking 2 bytes. So that is why 64. And we have four items. 4 into 2 is 8. And then we are trying to calculate this 8. So this is how it occurs. So I think you understood, Deepak? Yes, no? So now we'll begin with the arithmetic operations. So do you want me guys to cover these operations in this class or next class? So let's try to see some operations such as NP, add, multiply, divide. Okay, or we'll stop here. Okay, so next class. Fine. Okay, so what we have covered today, let's try to give an quick recap and overview, right? So let's try to take the practical overview of this. Okay. So today we started with our session with our the import modules, which is Datetime, and we have seen that how we can write a effective program using our import module, which is your Datetime, right? So we have used a simple program. Then we'll try to cover your NumPy. So NumPy we have started it, which is a numerical Python, and it is very effective in handling large scale data. So we can convert your operations into ND array, which is your list, and that list could be converted into NP array. So there we have seen that how this NP arrays are very efficient in terms of computation. So we try to use some NP array and try to see these operations and seeing that NumPy array is faster than as compared to your list. Okay. So then we have seen your ND dimension, which gives us the dimension. Then shape, it also gives you the shape. Then your once it will try to create your n dimensional array with your only ones with only ones, right? And D type and your data and your and size, right? So we have seen that, right? So this is we have seen that, but in the next lecture we will try to cover more in depth operations of your NumPy, and then we'll touch upon your Pandas also, right? Okay. So let's meet tomorrow and continue this session. And before we end the session, please guys try to rate me 5. And in the next session, we'll try to see more practical implementations of this Python, NumPy, and your data science applications, right? Right. Okay, so the array makes the data management very easy for the larger data set, as we have already seen in terms of your NumPy arrays, right? The characteristics of an array, which is a fixed size, homogeneous data type, and indexed, right? It's a fixed size which can hold a definite number of elements. Homogeneous, which can hold the same data type, and index, it is known to be a specific position which is starting from the zeroth index. Yes, Deepak, you have any questions, Deepak? Yes, we'll do that again. We'll do that again. A program. Okay. Right. So types of array, then we have the single dimensional array, multi-dimensional arrays, and jagged arrays. So single dimension, which are stored in the linear form, and multi-dimension uses more complex data structures like matrices, and jagged array, which consists of rows which could be different, right? Okay, so then we talked about matrix, which is a rectangular representation of rows and columns. Okay, then some of the operations of matrix, which include your matrix multiplication, addition, scalar multiplication, subtraction, division, right? So this we will try to see today, right? So this topic we were trying to focus, and we see that how we can create a NumPy array, but the matrix multiplication, matrix operation we haven't seen it, right? So today we will work upon those and see the practical implementation, and we'll do the hands-on practice on these operations. Then we touched upon fundamentals of NumPy array. So NumPy array is a free open source library which is used for designing operations in scientific and engineering applications, and it performs operations on multi-dimensional arrays and matrices. Then the advantages of NumPy, it is considered faster than your Python list, and it also saves a lot of memory as compared to your list, right? And lists are much slower. We have already seen a program in which demo in which we see that like the NumPy operations are really very faster as compared to your Python list, right? And the processing of your large data set also in the case of data analytics and scientific research, so NumPy is very essential, right? Arrays in NumPy, everything is been associated as an array in NumPy, right? So we have the rows, a tabular format in which we have a rows and column structure, and this could be seen as a multi-dimensional system in which the particular structure could be repeated n number of times. Okay, which we call it as an ND array, n-dimensional array, right? Okay, so consider this as a uh, information which is being stored in the rows and the columns of one patient or one student or one employee, right? And it could end to multiple records. Then we need to perform some analysis on these records so that we could gain some insight and perform some data analysis, right? Right. So then important attributes of the ND array, we saw that data, n-dimensional, shape, size, d-type, item size, right? So these were some of the practical implementations. And dimensions provide the number of axis dimensions in the array. The axis 0 along the vertical position, along the vertical, right? So this axis 0 and axis 1 is really very helpful, in which we are trying to take the arithmetic operations along the rows, all the rows inside a column, and this is along the columns, all the columns, right? So how you interpret it's up to you, right? I interpret it in this manner. Axis equal to 0 means that along all the rows, right? It is vertical, and axis 1 it is horizontal, right? Shape, you can have the shape, the size of the dimension, right? Then size, right? It is the product, the number of products, like how many products are present in a particular array. Then D type is the dimension, which type of data type it is storing. Is this numpy, integer, float, or boolean, right? So this kind of a data type. Item size, it calculates the size which is needed to store that information. Okay. Then attributes, so this we have seen. Reshape, so we have a numpy array like 2 cross 3, right? So we can reshape it to 3 cross 2. So earlier the number of rows and the columns were 2:3. So now it is 3:2, right? So this means that we can reshape any array to a particular size, but the constant is that the numbers should be multiplied and the result should be same. That is 2 into 3 is 6 and 3 into 2 is also 6. Right? So dimensions can be changed, but the overall dimensions should match to the original array. Right? Okay. Okay. So this up till now, this we have seen the arithmetic operations in NumPy. Okay. Okay. So let's try to see this session, right, which we have already covered. Okay, so what we have covered yesterday is that like we have imported datetime from date, and this is a datetime module. And from that module, we are trying to import date, which is a class, right? And we are trying to take the birth date and year, day, month, right? And also we can calculate the today date by using a today function. So this is a function which will try to give us the today date, right? Then we have seen a program in which we take the input from the user, okay, and we take it as a year, month, and day, and we try to calculate the convert into a birth date by using this date method or class. You can say that. After that, we have written another function which is your calculate age, which takes the argument as a birth date, and we have the current date, and from that we try to write some logic. Okay, the function which will try to calculate the age, right? So that function of calculation of the age, you can design your own algorithm also, right? Mine would be wrong, and I have uh, demonstrated uh, specifically to give you a structure that how the program follows, right? How the program has to be written. The program has to be written in such a manner that it should be modular, it should be concise, and it should be written so that next time if you wanted to do some modification, you can easily do it. Right? Okay. So let's say we come up with this first statement. We calculate the we input the year, month, and day by using our input function, and we convert it into the integer because in the input function everything is stored as a string. And since we are trying to take the year and we are trying to do some arithmetic operations, so we need to typecast it to the integer, right? So we have taken year, month, and date from the user, and then we have used this date function or class to convert into a birth date into a particular format. Okay. And then we have also tried to use the try and accept block. In this particular block, if some error occurs, okay, it will automatically go into the accept block and it will not give us the error, and it will try to give us the print statement, enter the valid date with the exception, right? What exception we'll have tried to have. So this is the standard procedure because like nobody likes errors on their screen, on their websites, on their pages, right? So it is if you are trying to work as a developer, so it is better you do the uh, exception handling of your code, right? So this is very important and very necessary to try to validate the edge cases. Okay. Then we have written another function, which is your get age, and we'll try to take it as a today date, and we'll try to write some logic. Okay. So this logic, according to you, may change, right? So I've given you a simple logic in which we are trying to uh, subtract the year-wise date, and here we are trying to check the month date is and the today's date is less than or greater than. We can just write one statement that we can subtract 1 year or add 1 year, right? So this is only for the demonstration purpose. So this logic might change, right? Okay. Then this is your main function where we are trying to call this get birth date. So this is your get birth date function, which is written over here, and the birth date will get into the get age, and then after that, like your age gets printed. Okay, so this function we have called here in this particular block. Right? Okay, so this is the ideal path in which we can write a function, and if these functions increase over time and you are building a project, then these functions has to be written in a separate file. Okay, so this is like what we have seen. Then we touched upon your NumPy. So NumPy is your 1D array, right? 2D array, right? So we took a 1D like a scalar quantity. Then we took a list. So this is a list, and we try to convert into a NumPy array. Then we also seen your list, right? And we try to do some operations into your list, that we are trying to sum all the elements of a list. And it took us about 2.75 microseconds. And when we did the same operation using your NumPy array, that it took us 1.23 microseconds, right? Okay, then we talked about endem and shape, right? Okay, then we also converted ones, np dot ones, np dot zeros, right? So these are also some of the methods, okay, in which we can create some array, right? Okay. Then reshape is also another option in which we are trying to reshape some of the elements, right? And dtype, item size. So this we have already seen, right? So up till now, any doubts, any questions you are having, just let me know, or we'll proceed with the next part, which is your multiplication, subtraction, additions, and your other operations onto your NumPy array. So, arithmetic operations in NumPy. So, there are various types of operations, which is your NumPy dot add, right? NumPy dot multiply, NumPy dot subtract, NumPy dot divide, okay, and NumPy dot remainder and NumPy dot mod. Yes. So basically, Deepak, you got your error in get age program. Why? Because this error you got it because you haven't imported this thing, right? From date time import date. Okay. So it is when you are trying to encounter some error, just look at the error first. Your name date is not defined. Basically, you are trying to access the date. Okay. So date is an external library. Okay, which we have imported, right? If you didn't run this date, so your program will not work and it will give you error, right? Okay, try to run this line first, and then you are trying to run this thing. Okay, so these are some arithmetic operations. Arithmetic operations involve your matrix multiplication, matrix this thing, and which involves your element-wise addition, element-wise multiplication, element-wise subtraction. Okay, so let us try to see this thing. I'll create a new notebook, which is your eighth session. Okay, so first thing we need to do is like import numpy as np, right? So this is the first thing, or we are trying to import some library. So whenever you are trying to run, so this statement you are trying to call an external what we call package or module, okay, for your use. Okay, so then let's try to uh, make some array, right? Okay, so let's say I wanted to make some 3 cross 3 array. So np dot arrange, right? So arrange is similar to, let's say, I wanted to create the array from, let's say, 1 to 3 cross 3, 1 to 10. Okay, so 3 cross 3, I will try to create it. Okay, right? So I will try to create array, right? So 1 to 9, it is already created a 1D array. So I wanted to reshape. I will reshape it to 3 cross 3, right? And I will try to give it as array underscore 1, right? So now I will try to print this thing. So now you will see that So this I have made a array which is your with using this arrange method. Arrange basically it starts from 1 and it ends at 9 n minus 1. So we have seen the range function. So it is similar to range function. Okay. So why I have done is instead of typing again and again, so I've created a range function and created an NumPy array where we shape the size to 3 cross 3. Okay. I can even try to do something like array 2 and p dot ones, right? And right, and p dot ones, and I will try to give the shape also. Let's say I wanted to give it as 3 cross 3, right? Can't interpret is equal to, right? Right. So this is also created as a np or dot array, right? Okay, right. Okay. So I've created two arrays. One is your array one and array two. Okay. So let's try to do first addition, right? So array underscore one, right? And I'll do np dot add, right? So now you can see that the element wise operation has performed and you have tried to add the np dot array, right? So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, similarly 4 plus 1 is 5, 6, 7, similar to that, right? So similarly np dot subtract, okay? So I urge you guys to start doing along with me, okay? Even though I will try to share this Jupyter notebook, okay? np dot subtract. So similarly, try it with multiplication and division, guys, also, right? So this is addition, this is your subtraction, then we have division or your multiplication, right? Okay, so this is your multiplication. And then we have division also, array to divide, divide, not division, right? Okay. Then we have mod also. Okay. So it is floor division basically, right? So we have seen the floor division, right? So it is basically your remainder kind of a thing, which we have already seen in case of your this thing, right? So mod is an alias of remainder, okay, right? Okay. So let us try to see this arrow one. Yes, Hina. Okay, okay, Saurabh. I'll go slow. Okay. So first, what you do, you try to make some. Yeah, yeah, I can understand. Yes, yes, yes. So I will try to share each and every line here first. I'll keep that in mind from now onwards. I will try whatever I write. I will try it first. Okay. Okay. So I'll give you ample amount of time. Okay, to write and practice. Okay, it is subtract, multiply, and divide in mod. Okay. So right. So Srishti, basically what we have done today is that we are trying to make an array, right? So this is an array. An arrange function will try to list me the elements ranging from 1 to 9. Okay, starting from 1 and ranging from 10, 10 up till 10. 10 will not be included up till 9. Then I'm trying to reshape that particular array into a size of 3 cross 3. And automatically it has been reshaped and it is a this thing 3 cross 3 matrix. Okay. So Deepak, it is not arrange, it is single R. Okay. Basically, it is not np dot range. Range is single a single. You have a I am trying to write in the chat again. Just copy this and try to write it. Okay. Then we have made another array, which is your np.ones, which will try to give me only the ones, right? And it is of shape 3 cross 3, right? Okay. Then we have two arrays. One is your array 1, which is a 3 cross 3 matrix. Y 1 2 in array after addition subtraction. 1 2 1 2. Okay. One dot. Okay, so this is dot, basically it is a floating point value. So this is your floating point number basically, right? So when we are trying to have this ones D shape, so we'll try to define which is the D type. So D type can be defined as in 32, right? And P dot in 32 we can define it, right? So if I try to define it now, you can see that like earlier by default it was floating point value. So that is why it was giving one dot, two dot, right? If I try to now add it, you can see that. Okay. So so by default it will take a floating point. So now you have defined the data type. Okay. So let's try to give this to you also so that you can try it, right? Okay. Right. So then we have subtract, then we have multiply, then we have division, modulo. Modulo is basically we are trying to like trying to calculate the remainder. Okay, so this is array 1 and this is array 2. Okay, so this was one array, this is one array. So we are trying to divide it and find the remainder. Okay, so that is why like it is giving us the modulus. Modulus we have seen in the Python itself only, right? So this is what we get. Got it. Okay, okay. So okay, so another 30 seconds. Okay, yes, the mod function. Okay, so if you are having some trouble with the mod function, so just try to write and try to see the documentation. Okay, returns the element-wise remainder of the division. Fine. It computes the remainder complementary to the float divide function. It is equivalent to the Python modulus operator. So this modulus operator we have already seen, right? Okay. So it computes the remainder. Okay. So x1 modulo x2, right? Okay. So fine. So we have one array and another array, array 2, and like it will try to do the element wise operation and it will try to divide x1 and x2 element wise remainder of the question, right? Okay. So if you don't understand any of the function, okay, maybe there are n number of functions. Okay. So it is better to follow the documentation. So this is the official documentation of your NumPy, even though you can get it on the internet also, but it may be updated. It may be updated, right? This is the latest one. Okay, with some specific versions it is updated, and on the internet you get an information which could be outdated, right? So this is the best practice where you don't, even if you don't have the internet, this also still works. Okay, so that is the main advantage of using this documentation. Fine. Okay. So shall we proceed further? Yes, no, or you want another 10 seconds? So now we move to the conditional statements in NumPy. So conditional statements basically are two, which is your np.where and np.select, right? Okay. So let us try to see the conditional statements where np.where is basically your condition and your true expression and your false expression. Okay. So let us try to see this np.where first. Okay. np.where. Okay. So we already have an array, array underscore one. Okay. Right. So what I will do is I will try to write np.where. Okay. So before going to this mp.where, okay. So let us try to understand the documentation. Yes, Saurabh, you need mod needs explanation. Okay, so you wanted to explain, like you want me to explain mod again. So basically, mod you have seen, right? Mod is basically it will give you the element wise remainder of the division. Okay, so let's say there's one element, this A1, right? Another element is, let's say, 2. So it will try to first divide it and find the remainder. Okay. After the remainder, right, it will try to give that element wise. So this is what it's trying to do. From one another element wise. So it will go, it will divide it and it will return the remainder. Third element, it will divide it and it will remain the remainder. So this is what it is trying to do for the mod operation, right? Okay. So you try it out and just follow the documentation and you will try to understand. So what is this mod about? If not, like then let me know again. I will explain you in detail. Okay, because we have a lot of functions and everything we cannot cover due to time constraint, right? Okay, right. Okay. So let's try to see the np.where. So in order to understand np.where, so we will see. Okay, so this actually you get used to this operation or this documentation. Okay, because whenever you are trying to work on it, so these are the parameters. Okay, and these are the returns. Like this will try to return it, and you will try to see the example also here. In some cases there is written, in some cases it is not written. Okay, right? So you just need to follow this. This is the official documentation, and wherever you go to the official documentation, this docstring and that docstring is more or less the same one. Okay, so this is given for your ease. Okay, so let us try to see this. Okay, so basically this has having a condition, right? np.where it is a condition, okay, which is being performed on a particular array, right? So it is performed on a particular array and it will try to return me either x or either y, right? It returns the element chosen from x or y depending on the condition. Okay, so let us try to see this operation. Okay, so from this array one, right? I wanted to write whatever elements are even and whatever elements are odd. So what I will do is I will try to say array underscore one modulo two equal to 0. First, every element will try to divide by 2, right? And if the result is 0, I want to print it as even, else I will want it to print it as odd. Fine. So what will happen? 1 will get as odd, 2 will get as even, 3 will get as odd, right? And 4 even, similar to that, right? So I want to make that the elements where this is this thing like divisible by 2, it will provide me even, else it will provide me odd. Okay, so let us try to run this. So now you can see that, right? Odd, even, odd, even, odd, even. So this is what we are trying to see. We are trying to make a condition, right? So I'm typing here and the array one we have already there, right? So array one, I'll try to, so this statement you already run it, right? So I'm trying to run it, give it here again. Okay, and you need to reshape it, right? And then after that you run this np.where. Fine. Okay, so this is very helpful in terms of when you are trying to find some logic. Okay, so let's say I try to change some logic. Okay, so can you think upon it? Let's say uh, no, no, you don't need to run, rearrange, and reshape again if it is already been run. It is for your convenience I have given you because, right, if it is being already been run, okay, so then it is fine. You don't need to run again and again. It is your convenience, like because if you are trying to run like you haven't run that in other earlier cases, I found that like the numpy was not run or date module was not run. So that in that case I've shared you so that like the you don't get any error that you error one is not there, right? So that is why. Understood, Deepak? So this is your data type, unsigned integer we call it, right? So this is your data type unsigned, which is basically a string or unsigned. Okay, okay. So I'll let you know. Okay, so what is this exact? But to my knowledge, so it was unsigned kind of a thing, right? So I'll let you know on this, right? Okay. So don't bother upon this. Okay. So the only thing is that like just concentrate on the logic and the building. Okay. Okay. So there, like let's say in this particular thing, I want the elements. Let's say to become for the even, I wanted to make it 0. Okay. So that also can be done. Okay. So I will say 0 or 1. Yes. Okay. So whatever events are there, it can be 0, which that can be combined as 0, else it could be combined as 1. Fine. So this way also you can do it, or you can just type the where condition where you can say that array underscore 1 greater than 3, make it as 0. Okay, else 1, similar to that, right? Okay, right. So this way also you can do it, right? Right. So this was your np dot where. So another part was np dot select. Okay. So let us try to see the documentation first. Okay. So yes. So this signature, the np dot select. So try to understand this. Okay. So these are the parameters. Okay. So the parameters means it is a function np dot select, and it consists of your condition list, choice list, and default. Okay. So there could be many parameters. So Saurabh, basically this is your modulo function. Okay, so if you have attended your Python session, so basically what it does, it will try to divide your number by by 2, and it will give you the remainder. And if the remainder is equal to 2, it will return you true or false. Okay, so basically this is a modulo function, modulo operator we call it. And this array one is basically your array. The element, first element will try to come, and second element, third element, right? So this way it will come, and it will try to give you the remainder. If the remainder is equal to 0, then it will try to give you like the condition what we have written, right? Yes, yes, divisible by 2, yes, and gives you the remainder actually. It is divisible by 2 and equal to remainder. The divisible by 2 and this modulo operator will try to give you the remainder, right? Okay, fine. Shortcut of signature. Signature shortcut basically, right? I have explained you that it is question mark and then shift and tab, right? In earlier session also. Uh, yes, shift and tab. Yes, question mark, shift and tab. Okay. So we'll get the signature. So this is very useful. You don't need to go again and again on the internet and search for it, right? Okay. So these are the parameters. You have the condition list, choice list, and default. And it will also give you that it is a list of Boolean and the arrays, what data type it demanding, right? And if you try to go through it carefully, you will automatically understand like because the thing is that if you are a programmer, if you are a data scientist, most of the things you need to do it on your own. Nobody is gonna tell you. Okay. Then you need to understand it. You need to follow the documentation. Maybe I'm trying to tell you one function. Okay. I'm trying to tell you earlier also I said it that I'm trying to tell you how to drive a car. Okay. So I'll try to teach you one car, and rest you can take it on your own. Okay. So this is the method. This is the way I'm trying to tell you that if in future any method you have encountered and you don't know about it, you just need to go for the documentation first, understand it. Okay, right, write it out. Then you need to if you didn't follow, then you need to go to the internet. Okay, so this is the practical scenario. Okay, if you just follow, so this it will give you the condition, choice list, and default. Okay, then there's an explanation also. Let's say np dot range. So this is 0 to 6 elements, right? And the choice condition list is that like if it is greater than 3, put it x. If it is sorry, it is less than 3, put it x. Leave as it is. And if it is greater than 3, then multiply that elements with 2. It's not 2, sorry, it is power. It is basically power, right? So if it is less than 3, make it as x, same, nothing will change. And if it is greater than 3, you make it as a that element as a power of 2, right? So let us try to do in practice, right? np dot select. Okay. So I'll try to copy this example itself only. Choice or condition list, right? Right. Okay. So here we will try to give you condition list and your choice list, right? Choice list. Okay. Right. Okay. Okay, I will run it and it will give me error. Okay, so and then you guys has to tell me what is the error, because this is also a part of your data intakes to identify the error and try to let me know that what went wrong. Okay, because most of you are encounter some of the errors. Okay, and in that case, like you just need to tell me that what sort of error was there and how we can correct it. Where Python implement the logic, array is missing. Yes, X is not defined. Yes. Yes, Virendra, array is missing, and in this array X, like it is trying to say that array is not defined, name X is not defined. So we just need to put that operation on a particular array. Yes, yes. So what we will do is we will try to see these array one. Okay, then we will replace this X with your array underscore one. Okay, and here also we'll try to replace your array underscore one, and here array underscore one, and here also array underscore one. Okay. Okay. So this is this the basic uh, uh, motive was to like understand like what went wrong, and the thing is that like we just need to make sure that we don't follow blind practice, right? We just also see that what the error is that and how we can correct that error. Okay, so here you can see that if it is less than 3, keep as it is. It is less than 3. Yes. Okay. And if it is greater than 3, you can see that 4 raised to power 2, 5 raised to power 2, 6 raised to power 2, 7, 8, and 9. Right. So this you can have that np dot select. According you can make a condition according to the choice. Right. And if there is a default, okay, so I will put some default equal to, let's say, 4. Right. Right. Now you can see that, right? So 3 has changed to 4, right? So because 3 was not mentioned and default has been changed to 4, right? Okay. So this you can just understand and try it out, because I have trying to tell you the method. There must be numerous types of methods and numerous parameters. Okay. So in later stages, you can see as we see the parameters go on increasing. There in one function there could be 10 parameters, and it is very difficult to explain you 10 parameters due to the time constraint, right? So I can explain you at max 2 or 3, but the rest of the parameters according to your requirement you can see and you can try it out. So the purpose is basically you have seen this where, right? So it is also basically we are trying to make some condition, and we are trying to make some choices, right? Choices in the sense like based on this condition. So here we are trying to put only one condition here. Here we are, can make multiple conditions. Understood, right? Okay, so we can make multiple conditions. According to that multiple condition, we are trying to make it that this is our choice list. Make it according to that and give me that array. Let's say practical implementation. You have a long list of array, right? With some tax calculation, right? Let's say salary of the employees. Okay, so you have a 3 cross 3 metric of the 9 employees. You have the salary. Let's say these are some salary numbers. So here I will make a condition according to that condition which is being taxed, right? Let's say it is like falls under 0 to 50,000, like this much tax is being or 5 lakhs, this much tax is deducted, 5 to 10, this much tax, 10% tax is there, 10 to 15, 20%, right? And rest on this thing, right? This array is arranged. So when you are giving greater than 3, how will this function is check each number? Uh, Sort of basically like it is designed in such a manner that it will try to check each and every element. It will iterate through each and every element. It will try to check it, and based on that, it will try to give you that condition. Okay, try to follow. I understand your point that you are trying to say that like this is the array whole completely, and it is how it is trying to check. No, it is trying to check on each and every element. So that is why this np.select method or function, which we call it, it is designed in such a manner it will try to act on individual elements, right? Okay. So that is like it is designed in that manner only, right? Only every element it will try to uh, follow that choice condition list or choice list and do the operation, right? Okay. Okay, so Radha, you got that point, right? The salary thing, right? So we have the structure in which we say salaries of employees, and then we can make some condition and choice list on that. And based on that condition choice list, we can just care that. Yes, yes. Okay, okay. So Saurabh, like you can just see the documentation. There could be n number of parameters used in this operation. Okay, it is a scalar, the element inserted and output where all the conditional values to false, right? So here basically if the this condition is not met, this condition is also not met, right? So there it was zero. So we don't want that the zeroth element could be present, it could be default to 4. So that is why we have made it default as 4, because earlier if you don't put default it will try to give you 0 because this condition is not met on because it's less than 3 and greater than 3, but equal to 3 we haven't got it. For that purpose, we have made it default 4. Okay. So is this correct? Is this fine? Yes. np.where, np.select, right? Okay. So these are some of the methods in which you can just make your programming better. Okay. And try to learn programming, understand programming. Okay. Don't cram it. Okay. Just go through the official documentation and try to learn each and every or try to follow the steps which they have given. Right. Okay. And try it out. Basically, the more you practice, the more you will try to understand that. Okay, fine. Saurabh, Radha, right? Right. So now we move to the statistical functions. Okay, statistical functions, you already know that like some of the statistical functions which we have np.min, max, a min, a max, np.mean, median, standard deviation, and variance. Okay. So now I will not do it, right, guys? So you need to practice and just let me know. Okay. Try to create an array. Okay. And try to use these functions and first try to understand what does it does do. Right. Let's say you are trying to do np.min and just question mark and shift and tab and try to read the documentation and then understand it. Okay, the whole purpose of this activity is that I may not be present every time with you. Okay, you just need to drive your own car. Okay, I'm trying to give you the control and I'm trying to say that okay, go ahead, turn left, turn right. Okay, so this way you need to learn it, right? Okay, so I'll also try to do the statistical function along with you, but your job is to look at these statistical functions and try it on your own. What is mean, median, standard deviation, and variance, right? Okay, okay, guys. Are you ready? Yes? No? Is it fine? Okay, so let us try to have that array again, array 1, right? Okay, so array np dot a min, right? First, I will try to see the documentation. Okay, so now you see. So here in the np dot a min, so we have the a, right? So which is the a? A is your array, and axis is by default it is none, out is none, keep names initial where, right? So these are some of the arguments we can use it, right? But for simplicity, we will only try to use a this only, or at the max we can use the axis also, right? Okay. So then if you try to see that these parameters, okay, right, and implementation. Okay, so let us try to see. So this doc string has little implementation or little docs string. You can see that in some cases it is given with an example. In some cases it is not, right? Okay, so let us try to see that and try it ourselves. Amen. Okay, right. So it will give you one. So this is your one. Basically, it has given you as this is your integer this thing, and it has given you the first, right? Okay. So if I try to see the axis equal to 0, So remember, x is 0 across your vertical. X is 1 horizontal, right? So now x is 0, just see. It will try to give you minimum values across 1, 2, and 3. Fine, right? Okay, got it, right? And if I try to give x is 1, that is your 1, 4, and 7. 1, 4, and 7 across vertical lines. Earlier was horizontal, this was vertical lines. Okay, so this you try it on your own. X is 1, and I'll try to give it x is as 0 also. Just quickly try it with a max also, right? And p dot. So now the question is that where it is being used, right? The question is that these are some of the data in the sense, maybe data in the sense the ages of your students. Okay, so this is particular row, one row, second row, third row, and this is your age. This is your, let's say, age, and it is could be your class, right? And it could be your height, right? Right. So basically, you wanted to uh, give me the names or the student where the age is less from that particular column, from x is 0 or x is 1, right? So this way you need to find it out. So this is the very good method in which you can find that age, a min or a max, right? Right. So then we'll try to compute the mean, median, and standard deviation, and your variance. Okay. So guys, what is the difference between mean and median? Anyone? Yes. Mean is the average, right? So you can get the average, and your median is the middle one. Absolutely. Absolutely. Sudhir, you are correct. So mean and median basically is the middle one, right? So basically when we try to uh yes, yes, column wise or row wise, and anything in any interpretation you make, yeah, right? So I have termed it as a vertical and horizontal. You can term it as a column wise or row wise. So what is best for your memory, right? You can just try it out, right? Okay, okay. So the interpretation has to be correct, basically, right? Okay, so the mean, right, and then uh, which is the average sum of all the values divided by the number of values, right? Which is the mean, right? So here you can get all the mean information where all the elements are being summed and divided by the 9, right? And you get a number which is 5, right? Okay, so this is basically your mean, and median is the middle one value, right? If the numbers are being there and the odd one, right? So odd one is the middle one, right? Else in the even, right, we divide by 2. Okay, so this is your median. Okay, so we'll try to calculate the median also, and p dot median, right? And then we'll try to get array one, right? Right, so it is also 5, right? So mean and median is basically the same here in that part, right? Okay, so can anyone tell me what is variance? Yes, anyone? So variance is basically like how far the data points are being separated. Yes, yes, distance between the data point. Yes, Virender, you are correct, right? So how it is being calculated? First, it is being the average calculation of the squared differences from the mean, right? So then we take yes, standard deviation. Yes, yes, you can say that, right? So standard deviation is basically the square root of variance, right? So this also way you can do it, right? So so now here np dot variance, and we can calculate array one, right? So this is your variance, right? And if we try to calculate the standard deviation is also str np dot, right? So this is your standard deviation, right? So these are some statistical properties or statistical operations which you need to uh, like perform when you are trying to do your data analysis. So data could be in the form of data points, what we call it, right? So that points could be, let's say, we are trying to record some uh, temperature recording or sensor recording, right? Wind pressure, right? Rainfall, right? So there you need to find what is the average rainfall, right? What is the standard deviation? How far the data points are being separated? So there you need to understand it. What is the mode? Mode is also there, the highest point we call it, median, mean, right? The average, right? So these things you just need to understand, and then you need to apply based on the analysis you will do. Okay, and then max, minimum, right? Along the rows, along the columns, right? So this you need to do it, right? Median, yes, mean and median should be same, Deepak. Yes. Why it is being same? You tell me, because the thing is that if you try to calculate the mean of these numbers, you sum it all and try to divide by 9, it will be 5. And your median is also the middle one. Middle one is your 5 because it is an odd number, right? So this you need to understand it, right? Okay, so I guess it is self-explanatory. So median and mean, because basically the middle one is your median and mean is the average, right? Okay, so that is why you are getting the output as 5. Fine. Okay. Everyone done? Yes, no? Standard deviation, variance. Shall we proceed further? Yes. Okay. Great. Okay. Right. So these we have done it. So min max you can try it out. So these are also some operations, right? Okay. Right. Then how you can calculate the variance of elements in NumPy array? So np dot median, np dot var, np dot mean, np dot sum. Okay. So B, yes, 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 you are all correct. So NP dot variance is the method to calculate the variance, right? Okay. Indexing and slicing of NumPy arrays. Okay. So this is very important, guys, right? So how we try to index and slice your NumPy array, right? So this you need to understand. Okay, so based on this, I will try to give you one activity also, right, after the break. So let us try to complete this theory part first and practical also. After the break, I will try to give you programs or statements in which you just need to give me the answers, right? Okay, right? Okay. So what is indexing? Indexing we have already seen in the NumPy or in your Python also, right? So index, we can access an element based on that index number. So index also always starts with 0. Okay. And that property follows your square bracket in which we can put a number, right? Let's say 0, 1, 2, 3, and we can have that particular element indexed, right? Okay. So index like address, no, not basically I address. It is basically like your key. You can say that like basically the address is different. So you cannot call it as index as an address. Every element which is being stored has a specific address, and you cannot say that like that address and that index could be same. Fine. Okay, the index always start from 0 where that element has been stored. So you name that as a index. Basically, you are trying to store it in a stack. Like you have a stack of shoes in which you try to place your shoe at the bottom, then after above, then after, likewise, right? From bottom to top, right? You go on increasing. And from the lower one, it is your zeroth index, and then it starts rising from the top. Okay. And slicing is basically you stack the portion of an array. Let's say you wanted to start and stop, and you try to give a step function also, right? So this is basically your slicing. Okay. So let us try to see the indexing in practice. Okay, right? Uh, so let us try to see the same as your ARR one. Slicing, like, yes, Virender, slicing is basically it's basically in Python also we did the slicing, right? Yes, Saurabh. Yes, go on. So basically median, right? Median is what is basically the middle element. Okay. So here you have given elements from ranging from 1 to 9. Okay. So you take four elements here, four elements here. Okay. So what is the middle one? 5. That is why the result is 5. Understood? So the middle one is your, now you try to give it as 8. Yes. Even count. No, it is not an even count. Even count will give you 4.5. Okay. But your odd count will give you the middle one only. So that is your median. Understood? Yes, no? Fine. So that is what is the median is. Okay, right. Yes. Virender, any doubt? Okay, fine. Right. Okay, so what we are trying to do is we are trying to do a slice, right? So let's say this is your array one. So I'm trying to print the array one again. Okay, so I wanted to get the excess of 0, right? So zeroth index means your first row. Okay, so this is your first row. And if I try to write it one here, it is second row. Okay, uh, third row. Okay, because indexing always starts from 0. Okay, so 3 is not there because index is out of range, like for the axis, the 0 with the size 3. 0, 1, 2. Up till 2 will be there. So third element does not exist or the third row does not exist. Okay, so this we have already seen in the Python when we are trying to have your index, right? So negative index, positive index, so we have seen it. Okay, so let's say if I try to give -1, what will happen, guys? Yes, no? It will give me the last entry, right? So indexing starts from 0 and indexing starts from -1, right? So this we already seen, right? -2, minus, right, and -3, similar to that, right? Okay, so this we already see, right? So this is your indexing, right? Fine. So zeroth indexing, right? We have seen it. Okay, right. Okay, so if I try to see the 0, 1, right? 0, 1 or 0, 0 would be the first element. This is first. 0, 1, 0, 2, 1, 0, 1, 1, right? So this is how we can get that elements, right? Individual elements. So this is individual element 1. If I try to give 1, right? Okay. So I'm trying to type it again for the sake of simplicity and for the future use also. Okay. So row. Right? Second row, right? Fine. Understood this point? Okay. So this is how we try to index the rows. Okay. Now come the slicing part. Okay. So let us try to do the slicing. Yes, this is indexing. Yes, yes, Virendra. Right. So now we'll try to slice it. Slicing means we are trying to this is particular an 3 cross 3 matrix. It could be 5 cross 5 also. But I wanted only these last four elements, 5, 6, and 8, 9. Okay. I want only these last elements. Okay. So there we can slice it. There we can slice it. How we can slice it? By using your row, right? So this is your nomenclature, right? I'll try to this thing. Let's say, right, you want to have 0 up till 2, right? Right? And inside this 0, sorry, not this 0, right? Row to row, okay. From column to column. This I will try to do it. From here, I will get 1. Understood this point? I'll repeat it again, guys. Okay, because this is a little confusing. Okay, so let's say this is your array, right? I wanted to have the elements, let's say 1, 2, 4, and 5. So 1, 2, 4, and 5, first you need to have only first two rows. So first two rows, yani ki 0 to 2. Okay, so let's say 0 to 2. Okay, you will get first two rows. Okay. From these first two rows, you only want to get 1, 2, and 4, and 5. Okay, you put a comma. Okay, then you are trying to have columns. So 0 column till first column. Okay, you 0 and first, right? But here you will try to write 0 and 2. Okay, you will not write 1 because if you try to write 1, only the first element entry will come. Okay, so that is why we are writing 0, 2. Okay, if you try to write 1, 1, 4. Fine. Okay, so let me try to give you another example where you want only 8 and 9. For the 8 and 9, what will happen? Array underscore 1. Okay, 8 and 9. 8 and 9 is happening in this thing. In the row second. Okay, so I will say only row second I want, right? 8 and 9. After that, I only want the columns from 0, 1, and 2, from 1 onwards. Oh, sorry, 8 and 9, comma. Actually, I forgot to put comma. Yes. Understood? Yes, no? Do you want me to repeat again? This is the normal structure, row versus row, comma, column. So you can slice any part of it, guys. I only want the fifth, this single entry. No, it is empty, Sudeep. Your answer is 0, 1 to 1. Okay, 1 to 1. So 1 to 2 could be, you're right. 5 and 8 is there. Okay, so you are having 5 and 8. So basically, first you want this and 0, 1, 5. Once again, I'll try to do it. Go into the next topic, which is our file handling topic, right? So this is also very important. Okay, it refers to the process of working with files stored in computer file system, right? So NumPy array can easily save to and load from files using the functions called np.save and np.load. Okay, so these are two functions, which is np.save and np.load, which is to load some file and to save some file. And to read files, we have load txt and gen from txt, right? Okay, so these are the two operations, these four methods we will try to use it. Okay, so we have a CSV file in which some data is being stored. We wanted to load it and then we wanted to perform some operations and then we wanted to save it. And to read from files, there is load txt and gen from txt, right? So let us try to see this in practice. Okay, right. So let us try to see that we have np dot load txt. So first we'll try to see the documentation. Okay. So now what the doc string and the signature says, the load txt takes these many parameters, and by default some are none, some are zero, some are false, right? Right? And it will try to load a data from a txt file. The file name parameter, okay, could be a file, could be a string, could be generator, right? So some extensions is also given, right? Right. So this kind of an doc string is very useful in which we are trying to work with some files and that file format is not supported. There you can check the parameters first and whether it is supported and not, you can just check, right? If the file name is extension is .gz or bz2, the file is first decompressed, right? So it is trying to say that. Okay, we have the delimiter, which is string optional, right? And skip rows, use columns. Okay, so these are some of the parameters. You can just try it out. Fine. Okay. Then examples. Let's say we have your string input output. We try to load the txt, right? Okay. Okay. In our case, what we will do, we will try to make some file, and from that file, we'll try to make some delimiter, and we will try to say that it is the type is string, right? Then we'll try to load it, right? Okay. So let us try to make some file first. Okay. So in this particular Jupyter notebook, so I have made a sample.csv. Let us try to add sample.csv. So these are some fields: Ashish, Vipul, Vikas, Monal, right? So I've added already, right? So how I can make this file? Let me try to give you this file directly. Okay, so you can just modify it. I'll just give this file sample.csv to everyone. Okay, okay, okay. So this file has been reached to you. Okay, so what you need to do is you just need to make sure that file is present in that folder where you have this notebook stored, right? So I have this 8 Sunday session 2. Okay, and I have the same directory in which there this file exists. Then I will try to say sample.csv. Okay, and it is delimiter equal to comma, right? And d type is your string. Okay, so I'm trying to load this and try to store it in the array dot, let's say 3, you can say that. Okay, right? And when I try to print this array 3, you get the values. Okay, right? So some unknown characters are also coming. It is due to that we have made that file and the file format was not proper, or it is basically if the file is proper and the contents are proper, then you can make this array. You can correct it yourself also. You can fiddle with the sample.csv. You can create your own sample file and then you can just make sure that all the content is being loaded correctly. Okay. So this is only for your demonstration purpose that we can also load the file, that is CSV file, and then we can just have some options, right? That is the comma separated. So why we have used the delimiter? Because it is a comma separated, and we have specified the d type as string, right? Okay, so we are trying to load this file. Okay, right? Okay, so you can just try the other option also, right? Skip value, skip row, something like that, and try it out, and you can just fiddle with the parameters. So these parameters are a long range of parameters. Okay, so that is the case. Okay, so this is how we can get the file. Okay, so another method is np dot gen from txt, right? Let us try to check this also. These have other parameters also, and load data from a text file. So this also loads the data from the text file, right? And the only thing is that it will try to give the handle. It will try to load the data from the text file, and the missing values are being handled. Okay. So basically, the difference between your load txt and gen from txt is that like that doesn't handle your missing values, but it will try to handle your missing values automatically, right? Some of the values are not there, not present. Okay, it will always like it will try to handle it. Okay, so this is the common practice. Like when we try to get some data from the client or some external resources, so there it might occur that some of the data is missing, and you need to correct that data. Okay, so either you will try to use some where clause in which you try to filter out where the data is not there. You try to put a default values to it. Or either you at the time of loading itself only you can just specify and try to put some value which could be a default value to the missing value. Right? Okay. So this is your basically gen from txt, and this is also a sample CSV, and we'll try to put the delimiter equal to comma, and the type is also string, right? And let's try to put it in array 4, right? So this same we got it, right? So just try to skip one of the values and try it with the CSV and try to compare these both values. The only objective of doing this activity is that you got us this step that how we can just load our data, right? Okay, and then data could be complex and it could be challenging sometimes. So in that case, you just need to make sure these functions exist and you know these functions. Okay, right? Okay, right. Okay. So the next operation is that we are trying to save the NumPy array in a text file, right? So let's try to have that array one. We have already have this array one, right? Okay. So I wanted to save this. So what I will do is I will try to say np.save txt. Okay. And I will try to put a name of that file. Let's say sample file one dot txt, or I will try to say CSV, let's say, right? And I will try to give this array one. What I wanted to save, I wanted to save this array one into this CSV file. Okay. Then delimiter. So delimiter is basically your CSV file is always your comma separated. Okay. So I'll put a comma. Okay. And then I will try to save it. Okay. So what will do, it will try to save the CSV in that particular folder. Okay. Then we will try to see and look whether it has been saved or not. Okay. So I'll try to copy this and send it in the chat. Okay. Just type it yourself. Okay. Now let's see. Now you can see that sample1.csv, the file has been saved. Okay, let us try to open it. Okay, so it is giving you some values, right? Okay, so okay, so let us try to open it. Yes, so this file I got it. Actually, I try to show you. Yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this already got it, right? So this is basically your like floating point exponent value which is being given it there, here, right? Up to this much decimal, right? Okay. Okay. So this basically this is like it will try to save it, right? And this has saved it, right? Okay. So you can convert to a number and try to do some processing, and then it will try to save it effectively, right? Okay, okay, fine. Yes. Okay. So the another method is that we can save that in the file in using your NPY method also, right? Okay, so let us try to do that. np dot save, right? File dot npy, right? Right. So this is your file npy, right? So it is a document, right? And this file can be loaded also. So this is your np.y file format, right? So basically we are trying to save it in this format. Okay, so let us try to see the documentation of this. Okay, right? So save an array to a binary file. Basically your n.np file format is a binary file which is in the np and it is loaded as a np format only. Okay, so you are trying to save it in the array format or in save the array in the binary format which is which takes less space basically. Okay, so that is the purpose of saving this to the .npy format. Okay, right. Then we can also load this file. Okay, and load this np.v file, and then we can just see the contents. Okay, so how we can do it? We have another method called np.load. Okay, so let's say array underscore 2 equal to np.load, and we will try to say that file dot npy, right? Okay, and if I try to see the array dot two, you can see that the values have been exactly matching. So what we have done is we have tried to save that file and then we have tried to load that file. Okay, right. So let me try to copy all this and try to give you. Okay, the practical part will not cover in the today's session. So practical part will cover in the next session. But I just wanted to give you a touchdown with your linear algebra part, right? Okay. And regarding the Python project, someone asked me that we would be having one session with the Python project also. In the next session, we'll take that point, right? Okay. So what you do is you gather all your doubts and your queries, right, regarding your Python project. In the next session, right, we'll assign some dedicated time to your Python project, and we'll try to address all the issues, right? And we'll try to explain that Python project also to you, and whatever issues or concerns you have or you are facing in some programming, so we'll try to cover next part, right? So next Saturday and Sunday, we'll dedicate some time in Saturday sessions and in Sunday sessions. Okay. So quick recap. So what we have covered. So we have covered all these NumPy array. We have covered indexing, slicing, and conditional statements, and we have also seen some projects and the practice assignments also we have done it, right? Okay. So now what we need to think like the learning objectives of this course is basically understand the concept of scalars and vectors, right? Because scalars and vectors are very essential when we are trying to do some analysis. Okay, so one variable is being dependent on the other variable or not. How much it is being dependent on other. Let's say age versus height is being dependent variable or independent variable. Okay, we need to perform some analysis whether this particular variable is of importance or not. Okay, right? Then in that particular sense, we just need to understand the concept of scalars and vectors. Scalar is basically a simple scalar value, right, which has some magnitude, right? But vectors, on the other hand, has some direction as well as some magnitude, right? So we can apply some basic operations for data manipulation analysis, and also we'll demonstrate how we can do a transpose of a matrix for data processing. Okay. So we'll apply the principles of linear algebra using Python programming and also for real world data analysis tasks, right? Okay, fine. Okay, so let us try to introduce linear algebra. So we touch upon what is linear algebra. Okay, so it is a branch of mathematics that deals with linear equations, vectors, and matrices. Okay, so everything what we study is basically your linear algebra, where we are trying to write an equation and represent data in the form of an vector, right? And also, let's say we wanted to represent line, right? So we try to represent a line in terms of a 2D dimension, right? So basically, data is being represented in terms of an 2D array which has some data points, and there we are trying to formulate a line where these data points collide with each other. Similarly, in terms of your data points, it can be represented into n dimension. Let's say I have some data points and I distribute the data points into n dimension space. Whether it's a 2D space, 3D space, then I wanted to make some connections with that data points, whether a line, whether a curve, and I just make some manipulations to it. For that understanding, I just wanted to understand the concepts of linear algebra, how to construct a line, 2D line, how to construct a graph or a circle or something like that, right? For that, I just need to understand how this linear algebra or mathematics can be used in terms of Python code. Because what we are trying to understand math, which is mathematics, which is pure algebra. This mathematics, we are trying to run our algorithm using our Python code. Because data we already converted into Python code, right? Now we have data residing in our Python program. Now we wanted to apply some mathematical formulas to our data, right? So that mathematical formulas, we first need to understand it. Then we just apply with some library so that we can use it. Okay. So it is very essential in terms of understanding of your analytics or deep learning, right? So most of the AI based algorithms, what you see nowadays, has been uh, made or grounded on this concept only, the mathematics part, which is your linear algebra. This is basically the base of your AI, right? So these algorithms have been built uh, on the top of. Okay. So in a broader picture, I'm trying to say that like first you need to understand this linear algebra, come up with the algorithms, the machine learning algorithms, and so on. And there we can just have it on a this deep learning part, right? Okay, fine. Right. So linear algebra represents data in linear equations. So whenever there are data points, so we understand the data points and we represent that equations by use of matrix and vectors, right? So let's say by our data, we have the data, right? So this is a 2D plane. So our data points are being structured in such a manner. So from these data points, we can just see that these are some equations and they are following some curve or path, right? Okay, and this path or curve has some properties, which are some mathematical properties. This path or curve, this is followed, right? So basically, from this we can drive to some conclusions, and then we can represent the data. Right? Okay. So this was the previous slide where we tried to introduce linear algebra, which is the branch of mathematics which deals with linear equations, vectors, matrices, and it is very essential for the understanding of data analytics. The essential parts like you have seen as operations, we see it notation and matrix factorization. Okay, operations, there could be various operations which could be applied on that linear algebra. Notations could be nomenclature, right? So we have performed some nomenclature that based on the mathematics, right? So there is predefined nomenclature that how we can write a vector representation or a transpose representation. So this is basically your notation. And matrix factorization, basically, yes, Deepak. Yes, the LMS manager will try to upload the slides and the PPT. Right. So basically, they are very helpful for the practitioners in data analytics, right? So these parts, the notation, like which helps us understand the algorithm presented in papers and books, right? So this is dot notation, this is x small x, right? transpose, right? So inverse operation, right? Right. So then we have a dot product, right? Transpose. This is modulus, right? So this is your multiplication, right? Right. Right. So these all the notations could be represented, right? And these notations have various what we call definitions, right? If we talk about, right? So these operations have various definitions, and like using our Python code also, so these holds true, right? So these notations in terms of mathematics and in terms of Python may be different, and then we just need to be aligned to that. Maybe dot operation could be different when we are trying to write in mathematics, but the dot operation in your NumPy could be different. Okay, transpose could be -1 raised to power -1, right? Or transpose t, right? This is inverse, this is transpose, right? So it is raised to power t or -1, so that could be different. But in your NumPy operations or in your Python code, that could be different, right? Okay, so this we need to understand, and this we need to relate it in order to when we are trying to follow some paper or book or notation. So this is your standard practice, right? So and while dealing with your Python code, so just make sure that the practice of the notation is exactly the same. If you are referring to dot product, so and you are trying to do a Python code to that dot product, so like it has to be matched, right? Then basically uh, when researchers try to implement your mathematics to your Python code, so they are very careful for their notation. If the notation says dot product and they are trying to do some multiplication, the whole code will mess up. Okay, so in that sense, like they has to be very careful. If they are trying to do transpose, so they will try to do a transpose in the Python code itself only. Okay, but if they try to do some other operations, so that might not work. So this is the basically notation is very important when you are trying to work your actual mathematics and converted that mathematics to your Python code. Okay, right. The operations they refer to some of the operations which are performed on vector and matrices. Some of the common operations are your multiplication, addition, transpose, or your inversion, right? So this we will try to see in practice, like what all operations do we have? We have matrix multiplication, we have inversion, we have addition, we have transpose, right? So this we will try to see, right? So let us try to understand the scalar and vectors. Okay, so I'll just take 10 minutes of yours. Okay. Scalar is a measurable quantity that is entirely characterized by its magnitude. Okay. So only the magnitude is there in the scalar. Okay. It does not have any direction. Whether it is your area, length, or volume, that is your scalar quantity. Okay. But the vector is an object that has both magnitude as well as direction. Okay. It will try to give you that 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 is something which is having some magnitude and as well as direction. Let's say wind which is blowing with the velocity of 15 uh, uh, kilometer or towards the northeast direction, which has both speed and direction. Okay, so this we can see that along the direction also it will see, right? And scalar is something which only have your magnitude, the number, right? Okay, so now the linear algebra represents both your scalars as well as your vectors. Okay, so they are used to represent attributes of entities such as your income, your test scores. Okay, right? And they are often represented by an arrow with the same direction as the magnitude of the quantity. So you, when we try to describe a vector, so there is just an arrow which is your something like an arrow x, and at the top of that you try to represent with an arrow, which is your vector. Your direction represents your this. But in case of your magnitude or a scalar quantity, we just simply replace it by a variable. Okay, right? So they are the most fundamental mathematical objects in data analytics, right? So basically, all these operations undergo the vectors operation, and we will try to study this vector operation. And they are ordered list of finite numbers, right? Okay. So we see the representation also. We have seen that they are often given to represent such entities such as income, your test scores, right? Okay. right? So they can be added together to create another vector object. Let's say speed vector x with the speed of vehicle A, and second vector with the speed of vehicle B, and third vector is your z, which is x plus y, right? And we can also multiply a vector to a constant value, right? We are trying to multiply 2x to obtain 2x, okay? And the result will also always be a vector. If a vector is being added or vector being multiplied by a scalar, the result is always a vector. Okay. So this theory, but why we are trying to do it? Because we need to do it practically, and when we are trying to do some programs or in Python NumPy, so these vectors are really important. Okay. This we'll see. Okay. So now we check which of the following best describes the vector in the context of linear algebra. For data analysis, a single array value representing a numerical quantity, an array of data points organized in a spreadsheet, a quantity with both magnitude and direction, often used to represent data in multi-dimensional space, a statistical measure of center tendency such as mean or median. Okay, so option A, B, C, or D? Yes. So the option is C, the quantity which has both the magnitude as well as your direction, which is often used to represent data in a multi-dimensional space. So often in a NumPy array, what we are trying to do is we are trying to represent your data into your n-dimensional space. This we are trying to do. Yes. Okay. So now the dot product of two vectors. So we have vector 1, vector 2, and we are trying to do some dot product, right? So dot product is the sum of the products of the corresponding elements of two vectors. Let's say this is your vector. This vector is being represented by these values x1, x2, x3, x3, xn, and y is a vector which is an array we call it, right? This could be an array or some data points we call it, right? Which is being presented in some direction, which has some magnitude as well as direction. Let's say these all data points are being represented in one direction or in one dimension. The y direction could be another direction, right? So this way we can interpret this. And we wanted to have a dot product of this particular thing, of this x vector or this y vector or this x array or a y array, can call it. Okay, right? So this we trying to have a dot product, and this you can see that we are trying to do an element wise operation, the x1 y1 plus x2 y2 plus x3 y3 and so on, right? And if we try to see it is in the form of an equation, so this is a mathematical equation which we try to say that this is a summation from I to n, and where we are trying to give a x1 into y1. This is your multiplication, x1 plus y1, then plus, this is summation from I to n, x2 y2 plus x1 x3 y3, right? So this is basically your summation. This is your expression which is being converted into this form, and in the Python we can just do this operation. Understood, right? So this is your dot product, and you need to understand this dot product will try to give me a scalar value, right? So when this dot product, this scalar, this vector will try to have a dot product with this with this another vector, the result will be a scalar quantity, right? Understood up till now? Yes, no? So let's say the dot product of two vectors, x is a vector, y is a vector, right? And we are trying to do a dot product. So 5 into minus 1, 6 into 2, 7 into 5. And this is a scalar quantity, right? So this is your dot product by example. Understood? Yes? No? Are we clear? Yes? Okay. So I will not go further, right? So I will try to stop here, okay? Because up till now, so this is all the theory part. So we'll try to cover practical part in the next session, okay? Right? So this is all how we are trying to calculate the dot product. So just a quick overview. What we are trying to do is we are trying to create one vector A and vector B, and we need to calculate the dot products using numpy dot dot, np dot dot. np dot dot is a, function where we can perform the dot product of these two vectors. And the dot product of this particular vector is a scalar quantity, right? Right. So basically, if you are trying to do this, wanted to know what a particular function does, just put a question mark inside the brackets. So these are the brackets. So this is a function. The function by means it has to be inside your bracket. Okay. And you put a question mark and then you put a shift and tab. Shift and tab. Okay. It will provide you the doc string. Fine. Okay. So reshape. So what does the reshape does? So these numbers, it will try to provide you in the a particular shape. Shape means 3 cross 3 matrix or your like 2 cross 5, right? The first number, what it represents? It represents the number of rows. The second number, what it represents? It represents number of columns. If it is a 2 cross 2, then the first represent the rows, second represent the columns, and it could be your n-dimensional. We call it first dimension, 2 dimensional, 3 dimension, 4 dimension. So we can give any dimension to it. Okay, so this is what the power of arrays. So array could be ND array and it could be n-dimensional, right? Okay, so we have some data. So in the coming classes, we will see that we have a list of data in which we have the person's age, person's salary, person's geographical information, right? Person occupation. So these are some fields. Okay. So these could be rows, could be let's say 1%, 2%, 3%, and it could be 10%, or it could be million persons, right? So those could be number of persons, and the columns could be referring to your age, your your sex, could be your occupation, could be your salary, right? Could be your geographical location. So these are the things which could be arranged in your row and column format, right? So this is could be defined inside your array, right? So that is why we are trying to learn this array, so that when we are trying to work with some machine learning models or algorithms, so this mathematically helps us. Or if you don't know, you can just quickly type it on your Jupyter notebook and just tell me that by question mark and shift and tab, and what is this np dot one does. Yes, provide me the array of ones. Yes. So we can specify the shape, in which shape we can do it, and also the d type we can specify. So what here we are trying to specify, we need a np dot ones that all the elements should be one, and it should have a data type which is your np dot int32, right? So this is what we are providing in np dot ones. Okay. So then we did like np dot add. So these are the methods in which we are trying to add one array with the another. Okay. So this was the array one, and here we are array two. Okay. So here one thing to note, the operation which is being done, that is your element wise. That one is being added to one, two is being added to one, three is being added to three, right? So this is how the operation goes. Similarly for the subtraction also, right? So we can have the np dot add, we could have np dot subtract, then the multiplication. So multiplication also works in the same manner. Here we are trying to work with arrays in which one array gets multiplied with the other. Fine. Okay. So division. So division also is same, in which we are trying to divide one array by other. So let's say we have this array this np dot one. This is your array one, and this is your array two. We are dividing first element by first element, second element by second element, third element by third element, right? So it provides me the division. So, okay, so can anyone tell me what is for mod? So what does it does? It will try to give you the remainder. It will try to divide the element wise, and it will try to give you the remainder. Okay. So these were the some operations we did in our NumPy array, right? So then there were conditional statements. So that we did like np dot where and np dot select. Okay. So np dot where. Okay. So for example, this is an array and the use case, right? So we are more interested in the use case, so why we are learning and how we can apply this into our real life problems. Okay, so as we are trying to work with the large data set, okay, so there we need to do some uh, filtering process. Filtering process means we need to filter the salaries of employees which are greater than 10,000. Okay, so we only are concentrated of those employees where we are having the salaries greater than 10,000. So this is your array. So this is your array in which you have uh, three rows and three columns, right? Okay. So consider this is a first column as the entry of one student or a patient, okay, or could be your stock market analysis, right? So this could be a one stock, this could be another stock, this could be a third stock, okay. This could be a first person information where first row represent or the first column represents your age of the person, your uh, salary of a person, okay, your occupation of the person similarly, right? Okay, so then yeah, I wanted to filter out from this array those employees which having the salary greater than 10,000. So similarly here, like we have made a condition that array is modulo by 2 equal to 0. It is even and odd. Okay, so here instead of this I could simply say, okay, let me run this array. So let us try to understand it, and I will try to multiply this array by 1,000, right? Okay, or 10,000, right? Okay. So now you can see that this array consists of 10,000, 20,000, 30,000, right? So these could be the employee salaries, right? So I was wanted to make this like is uh, greater than 20,000. I need to write greater than 20K. Or here I could write less than 20K. Okay. Okay. So now, so what I did is like I wanted to do the array operation, but I haven't saved that array, right? So this was only trying to reflect on that array locally, but it didn't. I haven't uh, put it into the back to the array one, right? So that is why it was giving me not giving me the results. So now when I try to put it back, so it has given me greater than uh, greater than and uh, less than, yes, greater than, because this we would be using frequently like when we are trying to deal with our large data sets and we wanted to extract some information and perform some modifications. So basically, so this you can make any condition based on your data, right? Okay, whether it is a male, female, also that also you can make it based on the data which you got it, right? But we are working with numbers, so that way we are doing some arithmetic operations to it. So when we deal with your pandas, yes, okay. Hi, Deepak. Yes, fine. So another operation what we did is was np.select. Okay, so this is also very good uh, conditional operation where we wanted to perform the similar operations, right? So np.where is also very commonly used, but np.select is used where we have multiple conditions. Okay, so here we can specify our conditions into a condition list. So this you can see that it is a list. Okay, and there we have the choice list also. Okay, so according to the condition list, so we can perform if the array 1 has values greater than 3, then keep it as array 1 only. It's a no change. If it is having uh, condition greater than 3, then you make those entries to the power of 2. Okay, so this is what the interpretation says. So you have a condition list and you can specify multiple condition lists by a comma separate. Okay, so here we were trying to separate only one condition. Based on one condition, we were trying to give it like if this condition holds, then it is this and then it is this. But here you can perform different conditions also. So that is the difference between your where and your select. Okay. So let's say now we have the salary, right? Okay. So salary have some brackets, right? So according to the tax percentage, right? If it is less than 5 lakhs, if it is less than 10 lakhs, if it is less than 12 lakhs, right? So according to the tax lab, there are various amount of percentage which are being estimated according to your tax. Okay. So there, according to the tax lab, you can just mention, right? Right? Are con list and choices defined variables, sir? No, this is the variables, right? So this is the variable name, right? So you can have any variable name, you can put it here. So this is also a choice list variable, you can put it here. Okay. So if we wanted to see the documentation or the doc string, so you can see that. So this is your con list, choice list, and default. Okay, right? Okay. So let's say if you wanted to put it. Okay, so here you can just put that context. Let's say I will put it here, my variable, like my condition, right? And here I will put my choice list, right? Okay. So now here, this is your default arguments or the parameters of a function. Here you just need to specify my this. This is my condition which goes into your default function on list. And this is choice list, which goes into your my choice list. Fine, right? So this way you can specify. Okay, right? Fine. And the default is for your default that if these, according to these conditions, if doesn't hold true, then make it those entries as your fourth. Fine. So this was your np.select where we have made a condition and your choice list. Fine. Everybody got it? Yes, no? Should I repeat it again? Or shall I proceed further? Yes? Just let me know. Everyone okay with this? Okay. So Deepak, basically what it is like np.select, right? Okay. So np.select, okay, so let me try to give you an example. Let's say we have this array one, right? Okay. So let's say in this, I wanted to separate out those entries which are falls between, let's say, 10,000 and to less than or equal to 10,000, then it is equal to or greater than 20,000, like 10 to 20,000, 20 to 30,000, 50 and 50 onwards, right? So these three conditions I wanted to separate out. Okay. So what I will do is I will try to specify the condition if is greater than or equal to 10,000, right? So if my condition is this, right? So what I wanted to do though with those conditions. Okay. So I wanted to make this divisible by, let's say, 10. Okay. If I wanted to have this condition greater than 10,000 and greater than 10,000 and 1, right? It should be 20, right? Okay. And default, I will not specify anything, and just I will put it. Here the condition could be wrong. Right? So this way I have done it, right? So basically you are trying to formulate a condition. If this condition was true, then you are trying to divide by 10. And if this condition falls greater than 20,000, then it divides by 2, right? So this way you can make this condition and your choice. Okay. So if you can quickly do this and let me know. Yes, everyone, Deepak. Okay. So let me know once it is done. So let me formulate another program. So what I'll do is I'll try to do it a marks. Let's say marks equal to two dot array. Okay. So this is your marks, right? So what I will try to do is I will try to make this condition and choice again. So let me make my condition. So I will say marks is greater than uh, uh, less than or greater than 90. Okay. So give it an A grade, right? So marks is less than is greater than or equal to 60, right? If it is 60 and then give it as a B grade, then I will try to specify marks is less than 60, right? Then give it as a C grade, right? Okay, so this is my condition. Then my choice would be like A grade, then B grade, and this would be C grade. Okay, so I will try to do it and P dot select. Then it is condition list equal to my condition. Okay, then I have choice list equal to my choice, right? Okay, so let us leave as default. Okay, so my choice is not defined equal to. Here I forgot to put equal. The same choice list and default values do not have a common data type. Okay, so let's put a default also. Okay, right, fine. So here we got it. Okay, so now you can relate like what is this implication and what is this select does. right? So you have the marks of the student. According to that logic, you can just give it the grades of the students, and then you can just try to uh, what we call try to modify your data, right, according to these choices and your conditions. Okay, is it fine? Yes, no, Deepak? Okay, so have you practiced this thing? Okay, okay. So, okay, so I'll wait again. Okay, so I want everyone to do it and let me know on the chat they have done it or not. So let me share this code also with you guys. And this is your marks. First, first you need to run this and then you need to run. Yes, done. Okay. So Deepak, okay, fine, great. Okay, so okay, so any doubt up till now? Okay, just let me know in the chat. Okay. So then what we have seen, like a min, right? And this is function is used to calculate the minimum, right, across your axis, right? So this is x is equal to 1. So basically, it is basically your axis 1 means your across your these minimum value across these uh, so 0 is for across your rows and 1 is for across your columns, right? Okay, so across your these things, so it is giving you 1, 4, and 7. So across your vertical lines, so sorry, horizontal lines, not the vertical lines. So along the horizontal lines, it is trying to calculate you the minimum values, right? So sometimes it is confusing between 0 and 1. Okay, so I'll make it in this manner. 1 means across your horizontal lines. 0 means across your vertical lines, right? So this is how you try to interpret it. Fine. Similarly, for the max value, so we are trying to calculate across the 0. 0 is for the across your, tell me, horizontal or vertical? Yes, vertical. Yes, exactly. Okay. Yes. So 0 is vertical, 1 is horizontal, right? Okay. So try to do it in this manner, or else you can just look into the documentation. If it is find you confusing, right? Axis 1, 0. Okay. Right. And it will try to give you the documentation. Okay. In some part it is given, and in some part it is not given. But it is better if you are trying to refer the documentation. Okay. So then mean, median, and standard deviation. Okay. So what is the difference between mean, median, and your standard deviation? Anyone? So what do you mean by mean, guys? Yes, average, right? So this is basically you need to do it in every operation. So basically it is try to calculate the average, right? So you have the data points and you wanted to find the average, right? And median. Anyone can tell me about the median? Yes, median is the middle value. Okay, middle value. Yes. So in case, let's say you have the numbers, let's say 1, 2, 3, 4, 5, right? Okay. So can anyone tell me what is the median here? Yes, 3 is the median because it is the middle value. So 1, 2, 4, 5. So here 3 is the middle value. If I try to put 6 here, so now can anyone tell what is the middle value? Yes, 3.5. Yes. So because 3.5. So 3.5, why it is 3.5? Because now this part and this part. So if we try to divide this part into two parts, so first three parts is this and second three part is this. And the middle value is 3.5, right? So this is how the median works in case of your odd and even parts. Fine. So this you need to make sure that if you're trying to calculate for the odd part, so the median is the middle value. And for the even part, okay, to divide by 2. Okay. So you try to divide by 2 the numbers and then you try to divide by 2 and find out the middle value. But provided you need to arrange those values in the ascending order first. Okay. So this is the basic rule. Fine. Okay. So now variance. Anyone? Yes. So basically the square root of standard deviation, right? So we call it that, right, variance, right? So basically variance is the fluctuation, like how the two values are in conjunction with each other, how it is being separated, linearly separated with each other, right? So that is what we call it as a variance. Okay. So the under root of variance is your standard deviation, right? Okay. Right. So this is some of the arithmetic operations that is very useful when we are trying to work with the data. So practical implementation. So let's say, uh, so in our monsoons, right? So India is trying to record the what is the average rainfall, right? Recorded in the month of June, right? So like what is the highest, right? Rainfall which is being recorded in the month of June, right? So their median, highest, right? So highest means highest peak, right? Or you can see that, or the mode can also be calculated, right? Right. So their mean is the average. So how much average rainfall we are trying to get it, right? And the variance is that like how the data points are separatable by each other, right? Plus minus, you can say that, like according to the yesterday's temperature and now today's temperature, how is the temperature fluctuating by how many points or how it is being varying, right? So that is being calculated as a variance, right? So these operations, these statistical operations are very useful when you are trying to do some analysis. Okay, that is why we are trying to learn this first, and programmatically we are trying to analyze it. Okay, got it? Everyone? Yes? No? Okay, fine. So now, then this slicing part. Okay, so slicing part is very important. So I gave you an activity also based on this slicing part. So I think everyone has done it beautifully, right? So those who have not followed, so I'm repeating again. We have the array, right? So it is a 3 cross 3 array. So I wanted to get the entries of the particular array. Fine. So for example, so zeroth at the zeroth position of the zeroth row and the first column, right? So what is the entry? So this before comma represents the row, and after the comma represent the column, right? So what we are trying to say is at the zeroth column and first column, what entry we are trying to have in an array. So the entry is 2. So zeroth row, first column, 2 entry, like two value, right? Second value, this value. Okay. If we wanted to have all the rows, so only we specify 0 or 1 or 2, right? So this is basically we are trying to specify all the rows. Okay. For this slicing, what I've told you that row from this row to this row and from this column to this column. I just wanted to have it and sliced part of the array, right? It means that from 0 to 1 and from first column and onwards, I wanted to have that array, right? So, for example, here 2, 3, and 5, 6, right? So this is what I want, right? So you can see that like from 0 to 2, so 0 to 2, both these entries, and from 1 to this thing, from 1, so this is your first row, from 1, right? So you can have only 2, 3, and 5, 6. Okay? So this is how you slice. Okay, right? Fine. So anyone having doubts? Should I give you an example to practice? Yes, no, yes. So let me give you an example. Okay. So array 1. Okay. 1 to 10. I'm trying to make an array. Okay. And I will try to make it dot reshape also here. Okay. So instead of putting the commands in you can put it in the single of this thing also, right? So what I am trying to do is first I am trying to make the array of elements, the single dimension array of 1 to 10, right? For 10 elements, or basically it's the 9 elements, right? It will start from 1, but it will end at 9. Okay. Then I'm trying to reshape it, reshape it into a 3 cross 3 matrix, right? So if I try to put this array, right? So now I have a 3 cross 3 matrix. Fine. Okay. So similarly, I could give a 5 cross 5 matrix also, uh, in which 1 to 26, and it is a 5 cross 5, right? Okay. Fine. Okay. So from this particular array, first all of you make this array 5 cross 5. So what I want is I want these elements 7, 8, 9, 12, 13, and 14. Okay. So I will just write it here. What the output is. Output I want 7, 8, 9, 12, 13, and 14. Okay, everyone has to do this activity. So first you need to make an array of size 5 cross 5, and then you need to filter it out and give me the code in which you will try to give me 7, 8, 9, 12, 13, and 14. Yes, Deepak, when we are trying to run this, okay, so NP is basically you had to run this import NumPy as NP every time. Okay, so this is the library which we are trying to run. Okay, so you are trying to import this library. This is the external library. So first you need to run this. After that running, you just need to run the commands which I'm trying to show you. Is that fine? Yes. So do you want? Okay, fine. Okay. So now then the next part which we have seen is loading our CSV, right? So there it is a simple operation where we are trying to load the CSV, and whatever is present at the CSV, we are trying to print that as a array, right? Okay. So these are simple functions where you have some data and the delimiter. So delimiter is basically the CSV format. So CSV format is always a comma separated format, right? And you need to specify that the type of data type which that CSV hold is of string data type. So it may be integer also in some cases, right? But you need to specify that. Okay. Similarly, this is also another operation generated from txt, and this is your load txt, right? Then we can also save the numpy in a text file. Okay, so where this is used? So suppose in the previous example we have done some operations, right? So now this operations we have done it. So let's say you got the list of students and list of marks, okay? But you don't know that where that marks could be graded, right? So the grading scheme could be simple enough where you are trying to load the CSV and convert into a NumPy. And then after that, you perform operations and then you save it again as a TXT, right? So this operation is very much useful where you can perform some operations and give the result back to the desired persona. Fine. Let's say the manager says that, okay, I want you to this as CSV where it is having some data, and your task is to just do some operation onto that file using NumPy, and then give back me the results in the same format. Generally, it happens, right? The file you are working, so the customer or the client wants that information in the same format which you have given as an input format. So there, these operations or these uh, functions are very handy to use. Okay, so these are very handy to use, and this you can do it by using your save txt or save, and then you are trying to load. Fine. Okay. So in future in further analysis, we will try to do some operations where we are having some CSV file. There we are trying to load it by using pandas also. The specified format or the well-known format is your pandas. So here we are trying to load a single NumPy, but in pandas we could load a CSV and then make some analysis. Okay, so that is what we are trying to learn today. We will have the introduction to pandas today, and then we will look it upon. Fine. Okay. Okay. So we started with the linear algebra, right? Okay. So linear algebra is this branch of mathematics that deal with your linear equations, vector, and your mathematics. Fine. Okay. So why it is essential? Because every numbers is being associated with your another data points. So we just wanted to match some relation with that number. Let's say your age is increasing. What will have that impact on your salary? Your salaries has to also be into be increased, right? Okay, right. So there has to be some kind of a linear dependence among that data types or the data points, right? So that is basically why we are trying to learn the linear algebra. So linear algebra is basically we represent data in the form of an equations. Okay. So whether it is a straight line, whether it is a curved line, right? whether it is a declining path or inclining path. So there we can just make some analysis. Let's say the as the car is getting older day by day, it is the price of the car is decreasing, right? If we get a declining path or a negative gradient, right, or a descent, right, so then we can just make some predictions easily. If it is a higher, so then we can just make that okay, the age of the person is increasing, this average has to be rise, as we have seen that trend. Fine. So that is why if we try to represent your data in the form of an equation, so then the analysis is very easy, right? Okay. By looking at the number, you cannot make some analysis. Understood? Right? Okay. The essential part of the linear algebra performs some operations that we perform some operations on their linear algebra part or the for the analysis. Then we have notations and your matrix factorizations, right? So these were some of the notations that we already know. So dot, transpose, right? Then we calculate the norm, right? Right? Distance, right? Okay. So normalize, right? So these are some of the operations we will try to learn. Then matrix, already we have covered this matrix part, which we are trying to have a multiplication on the matrix. Okay, inverse, addition, and transpose we will try to see today. Okay, okay. Then the scalar is a quantity which is entirely characterized by its magnitude. So scalar, we don't have any direction, we only have its magnitude, whether we call it as area, length, or volume, that are being scalar quantities, measurable quantities, right? So area we can have a measurement, right? So area we can measure it, right? Volume also we can measure it, that how like what that quantity, how many liter of that quantity we have, right? But vectors is something which we have your magnitude as well as direction, right? So we, for example, velocity. So wind is blowing at the speed of 15 kilometers per hour, right, in the northwest direction, right? So which we have both the speed as well as direction, right? So this is how we represent your vectors. And vectors can also be represented in the form of an letter X or with an arrow. Arrow of what means that it is a vector, right? And they are the most fundamental objects in data analytics, vectors, right? So because so vectors, basically we study vectors in your linear algebra, whether it is your income or your test scores, or already we have discussed, right? So that is also considered as a vector, right? So first we can add a vector, we can multiply a vector, okay? So create a third vector, which could be in addition to uh, uh, addition of first vector to each second vector, which can also be multiplied by a constant. Okay, so this we will try to see in practice, right? That how we can have a vector which could be created, and then we can multiply that vector by a scalar. Okay, so now the dot product. So dot product is also very important. Dot product is a scalar quantity, which we have two vectors, that vector x and vector b by. Okay, so this dot product, we are trying to calculate the resultant of these two vectors, which is a scalar quantity, which is independent of that vector, right? And how it is being calculated? The individual elements are being multiplied, and it is being added to every element. Let's say x1 multiplied by y1 plus x2 multiplied by y2 plus x3 multiplied by y3 and so on, right? So dot product, right? Basically, like it is very essential when you are trying to find the distance as you go deeper into your machine learning or your deep learning. So, so dot product or cosine similarity. So these topics are very important in finding the relationship between two objects or two vectors, right? If you wanted to calculate that how similar these two items are, then we calculate the dot product of two vectors, right? Fine. Or the cosine similarity also we call it. Okay. So this is how the mathematical expression where we are trying to calculate the dot product. So we have this vector 5, 6, and minus 7. And this again another vector which is minus 1, 2, and 5. So here we are trying to calculate the dot product and it is a scalar quantity. Okay. So whenever you are trying to open your Jupyter notebook, it is very important. First, you are trying to import the NumPy, right? So that is why you are trying to get the error that NumPy is not defined. Okay. So this is very important. Okay. So then let us try to first create the array, right? Okay. Yes. So np dot array. So let us try to create one array. Okay. So just try to type along with me, guys. Okay. I'll try to take some arbitrary values. I'll call it as a. What has happened? I forgot to mention here. Yes. So now this is an 3 cross 3 array. Here it is an 3 cross 3 array. Right? Okay. Okay. Great. So here these are the arrays and this is the operation of dot operation in where you are trying to do a dot product of those two arrays. Right? Okay. So always like there, like basically the dot product happens, right? This I have taken a 3 cross 3 array. So I could take a simple array also, a simple operation also, which I have shown you in the slide that this is the single element and this is your single array, a 1D array, right? So there also we can just formulate it and then this is basically your 42 is coming. But here, how this 11, 14, and 9 are being calculated, just look at this operation. So the first, this thing is being multiplied by 1, 2, and 3. 1, 1s are 1, 2, 2s are 4, 2, 3 are 6, right? So this is how it is being multiplied and the resultant is 11, right? If I try to give you a simple demonstration where I could say numpy.array, here I would simply say 1, 2, comma 2. And this is your y. And p.array, here 1, 2, and 3, right? And then I will say and p dot x comma y. You can see the answer comes to be 11, which is a scalar quantity. So this is how your this operation has resulted. Okay, quickly do this and try to just let me know if you try to multiply this right with this. right? 2, 4, and 2. Then this with 3, 2, 3. You get the 4 and 19. Then the second entry, then with the first, right? Similarly, you can get all the values calculated. Fine. Okay. Now, just let me know if you wanted to calculate, right, this 14. Fine. So how this 14 will come? So third row multiply with the first column. Okay. Just give me the points. Just do it and just try to put it in the chat. The So everybody has to do it. Understand the concept, guys, right? Okay, so this was the single, right? Single, like column entry and this row entry. So this we are trying to do it, right? Okay, so this is how the dot product is being calculated for the one dimensional. So every piece is breaking into one dimension, and then we are trying to put that values inside your three dimensional, right? So this you need to understand the how this dot product is being combined when you are trying to loop it into your whole array. No, matrix multiplication rule will follow basically, right? So what you are trying to say is correct, right? So if you wanted to see this thing, right? So first row and this third column, right? So this is fine, right? Okay. So if you wanted to have the this second row and second column, it will give you this 16 entry. If you have wanted to have your this entry, right? So this third row, okay, and your this column, right? So automatically it will follow. So let us move forward. So we have already created one array, right? Okay, so this is the array. So if I wanted to multiply with any scalar value, let's say I wanted to multiply it by 3, right? So I can multiply it. But the thing is that this will not get reflected into the array until and unless I do it a equal to a into 3, right? So now every entry gets multiplied by 3. So this is basically your scalar multiplication in which we are trying to multiply this thing, right? Okay. So let us try to see uh, the transpose. Can anyone tell me what is the transpose? So what is you? Yes. So basically transpose is basically we try to interchange row to columns, columns to row, right? Or vertical to horizontal or vice versa, right? Okay. So how in a NumPy we can perform this transpose operation? So this we will try to look it out. Okay. So for that, let us try to see a simple array, right? Let's say I try to have an array one, okay, equal to np dot array, right? And I will say one, two, three, okay. So a1 is this array. So I wanted to make this as a transpose, right? So let us try to see the shape also, 2 cross 3, right? So I will say b equal to, or I will say a1 underscore transpose equal to np dot transpose, I will say a1. So you can see that the first row has become your first column has become your first row, and your second row has become your second column, right? If I try to say a1 underscore transpose dot shape, it is 3 cross 3. Then we'll follow the introduction to matrix. So this we already know that like it is a rectangular representation with rows and columns. So this I'll skip. Then it is a matrix multiplication, addition, scalar multiplication, and subtraction. So this we have already seen, right? So matrix is basically your when we are trying to add some matrix. So the corresponding elements are being added, right? So two matrices of different orders cannot be added. right? Only the same order matrix can be added. So if you are trying to add your different order matrix, so that will not happen, right? So here there is a simple demonstration where how we are trying to add your 3 cross 3 matrix, and the resultant is also a 3 cross 3, right? Here we are trying to add x and y. So 2 plus 3 minus 1 plus 2, 5 plus 9, right? So element wise operation follows it, right? In which we are trying to add some matrix and give the resultant back, right? Fine. So this is the theory part behind it, like how we are trying to do the addition. And how in NumPy it is very easy that numpy dot add, numpy dot subtract. So this we have already seen in the previous session, right? So this I think we don't need to give much time to this. Subtraction, that is also very easy, in which we are trying to subtract that matrix, right? Element wise. So every element corresponding to that every element in the other matrix is being added or subtracted or multiplied, right? Scalar Scalar is basically every element is being multiplied, either it is being divided or multiplied. So every element gets its operation, right? 4 into 2, 8, 0 into 2, 0, 3 into 2, 6, right? 7 into 2, 14, right? And this is also how this scalar multiplication happens. Fine, right? To obtain the product of two matrices, multiply the elements of rows with the first matrix with the corresponding columns of the second matrix, right? So this is what like I think someone asked me this question, right? So we are trying to have this rows and columns, right? So rows of first matrix is being multiplied by the columns, and the resultant we get it, right? 1 into 7 plus 2 into 6 plus 3 into 3, right? Similarly, we are trying to have this matrix multiplication, right? So in this picture, we are very much clear that 2 into 5 plus 0 into 2 plus 5 into minus 3, right? So this will give us the first entry. So 2 into 1, 0 into 2, 5 into minus 8, it will give us the second entry, right? So then 8 into 5, minus 3 into 2, 5 into minus 3, it will give us the third entry, right? And 8 into 1, minus 3 into 2, 5 into minus 8, the fourth entry, right? So now see the shape. So this is your 2 cross 3. This is your 3 cross 2. And the resultant is 2 cross 2. Right? In the matrix multiplication, so this is basically your high school mathematics operation where we have a matrix, right? With this 2 cross 3, and this is your 3 cross 2, and the resultant is your 2 cross 2. Okay. So determinant is basically like we are trying to calculate for a 2 cross 2 matrix like AD minus BC. So this is how we try to calculate the determinant. But for the 3 cross 3 matrix, so what we need to do is we need to first keep this A aside and then calculate the determinant of a 2 cross 2 matrix first, then minus B, then D, then this minus P, and then DI and FG. So this we can calculate, and then plus C, right? Determinant of this. So it is a scalar quantity, guys. Okay. So this is how we are trying to calculate the determinant of a matrix. Okay, so we'll try to see that this is a mathematical operation, right? So this we already seen in our school grade, where we have some numbers, and then we are trying to calculate the determinant by using this multiplication of this matrix and then multiplied by A, then minus B, and doing some math, we get that scalar quantity, right? Fine. So this is how we try to calculate the determinant. But when it comes to your Python, so this is done by a single operation, which is your NumPy, right? It is providing us the library where we feed this matrix, whether it is a 2 cross 2 matrix or a 3 cross 3 matrix, and the job is being done by the Python. Okay, so you don't need to calculate this long lengthy math and try to fiddle with your mathematical operations. it automatically it will try to give you the result as a scalar form, right? Okay. So let us try to see this determinant calculation in practice. Okay, right? So I'll try to have a matrix 1 equal to np dot array. So this is your matrix, right? Right, it is a 3 cross 3 matrix. Fine. So now what we do, we will try to calculate the determinant. So np dot linear algebra. So this module is your linear LIN algebra, right? So we call it linear algebra. In this linear algebra, we put a dot again, and then there are some methods, right? So for the inverse also we'll try to see it, right? Then matrix norm, rank, transpose, right? SPD. So this we'll try to see in coming lectures, right? Right? How to do it, right? Right? Then we'll try to see the determinant. So this TET is basically for the determinant. Let's just try to see this, right? Computes the determinant of an L. Right? So this it has given us a nice example where we have a array and this you are trying to calculate the determinant. Fine, right? So this is your matrix which is of shape of 3 cross 2 cross 2, and this is how we are trying to calculate the determinant. Fine, right? So let us try to calculate the determinant of our matrix, what we have done. Okay, so everyone has to follow along with me and let me know, right? So this is your floating point value and it has got minus this, right? So it has given us a long value. Instead of doing, I will try to put a round in front of it so that it will try to give us the round of value, right? So round of value is given us 0, right? So the determinant of this particular operation is your 0, fine, right? So just we need to check whether the determinant of this, because it was a negative, so negative we don't consider it. So that is why we round off and it is given as a 0. So either the determinant of one value is 0 or non-zero. So there are two things. On the basis of that, we find some derive some operations that if the matrix is determinant of a matrix is 0, what will happen? And if it is non-zero, what will happen? Okay. So up till now, just try to calculate the determinant of a matrix and then let me know. Yes, everyone. Everyone try to calculate the determinant of a matrix of a 3 cross 3 matrix. You can just fiddle with the numbers also and try to change the numbers and let me know what you got. So np dot linear algebra, right? So this is your library and it has follows your DET. So DET stands for your determinant. And here you need to pass your matrix. Okay. So you just need to do a round off because determinant has to be either 0 or either non-zero. Fine. So that is why we are trying to calculate the determinant. Everybody done? Okay. So now what we know, we have calculated the determinant, right? So now there are some properties of the determinant. If the determinant of a square matrix is 0, right? So this means now like for a square matrix, so here in our case, right, it is 0, right? So then it is non-invertible, right? And if it is non-zero, right, then the linear system, it represents your linearly dependent, right? So let me try to give you an example, right? So let's say if the determinant is your 0, right? And uh, right. So if the determinant is 0, right? So then it is non-invertible. Yes, Virender. So first you let me know everyone has done this determinant. So then I'll try to explain you. Everybody done? Just put it in the chat. Yes, Virender. Because without rounding, you are trying to get a negative value. So negative is basically we don't require, right? So that is what we uh, this thing, right? Okay. So what I was trying to tell you, like if the determinant of a square metric is 0, then it is not invertible, right? So if it is not invertible, right? So that is basically you have a solution. You have a unique solution, right, of these particular metrics. But if it is invertible, that it is non-zero, right? Then either there is no solution or there could be infinitely many solutions be possible, right? So linear system, it represents a linear independent, right? The columns inside your matrix are not dependent on each other. They are linear independent of each other. Fine. And if it is 0, the rows are linearly dependent upon the vectors. Okay, so this we can see by a simple example where we can make this particular what we call a matrix, right? And then we can see it. Okay, so yes, I'll repeat this. So let us try to take a matrix, right? And p dot array. I will try to give you a simple example, and then I will try to show you. Okay, right? So let us try to calculate the determinant of this matrix. So how I will calculate? NP dot linear algebra, right? And dot determinant, right? And then I will put x into it. Okay. Okay. You are trying to calculate a floating point value, which is negative, and I will try to put a round value, right? So now this is your -2, right? Which is not equal to 0. Fine, right? So here, this is your invertible matrix. 1, 3, and 4 are not dependent on each other, right? So fine, right? So this is invertible matrix, right? Okay, so let us try to take another example where I will try to show x1 equal to np dot array 1, 2, and 2 and 4. Right? Here also I will try to calculate. Right? So now you have got 0. Right? So this is your not invertible, right? And you can see that. So your 1, 2, right? And your 2 and 4 are dependent on each other because 1 into 2, 2, 2 into 2, 4. Here 1 into 3 and 2 into 4, they are not related to each other. So they are independent. Fine. So this is how, if your matrix and the determinant of a matrix is 0, non-invertible. And non-invertible, this means it linearly dependent vector. Is rows, first row, second row is linearly dependent vectors, right? If it is non-zero, then the linear system is independent, right? So this we are trying to say it is independent. Now, Virender, you got the point? Yes, no? Yes, Virender? Okay. So any doubts, any thing you want me to repeat, just let me know again. So we are trying to calculate the determinant of a matrix. So this determinant is very important when we are dealing with your algebra, linear algebra, right? So we wanted to check whether your rows are linearly dependent or not, right? In case when it is your zero, your determinant is zero of any matrix, then we call it as a non-invertible. And where your rows are not are dependent on each other, that 1, 2, and 4, if you try to multiply by 2, so they have a dependency. If it is 1, 1 means non-equal to 0. Yes. No, no, no. You got it right. Means if it is 1, then dependency, and 0 means no dependency. Yes. 0 means it has the dependency. There has to be some kind of a relationship. Na? So there is a relationship. If the determinant is 0, there has to be some kind of a relationship. But if it is non-zero, non-zero means not equal to 0, then there is no relationship. If these values or these rows are independent of each other. You said it wrong. You said it the other way. Now you got it? Yes, Virender? Okay. So this is how we define the determinant of a matrix, right? Okay, and this is how we calculate the determinant of a matrix. Okay, so by use of your linear algebra operations dot determinant, we can calculate the determinant of any matrix. Similarly, we also can calculate the inverse of a matrix. The inverse of a matrix is such that X is a matrix and we calculate this inverse, then it is equal to the identity matrix, right? Okay, so this is how we define the term invertible, right? So invertible and non-invertible, it is tried to say that when a matrix is said to be invertible, when it is the inverse is being applied and we get an identity matrix. This is how we try to say that your X is invertible. If we doesn't get is X into X inverse equal to identity matrix, then we say that the matrix is non-invertible. Right? This way also interpretation we can get it. Right? So this is all math basically what we are trying to learn. And in your linear algebra books, you get these properties and these expressions often, right? But mathematically or in Python, how we can solve it? So that I'm trying to show you, and then a little conceptual knowledge of these concepts, right? So why inverse? Because we wanted to check whether a matrix is invertible or non-invertible, and how we can check that if the matrix is multiplied is inverse and the resultant is an identity matrix. So there we can check. Okay. So this is how your X and your X inverse. Okay. So this X and your X inverse, how it is being calculated, you interchange the elements, right? The diagonal elements, right? 3 to 2 and minus, and the rest of the elements you make a minus of it. So here you replace 3 to 2 and 2 to 3 and rest of the elements minus 1 to minus 5. Okay. And also you try to calculate into 1 upon the determinant. So here, right? 3 to the 6 minus 5, it is 1. So determinant is 1. So basically, you also try to calculate the determinant. It is non-zero. It should not be equal to 0. If it is equal to 0, then this you cannot calculate. First, you cannot calculate. So the first condition is being provided, the determinant you can calculate the inverse of. and matrix. Right? Okay. So let us try to see this part also, the inverse of a matrix, right? So let us try to calculate the inverse of this matrix. So we have this matrix. Okay. So right. So this is how you could try to calculate the inverse of a matrix. So we can give a round of it also. Round it doesn't support, I guess. Okay. So basically, this is your personal expense tracker, right? Okay, fine. So basically, what you need to do is you need to manage your expenses efficiently, right? Okay, so this is your day-to-day problem statement where you have assigned or you have been given some expense, and then you need to log your daily expense. You need to categorize them and track spending against them, right? Or let's say if you try to spend on food items, so you just need to have a track that how many items or how many items are purchased, and on the account of that, like what was the amount as stated, right? And that is like how many monthly budget do I have? Let's say I have $100, right, for the monthly budget. So I just wanted to daily wise, like I always wanted to make an tracker where every item I purchase or every activity I do, I just need to make a entry against that. And I wanted to store it in this format. And in the end, I could just see that how many items I've purchased or goods I bought and in which category I bought them, and on the basis of that I will try to manage my expenses in the against my monthly budget, right? So basically you need to do it and store it in the case of your Python program. Okay, so guys, understand this. If you're beginner, if you're new to this, so just try to take a pen and paper first, okay, and try to write some Python code, which is a pseudo code. Okay. So let's say I am a newbie into this project. So what I will do is I will try to first read this. Okay. That we need to design and implement a personal tracker that enables user to manage their expenses, first of all. Then allow users to categorize expense and set monthly budgets and implement your file handling functions. And we need to also create an interactive and menu driven interface for use. So these are the four objectives which we have assigned for it, right? So first task is to that read your problem statement thoroughly, take the points, what you just need to build and how you need to build it, and then you just need to break down that steps into smaller steps. Okay, so this could be your company project also in future. Okay, this could be your problem statement when you get from the clients also. So clients also give it in this manner where they will try to tell your problem statement, and they also try to set some objectives and the outcomes. Okay, right? So now let us try to see that these are some of the steps. Okay, so this description is written beautifully, guys. First of all, I tell you, right? We need to create a function first of all for the add expense, and then we just need to ask the user for the date, for the category, and the amount spent and the description. Okay, based on these steps, let us try to write a pseudo code and try to come up with. Let's try to do this thing. So in this only I will try to do this, right? So what we are trying to do is from the first operation, create a function, right? So let's try to create a function, right? What would be the function name? Add expense, add underscore expense, right? So this is the function name, right? So this is your function add underscore expense. Okay, right? So here we need to ask for the user the date, the category, the amount, and the brief description of the expense. So what we need to do is we need to write the input method, right? And here we just need to write four input methods where we need to ask it from the user, right? Fine. So here enter the amount, enter the what we call. So enter the date, category, amount, and description. Date, right? Similarly, you have the category, right? So I'm giving you the pseudocode, right? So this is how you are trying to category, expense, and description, right? So this is your first function in which you are trying to add the expense. Now here you are trying to add it date. Here you have category, you have expense, right? Then you have your description. Fine. Up till here, anyone of you having any doubt? Virender, just let me know. Okay. So this is how you create one function, right? So this is how this is being created, right? Okay. So now what you need to do is store the expense in a list of dictionary, right? Where each dictionary includes the category, amount, and description and the key value pairs. So this is how you try to create your dictionary, right? Right. So here you will try to create some dictionary, right? How you try to create a dictionary. So this is your data, I will call it. This is your empty dictionary, right? And then you will try to create data equal to, here you will put a date equal to date, right? Similarly, category equal to category, right? And so on, right? So this is how you will try to create a dictionary, right? After that, like you are trying to return this data, right? So this is your data. This is your function in which you have created one entry, right? And this entry could be stored inside your list. You can put it in the final data. Final data dot append, something like that. You can do is, and here you can add your data, right? So this is how you are trying to create one function based on the description what you have got it. Let me close this, right? Based on the expression what you got it, right? Now you can view expense. You can write a function to retrieve and display all stored expense. Ensure that function loops through the list of expenses and displays the date, category, amount, and description for each entry, right? Okay. So it also tries to validate the data before displaying it. So this validation you can just try it out afterwards when there is enough data you try to accumulate, right? View expense. So add expense. Now you try to calculate, write another function which is view expense, right? So here your final data, right? So this final data you can just put it inside your this file also, right? With open expense.txt, right? In your append mode, right? So f dot f f dot right, and then you can get a final data, right? So view expense, you can just read this with open, then you can read this in read mode, and then you can just f dot read, right? Okay, you can store somewhere, let's say data, and then you can just uh, return this data, right? So this is basically add expense, view expense, right? So this way you need to make some function, right? Set and track the budget. So create a function that allows the user to input a monthly budget, prompt the user to enter the total amount they want to budget for a month. Fine. So the first you need to ask the user that how much amount they want. Then it calculates the total expense and compares with the user's monthly budget. So here the expense. So here also you need to make this final data, and there you need to calculate that how much expense it has been entered, the final expense. So these entries, you just need to add all the entries and just make a final expense. And then you just need to compare it. Fine, fine, right? Any doubts up till here? Yes, no? Anyone? Virinder, Sisti, so Sudhir, any doubts? Okay. So basically now this is for the load and the save expense, right? Implement a function to save all the expense to CSV, and with each row containing the data, category, amount, and description. And we also need to function to load the expense from the CSV, right? Read the data from the file, load it back to the expenses so that user can see their previous expenses and continue from where they left off. Okay. So the agenda of this particular project is that like these are small functions. You just need to first make it. Okay. And in the end, you need to create an interactive menu. So for example, option first, you need to add the expense. Option two, you need to view the expenses. So first you will try to add the expense, and then this added expense, you will take it from the user and it will try to add it into your data where it's being stored somewhere else. Okay. From the view, it will try to read those data file and try to read all the expenses you have viewed. Then track budget. Track budget is that you set your monthly budget, and on the basis of that data, you just calculate how much total expense you have made. And based on that, you just need to select, you need to tell that user that this month much you have spent it and this much is left for your daily or your monthly budget, right? Then the last option is your save expenses. Save expenses is that you save all the expenses into a CSV file. We have also already saved it to the CSV file, and you just load it back, right? Or read the file or load it back from where they have continued from the, or you can just download that option, right? So this also you can make it. So this you make an interactive menu in which you can just say that like you can write a main function, right? And in this main function, you can just tell, or you can just say that menu options. Menu, you can say that menu, right? And in the menu, you can just say user will try to select an option, right? Option you will try to select from the user. Then after, if the user, if option equal to 1, right? You need to add expense. Go to add expense method, right? If there is option 2, then you go to save, show expense or view expense, right? Similarly like that, right? And if this is no option, then you try to break. If not of option, right? Not option or not option, right? You just say that break, right? No option is being selected, something like that, right? Okay. And this you call this as the menu in the main function, right? Right. So this is how you are trying to make some program, and this is the pseudo code which I have given to you. Okay, I'll just type this pseudo code in the chat so that like it give you an idea, right? Basically, you just need to first uh, uh, scribble it down in your pen and paper, and then you try to formulate in the piece of program. Until unless you don't try to see the clear instructions and match that clear instructions according to the code, so that will not happen. So we started with NumPy. We imported this NumPy as NP. So this is very important, guys, right? If you are trying to work with your NumPy library, so it is very important you first import that library into your this Jupyter notebook, right? So then we created two arrays, array one, array two. Okay, and then we did a dot product, right? Okay, so dot product is basically the element wise, right? The first row and the first column, right? First row, the second column, first row, the third column. So and so these elements get added up, and it is an element wise operation. Okay, so right, one, two into two, two into three, right? So this way the element was added and the resultant we get it here. Okay. So dot product, we got it, and yeah, this I showed you how a single row and a single column gets multiplied element wise, and then we can get the values. And here you can see that 11 was displayed. Right? Okay. Then the scalar multiplication. So A was a matrix, and then we try to multiply the A by 3, right? And there we could do it, right? So we did np dot array, we made an array and we tried to calculate the shape, and the transpose, the it is basically the interchange of your columns and your rows, right? So we did that, and then we calculated the determinant of a matrix. So determinant of a matrix is very important in case of you are working with your linear algebra. It gives us the invertible and non-invertible, right? Okay. So uh, yes. So if the uh, determinant is zero, right? It is invertible and matrix, and we have the independent values, right? And if it is not zero, then it is non-invertible, right? Then we have the relationship, right? So this we have this. Okay, fine. Okay, so then another part we did the inverse of a matrix. We can calculate the inverse using this library, which is called as linear algebra dot inverse, right? And the determinant we can calculate by linear algebra dot determinant with the et short for and matrix, right? So this is how we calculate the determinant and your inverse of a matrix. Okay. Okay. So before moving on today's session, so I also want you, have you guys used Colab? Anyone? Colab notebooks? Fine. Okay. Right. So I will also give you an introduction to Collabs, right? So because as we are trying to progress with the code, so it is very essential that you get to know the tools which are required in the market, right? So not only we are working with Jupyter, so in future we will be working with some other tools also, right? So from time to time, I would be guiding you, I would be assisting you in that tools also. Okay. So so let us try to see the tool. Okay. So so this is your Jupyter notebook. Okay. So this Jupyter notebook works perfectly fine when you are dealing with your small data. Okay. So what happens is that like when you are trying to deal with your data and you are trying to do some analysis onto your data, it depends upon your computational resources of your system, right? So what do you mean by computational resources? Can anyone tell me the computational resources of a system? Right. When you are trying to run your notebook, okay, and do some analysis, right? So it takes time for the analysis when there is a large data, right? Some processing has to be done. So in that processing, what actually happens? So let's say I'm trying to work on your data, right? So if I try to work on a data, so it takes some fraction of seconds to get the job done. In that fraction of second, at the background, what is actually happening? Okay, so I'll tell you what happens is, let's say you are trying to work on some project, right? And it has got around, let's say, 10 GB of files. Okay, so then you are trying to process that data. Okay, so you are trying to work with NumPy and you are trying to calculate, let's say, mean, or you are trying to calculate your what we call variance, right? So when you are trying to work or write some function or this inbuilt function like mean variance or something like that, and you try to act upon that data, right? Your system resources are being used. Okay. So when you are trying to work on your data, suddenly you feel that your system is getting heated, like heated up, right? So your fan is boiling, right? And it makes some noise, right? So this means that like here is the operation which is going into the memory. From the memory, it is going into your CPU, right? And then it is trying to do some work, and after it is done, it will give the result. Okay, so your processor is also in progress or in work, and your RAM is also in progress in work. Right after the job is being done, then the system resources get freed up, and then you can get the job. This is how a normal computational system works. Right. So when you are trying to work on some data, right, and your system memory or your GPU, like 8 GB RAM or 16 GB RAM, or let's say you have a RAM or a processor, right? Intel processor or a Mac processor or a Linux processor, right? So these processor gets in action and then they are trying to fetch the data or fetch the results for you. This is what the normal architecture or the nomenclature does for any of the operation which has to be done, right? But in some cases, you have heavy amount of data, let's say 10 GB of data, which your system is unable to handle that amount of data. Here you need larger RAM or larger GPU, right? Right to give you the output. Okay, to give you the output or to handle those files. There, then there's a challenge or a limitation that you cannot work with that data because the data is so large, it cannot be, your RAM is, let's say, 8 GB and your data is 10 GB, right? So when you are trying to load the data, so it will not get loaded because of the memory constraint, right? In that case, what we do? Okay, there are some techniques which we can do it, but on a global picture, on a higher picture, what I'm trying to give you the gist is that this Jupyter notebook, right, is in being working on your system and is being using your resources, right? Mine would be, let's say, what is the it is having 16 GB, right? Right. and your maybe 8 GB or maybe 32 GB, right? So based on different architecture or different systems structure, there could be different operating system, there could be different memory requirements, and on that basis you can work on, right? So this is the risk, right? Okay. So why I have given you some kind of a story or introduction, like, okay, so that we can work on this collab. So all of you guys open this collab.research.google.com. I'll just get this link, right? And you can see that when you are trying to open, it will ask for your Gmail account. Okay, it will ask for a Gmail account. You give the what we call access. After that, like up till here, when you reach, just let me know and type in the chat like whether it is done or not, right? Okay, because what we are trying to do is the similar notebook, what we do onto your system, we will be trying to do on a Google Colab. So Google Colab. This Google Colab is being provided to us by Google. Okay. If you are short of RAM, if you are short of, let's say, the GPU, right? So then this can be very helpful in doing some projects. Let's say you have a large amount of data which you cannot do it on your system. You can just do it here, come here. The exact functioning, the exact code can be here, be done, and it could be done, right? So just let me know whether all of you or I'll just give you the steps, right? First, you need to go to collab.research.google.com, open this link, authenticate with your Gmail ID, right? Because it is Google, then you need to authenticate. Then after that, this kind of an structure will come in which you will say open notebook. You will create a new note. So let us try to create a new note. Okay, so just listen to the steps and then you can just do it, right? Okay, so now you can see that a new notebook has been created, which is for the untitled 4 IPYNB. It is with the same extension which you have with this extension. Understood? And it has got the same cells as you have here, right? No difference. Okay. The only thing is that here you have a connect to a new runtime. Okay. So basically, it is trying to say that runtime, change runtime. Okay. So it is trying to say that you have a Python, you are trying to run a Python 3 notebook, and hardware is your CPU. You can access your GPU or TPU, right? So these are paid, right? So they can be purchased and from the Google, and then you can start working. Okay, if you have larger data, but it is not required, right? Only with the GPU or CPU we can work. But here we are having less amount of our data, so CPU will work. So why I'm trying to tell you, in future, let's say there are larger projects and larger data set. So you got to understand and you got to know that you also have worked on this collab, Google Collab, we call it, right? Okay. So you are familiar with your notebooks. I guess all of you are very familiar with the notebooks. Now you need to get familiar with this also, right? In some cases, you need to try it out this in the notebook with this, or you can try it out on the this what we call Jupyter notebooks. Everyone with me? Yes? No? Have you opened a new notebook in the Google Colab? Every one of you has to write yes or done. Okay, Inderjeet. Okay, Hina, just try it out and let me know. Yes. So go to this collab.research.google. After that, a screen will come. It will ask you for your connection with your Gmail account, right? And then it will ask you to open a new notebook. Yes. So, yes, Jalandhar, you can go to the file also. If you have reached the screen and you can see, so you can say open notebook. Okay. So this also, if someone has landed into this screen where these options are visible to them, so they can just open a new notebook. Open no notebook. Okay. Okay, Jalandhar. So you can just click on this open notebook and then you can try it out. Okay, fine, great. Okay, so now you can see that in this particular notebook, so you can name it, right? So let us try to name, let's say today is what date? Today is 15th, right? 15th Sunday session. Okay, right, right. So it is renamed, and then there's a connect button. Okay, so we need to connect to a new runtime. So this is what is trying to say here that okay, so we can click on this connect button and by default it will connect to a CPU. Okay, so don't try to go for a TPU or a GPU at this point because at this point we are not doing any heavy task. Okay, so in order to do some heavy tasks, then we will be requiring to change our runtime. Okay, so let's say so in the background, what is happening is that Google has reserved some machines in order to perform some computations for us. Okay, so for every Google account, let's say you are trying to have all of you are having a Google account. So they will try to give us some free GPUs and TPUs to work on. Okay, and if you need external TPUs or GPUs, then you need to pay for it. But for the initial analysis, so that is free. Okay, so here you can see that once it is been uh, there, you can see that the RAM they have given is like 12.67 GB, and disk is your this thing, right? Okay, disk space and the RAM. Okay, right? So so right. So this you can change the runtime settings. Okay, you can just ask for the TPU also or V28, right? V2 means the dual core 8 core TPU, right? So this you can also select, right? Based on your requirements, you can select. But for now, we will be only selecting your CPU so that we can just go through it. But in future, if we have larger data set and we try to work for the larger data sets, so then we try to work on it. Okay, right? Okay. Understood this point? Yes, no? Anyone, having any doubt? Okay, fine. So let us try to write. Yes, yes, Shweta. Okay, so here you can cancel this. After canceling, you can go to this file. After file, you can just open notebook. Okay, I'm repeating again. Whichever has landed the screen, you can just click on this open notebook and cancel. Cancel. First, you need to cancel, and then you can from the file you can open a notebook. Fine. So now here, let's say we have already covered our modules like NumPy. So let us try to see import numpy as np. Okay, so automatically it will give you suggestions also, guys, right? Okay, because this is being powered by AI, right? And it will give you auto suggestion also, right? Right. So let us try to run this. So now it has been run. So let us try to make an array, let's say, right? So np dot array, right? Then a, right? So this is basically similar to what we have seen, right? In these in your previous session, right? So this is how it works. So this session or this collab is basically running, right? Okay. Understood up till now? Yes, no? Anyone having any doubts in regarding your collab, just let me know. Shweta, have you resolved this? counting is not coming for me. Counting means okay. Next line. Okay. So you need to first run this. Okay, or you can do a shift tab, a shift and enter. Right. After that, you can go to the next shift and enter. After it, shift and enter. Right. So Shweta, okay. So you got the open notebook. Okay. So open notebook, one pop-up is coming. You try to cancel it. After you try to cancel it, go to this file and then open notebook. Okay. Can you, when you clicked on cancel, what is happening? Yes, you can share the screen, but I need to give you the access. Okay. So when you do the cancel, Shweta, when you are trying to do it, okay. So what we can do is, Shweta, we can just take this up later. Okay, in the break we can do it. Meanwhile, you can just go through this. We can go through the Jupyter session. Okay, okay. I'll just be working with the Jupyter session for today. Okay, this I have given you an information, right? Okay, so in future also we will be working on this. So why I've given you today because we were like going forward like we just need to be familiarized with lot of tools. Okay, one day we will try to work on one tool and another day we will be try to work on other tools because there are lots of tools in the market. Okay, and you must be well versed with all the tools that are being needed to become a data scientist or data engineer or AI engineer, right? Okay, so just let me know if it is being resolved, else we can have a one-on-one discussion and we can resolve it. Okay, fine. Okay, okay. So part which is the data slicing with pandas. Okay, so data slicing data with pandas. Okay, so in the previous sessions, what we have covered, so we have covered with linear algebra, which deals with your linear equations, vectors, and matrices. And then we also discussed about your vector, which possesses both a magnitude and direction, and matrix, which we have a rectangular structure or an array, we call it, which have consist of your rows and columns, right? And we also see the matrix operations like addition, subtraction, multiplication, right? Okay. Now let's just try to think. And you are being going for a dream vacation. So it's already July, and uh, like in the July, most of the people go for a vacation, right? But you have a planned budget, and that planned budget includes your flights, hotels, activities, and your dining, right? So now your activity is being involved in four places, like what flights you need to choose, what hotels you need to figure it out, and the activities, right? Okay. And also plus the places, right? So places, what places you need to visit out. So this you make uh, itinerary based on various locations, right? So all of you faces this issue, maybe on a CSV, on a text file, on a notes, on a sticky note, on a diary, right, or scribbling, right? So this we make every day. We try to make some plans, and that plans doesn't go well, and we are trying to write or jiggle some information across different resources or different platforms, we call it, right? Maybe it could be an internet, maybe it could be Excel, it could be a Word, could be a PDF, right? Okay, right? So now let's say we wanted to formulate this information into one place, and based on that formulation, we just need to make some decision, right? Okay, so this is what we want. So this is a real use case where you have data which is being accumulated or being stored at various places. And after that data is being stored, then you need to make a planned trip based on your budget, based on your interest, and based on that number of people and flight cost, right? So this you need to make a plan out of it. Okay, right? So I think all of you have done this activity like when you are trying to go for a vacation, right? Okay. So the only operation or the only outcome what we want is that we just need to make the best choice or best decision based on our budget and our interest. How we can do it. Okay. So this is what we are trying to learn and trying to understand. Okay. So why I have given you an example? Because this is somewhat a practical implementation where we can just relate that our data sources are being scattered at different places, and why and how we can just make our informed decisions by getting that data, by making or by some uh, data manipulations, right? Fine. Okay. So by the end of this session, we will be demonstrate two primary data structures in Pandas, which is your series and data frame. Fine. So we will try to see the practical implementation of series and your data frame. And we will try to see the functions which are being used on series and the functions which are being used on data frame, right? Okay. So now going forward, let's say like in the previous session when we talked about Python also. So Python has some data types, which is your list, which is your tuple, which is your dictionary. And those list, tuple, and dictionary consist of certain functions. Similarly, in Pandas or in NumPy also, we discuss so many functions, right? So similarly, in your Pandas, so there are two types of structures we use, which is your series and data set. And then we will be trying and seeing what is a series and what is a data set. So these are basically called as objects, right? Okay, fine. Okay. Any doubts, any questions you are having up till now? Yes, no, right. Okay. So Panda is an open source data analysis and manipulation tool that is built on the top of Python programming language, right? So it is very quick, it is very strong and adaptable and easy to use. Okay. So this pandas could be imported in two ways, which is like import pandas. Okay. So then every time we need to write the pandas dot. So instead of writing pandas every time, so we put a alias here, which is your PD. So this we already know that import panda as PD, right? As we have already seen import numpy as NP, right? Okay. So then there are two types of data structures, which is your series and your data frame. Fine. So series is a one-dimensional array with axis labels. So consider it is as a one-dimensional array with the axis with the labels. Okay, so it has got some labels, and you can also provide some labels to it that we will see in some time. The practical implementation, how we can create a series, right? Then a data frame is also a pandas data structure. So these are basically the two data structures of pandas: series and data frame. Similarly, consider it like a Python, where Python and your data structures could be your list and tuple. Similarly, in pandas, you have two data structures, which is your series and your data frame. The difference between your series and data frame is that series is one dimensional, right? So data frame is a two dimensional, which consists of rows and columns in a tabular form. Fine, understood? This you know, like the series, a single data structure or a one-dimensional data structure, and a data frame could be a heterogeneous tabular data with rows and columns, right? Okay. So this was the Jupyter notebook. Okay. So I'm trying to do in the Jupyter notebook. So the first thing, right, when you are trying to working with the Jupyter notebook, some tips and tricks I'm trying to tell you. All the import statements, whatever you use, has to be on the top. So let's say we are trying to import pandas as PD. Okay. So this has to be written at the top. So in, let's say we would be also working with the NumPy. So let us try to import that also. It is not that like I'm that let's say you are let's say you are working with your NumPy, right? In like let's say after certain period of time, then you are trying to import that term. No, you must include your import statements at the top. Okay. So how it happens is when you are trying to run this file, let's say when you try to run this file, so the first instructions got executed. Okay, the first instruction will get executed, and it is a standard practice that you write all your import statements at the top. Okay, for the sake of simplicity, that we know that what our libraries we are using. And if you try to see some other codes or trying to refer some other code also, so there also you will see some people write some documentation also, docstring also. This I have told you earlier also, right? That what you are trying to write, what you are trying to do here, okay? So our functions, and make it a habit that cell wise you try to differentiate that what you are trying to do. Okay, it is not that we are trying to do coding, but we need to do coding like with precision, right? With accuracy also, and it will look nice also. If you have nice written code, then you don't have any issues in debugging in solving it. Okay, so basically, first is that we need to run this import functions at the top, and for running, I have used Shift Enter, right? Or you can run by this command also, or Shift Enter is also the, it will automatically give it to the next statement. Fine. Okay. So now, okay. So what we were trying to do is we were trying to import, and now we were trying to learn the Pandas library. Okay. So let us try to create an list first with the x for x in top 5. Okay. So now we have created a list. Okay. And what I will do is pd dot, okay, s capital. So remember guys, so this series is s capital, right? So series. Okay, I will try to put shift and tab. So here you can see that in the signature you have pd dot series, data, index, d type, name, copy, right? So it is a one-dimensional ND array with X is label, right? Fine. So here is in the example, they have constructed a series from a dictionary. Okay, so this also we'll see it. But firstly, we are trying to create a series or a panda series from list. So what I will write here, creating a series from list. Right? I will simply put L, which is a list, into your pandas, and I will say S1, and simply I will. Okay, quickly do this. How you can create a series from list, and let me know in the chat. Okay, can anyone tell me? So this is your data, right? What is this? 1, 2, 3, 4, 4, 4. What is this? Index. Yes, exactly, Virender. So this is basically your index which is trying to give us. So this index comes along with it if you don't provide an index. Okay. So basically we are trying to create this index is automatically created. Okay. Right. Okay. Now let us try to access the second element. Sorry, it was S1. So this is similarly, we are trying to access the element of access the elements, right? So here indexing and slicing works the same manner which we have learned in the previous Python concepts of your indexing and slicing, right? So this how you can access the element. Fine. If I wanted to access, let's say -1. Oh, sorry, S1. So -1, I think it doesn't work. Yes. So -1, it will not work, I guess. Let me check again. Yes. So indexing will here -1 will not work. Fine. In the series. Here these indexes are being given to us by default, right? So 0, 1, 2, 3, 4, 5, right? So what we can do is if I wanted to get the index, right? Custom custom index we can get it. How we can get the custom index? So creation of series using custom index. So what I will do is, okay, so quickly do this creation of series using custom index, guys. So what we have done is we have specified the list of indexes. So earlier the index was 0, 1, 2, 3, 4, and we are trying to access that element. But here I don't want that index, right? I want some user defined index or custom index, like let's say A, B, C, D, right? E, right? And this is your L, which is the data, which is the list we have provided, right? So this is your custom made index which we have done. Okay, just try to create a series with your custom index. Okay, so how we can access those elements? Access custom index, right? So this is how we are trying to access the custom index. By the keys, we can just access that. Yes, yes, Virender. So there are some operations which we can do it. Okay. So I'll let you know when we are trying to work with that with the larger data. Okay. So there, according to the data set size, so we can just do a range function. Okay. So let's say, so here also, right, we can do a range function in which we can just give that index. Okay. So we can just provide that index, right, and then we can just do it. So when we are working with larger data, so there I will show the demonstration. Okay, so just stick with me up till this point because we are trying to learn the initial structure that how we can use this. Fine. Okay. So now when one question, can we have duplicate index? So let's say in this particular S2 dot this thing, let me put duplicate index. right? So can we have duplicate index something like this? Yes, no? Just try it out and let me know, guys. Okay, have you tried it, Indrajit? Radha is saying yes. Okay, try it out and let me know. Yes, yes, we can have, right? So we can have duplicate index. So here the error was that because I was provided many entries, so that the error came, right? So now you can see that we can have duplicate index. Okay. Now the most important thing you to note, if I try to ask C, right? I can index C element. So this is your index C. So what will happen? Both the entries will come, or only one will come, or the last entry would come. Just try it out and let me know. If I try to access the element which has got duplicate index, yes, yes, exactly. Both will come, right? So this we are trying to give both the entries, right? So these things are very important because in Python you have understood or learned some different concepts. So here this is another concept, right? So you cannot blindly say that we couldn't have duplicate entries based on the previous knowledge. Okay, so this data type is different. This is Pandas data type. So its functionality is being designed in such a manner that it can handle duplication. Okay, so that is why you cannot comment that whether that duplicacy will work or not, or it will work until and unless you run it. Fine. Okay, understood this point? Everybody done it, right? Those who have not done it, just quickly run this and let me know, or we'll move to the next topic. Okay. So what we will do is we will try to create a NumPy array. Let's say A1 will try to create it and P dot array, and there I will try to create or I will say np dot arrange. Right? So we create an array, right? So earlier we were trying to create a list. So this was a list, right? And now we have a array, right? So can a NumPy array can be converted into a series, Python series object? So Python series object we call it, right? So we'll try to do this same operation using NumPy array. So I will try to see on pd dot series s capital, right? Then I will say a1, right? Yes. So it has created a NumPy array, sorry, series object using your NumPy. Okay, great. So now what we have seen is we have tried to create a series object using list, NumPy, and dictionary, right? So dictionary we have not seen it. So let us try to create a series object using dictionary. So quickly, guys, make a dictionary. Okay, step one, make a dictionary. Step two, make a series object using your dictionary. Okay, okay, I'll also do it along with you. You also do it. So Kilesh, so you can make any dictionary. Okay, if you are having some issue, so you can just refer to the documentation. So there the example is already given. Okay, so there we have already seen this example is given, right? So just write out this example. So let us try to make some dictionary by dict. Yes, Virender, done. 60, Radha, great. Okay, great. Fine. Okay, so let's move forward. So now what we have done is we have tried to create a series using your list, NumPy and dictionary. So now you are trying to gain some confidence. Okay. So let us try to do some other operations. Right. Let's say I'll try to create pd.series. Okay. So now I have a list, right? L. And here I will try to put some index. Okay. So let's say A, E. Okay. So let me put some F also. Let us try to see what will happen. Okay. So now you will try to get a error that length of five values does not match the length of index. So if the index and your length of the data must exactly match. If it is not there, then it would be give you error. Fine. In the case of a list, right? Fine. Okay. So if I try to give you my data, let's say, right. Okay. So in the case of list, what I've done is if the data and your length is not the same, it will give you the error. But in the case of your dictionary, these were the index A, B, C, D, right? So now A, B, C, D is fine, but E, F also we have generated. What will happen? So let us try to see this. So it created that index, but the values are not known to us. We haven't provided as value because these values were already provided to us up till fourth index. But fifth and sixth index, it was not provided. So it gave us NaN. NaN means not a number, right? Okay. So these values we got it. But previously, what I showed you that if you are trying to have a list and your index should exactly match, your data in the list and your index should match. But here, if it doesn't care, it will automatically generate your index and the data should be NA. Got it, everyone? Right. Okay. Great. Good. So now the next topic is that how we can access the elements in a series, right? So let us try to make that thing. So what I will say as 5, right? ed dot series. So I will try to create your, right? So I've created a series with this data type, right? Okay. So there are two operations, which is iLock and iAdd, right? So let us try to see. So, right. So this is how you can access the elements in a series. Quickly try to create one series object and try to create it. So by using the index method also it can be accessed. Dictionary can have empty index. Ashish, could you please explain this list optimization which you are using in for? Okay, right. So this is basically called as list comprehensions. Okay, Vrinder, this is basically your list comprehension. So let us try to understand this thing, right? So you need to make a list. Okay. So if you wanted to make a list, so let us try to break this in diff parts for x in range for 1 to 11, right? Okay. So I will say print x firstly. What will happen? It will try to give me the list of 10 numbers, right? But that I don't want. What I want is that I wanted to have a list of 10 numbers. Okay. For that, I will try to create my list also, right? And instead of print, I will say my list dot append x. Whatever elements it is going to print, it will try to append into that list. And I will say my list. Right? So you get a list. Okay. So this is a simple code where you can have a range function where you can make a list of 10 elements. Fine. The same thing could be done using list comprehensions. Right. What you need to do is you need to make a list, the output. So this is the output you want. You put a for loop range of 1 to 11. This we have already done it, right? And the output list, my list append dot x, right? So this you just put a x in front of it, right? You first this will get executed, and x will try to work on this list what we have used. So this list, right? It will try to append one, then two, then three, then four, then five, then six automatically, right? So now it will, okay, clear, Virender? Any doubt, any questions you are having? Just let me know. Or let's try to take another example. I only want to give the even and odd numbers. So what I will do is, or let's say I wanted to get multiplied by 2. Yes, Virender? Yes. So this code, have you understood what I have written? So this is an empty list. I've created an empty list for loop for x in range of this. Then I have appended this, right? Okay. So the same thing which I want is basically is using your list comprehensions, right? So first operation, what we did, we made an empty list. So here also we are trying to make an empty list. Then we are trying to write a for loop. So we have written a for loop. So I'll try to write here a for loop for x in range of 1 to 11, right? After that, we are trying to append. So here we don't need to write my list dot append. We simply write x because it is already in the list and we are trying to append every element in the list. So this is the simple thing, right? If here I will try to provide into x into 2, so what will happen? Each and every element gets multiplied by 2. So similarly, if I want that elements to be multiplied by 2, so here I will simply write. Okay. So now, is this clear? Okay, great. So now what we will try to do is we are trying to access the elements using ilog. So this you need to understand. So ilog also works perfectly fine when we are trying to index the series, right? So indexing can also be done by 0, 1, 2, 3, right? By we have also seen the indexing, right? Like this. But using your ilog also we can do it. Okay. And another thing which you need to understand is that accessing with the loops. Okay. Okay, great. Okay. So we'll dedicate some time after the class, right? And or in last 10 minutes we can just take the loops again. Okay. Accessing the accessing using your IAT, right? Let's say we have your 5. right? So this is how we can access the series object using ilog and I. Hope everyone done this, accessing your series object. Great. Now we'll move forward to slicing. Okay, so let us try to type this. Okay, so I want the element from 3 to let's say 7, right? So what I will do is I will try to put a 3, okay, and I will put a 8 to it. So this is self-explanatory, right? I guess you all already know this, how this slicing works. Yes, quickly try it out. Let me know in the chat. Yes, Virender, ilog is basically you are trying to access the elements in a series. So these were the S5 and you are trying to access the 0th element. Okay, by using your ilog operation also you can access. ilat is also a similar. iat is also that thing, right? You can access that, right? Okay, so ilog you can access it, right? So this you can access it. Okay, ilog and iat. So these are operations which are needed to access the elements. Same. Okay, any doubts up till now? Okay, so this where we have already used, right? Okay, so let us try to do this thing also as 5, right? I wanted to find only the even and odd, right? So this S5 dot where I will simply say S5 divisible by 2 equal to 0. So what I'm trying to do is I only want the even numbers, right? So this we can do it. So this we already done in your NumPy where and select. If you see the documentation, the condition, right? Right here instead of this thing, you can put 0 also. So ilog, render ilog is basically you put the index and you try to find that value. Where? Okay, so this where is basically what it is trying to do is, so it is only trying to work on the entries. So these are the indexes, these are the values. Okay. So it will only select those entries which is divisible by 2. Okay. And it will give you the results. So this, it is giving results, 4 it is giving you, 6, 8, 10. And rest of the entry is giving not a number. Okay. So here in the second case, what I have done is instead of giving you any number, so I made it 0. Whatever entries this has made 2, 4, 6, 8, 10. It is fine. And let rest all the entries make it as 0. Right? So this is how you interpret it. Okay. So this condition applies on the data and wherever this is even numbers, so there we have done it and rest we have put it 0. Fine. Okay, you are not getting where function. So, Virender, uh, how you are trying to get your where function? Just understand the concept. So this is your S5, which is a series. On the series, you are trying to put a where function, dot where, or you are not able to understand. So have you understand NumPy where? Yes, S5 is a series. Yes. After that, you are trying to use S5 dot where S5 modulo 2 equal to 0. Right. So this is your this. We are trying to make this where function applicable on S5. Right. And this you are trying to see the results. Now you got it? Or yeah, you can just share the screen or give the snapshot. Yes, good question. So now what you are trying to do is you are trying to do where, okay, and after that you are calling S5, right? So now the changes are not getting reflected. Yes, you are right, Prinder, right? So basically, when you are doing this, right, you are assuming that the changes will get reflected. Okay, so changes up till now will not get reflected until and unless you do in place equal to true. Fine. So this in place is being used in further also at most of the times. Let's say you are working with some data. You wanted to check, right? If let's say you are trying to work on the data and suddenly it got your data corrupted, right? So there you are trying to check what are values are there. If you are confident enough that now this operation if applied on this series object, it is fine, then you go in place equal to true. Now check this S5 hasn't got its data modified. Okay, it is the original S5. And now let's say if I try to do this, now it has not modified the data. S5 will always remain the same. But if I do here in place equal to true and then run it, now you can see that the original data gets modified. So the operation is in place equal to true, right? Here also, if I try to do in place equal to true, original data will get modified and values are zero. Understood? Got it? Yes, everyone? So this was your in place, right? So when we are trying to do your in place, right? So two topics are remaining. So just handle missing values. So then we will be going for a break. Okay. So just quickly let me know, have you guys done it up till now using your in place, checked and verified that before your data, after you're doing your in place, what changes you got it? Yes, no, Christy, Virender, Indrajit, Radha, everyone. Fine. Okay. So now what is happening? So you got some NaN values and you wanted to get rid of these NaN values, right? Why I'm showing these things, guys? Because sometimes what happens is that when you are trying to get data from some external resources, right? So some data consists of some entries which is NaN. Okay. So what you need to do is you need to remove those entries. So how you can remove manually? It is very difficult to see each and every if the records are 10,000 or 100,000 or 1 lakh, right? So there's an in-bit operation called drop NA. So S6, we are working on this data series object. What I will say? I will say drop NA, right? So what will happen? The entries would get dropped. It is only showing us. It is not reflecting us. If I try to do S6, so the original data remains the same. Why? Because we haven't done in place equal to true, right? So now quickly create the data, right? And include some NaN values to it. After including, you need to drop those values, right? First, you need to check it. After that, you need to do in place equal to true. There you will see that these values get rid of. Now you can see that. Yes, great. Good guys. Okay, so now this is drop NA. You are trying to drop the entries which are NA. Okay, but the thing is that now the data is lost. In some cases, you wanted to replace these NAS values by some meaningful values. Let's say you have recorded the uh, okay, Inderjit, it didn't work. Okay, what happened? Okay, you have done in place false, Inderjit. In place, you need to do it true. After in place, these S8 entries would get reflected. After that, you do a in place true, then the entries would again get reflected. In where also you need to do in place true, and in drop NA also you need to do in place equal to true. So let's say this is S7. Okay, after that I will try to say that S7 dot where in place equal to true, and then I will try to put S7. So now you can see that the NaN values are still there. In the previous example, we have dropped that NA values by some, all the values have been removed. But let's say consider it as a practical situation. Okay, you have a sensor which recorded the humidity. Every day it recorded the humidity of the days. So first day, like the sensor didn't work and it recorded NaN. Second day it worked, third day it didn't work, right? So in some cases, alternate days it was working, and in alternate days it was not working. Just hold on 1 second, Virender, right? Alternate days it was working, and alternate days it was not working. So in that case, if I try to remove all these NaN values, my data would be less. I don't want to make our data less. Okay, I just wanted to make that data so that it would have some meaningful information. So my job is to make this NaN to 0. So what I will do is I will do fill NA. I'm trying to do is what I'm trying to do is I'm trying to give this NaN values or NA values to some specific value. Okay. So let's say this is NPN NaN. So these are NaN values. So I wanted to fill it by 0 or some other values, right? So let's say I wanted to fill it by 0. Now you can see that all the values have been filled. But if you try to go for S7, now you can see that the NaN values still exist. So all you need to do is here write in place equal to true, right? After that you go it. Now you can see that all the NaN values in first operation it was deleted by drop NA, but fill NA means you have made that operation by 0. Understood? Everybody do it and let me know in the chat. Yes, Virender. This will work for the dictionary also. it is not applicable that it is only we are trying to do on a list. So this operation we are trying to do is it is on the series level. This is the series level operation. Okay, it doesn't care. Once the data is being fed to the series, now you are putting some function to it. Okay, so then we are trying to work on it. Understood? So quickly do this, fill NA. You can give any other value also. You can give it -1 also. Okay, so let's try to move forward with the other topics. Okay, so we have discussed series, right? So series is a one-dimensional array with axis. Okay, now there are some of the pandas data frame and series functions. So let's try to understand one by one. Then we will try to see the practical implementation. The first function is of pandas data frame is head. So head, it will try to return the first few rows of the data frame or the series, right? Okay. So let's say try to work on the data frame. Then we will try to put a head and see what all contents does it have. Similarly, tail, it will return the last few rows of the data frame, right? Fine. So this first function is head, which will try to give you the first 5 to 6 entries of your data frame. Tail will give you the last entries. Okay. Info, it will provide you the summary, including your column name, data types, and non-null values. Okay. So we will also try to see this info. This head, tail, info, describe. So these four functions is basically used to analyze any type of data, right? So we will try to see it. So when the data comes up at your screen or from at your table, right? What is the first thing you need to do? You just need to analyze that how many null values are there. Is the data correctly formatted or not? Do I need to do some change some values to it? Let's say we have done the NaN values to some user defined values, right? So that information these four functions will give us. So whenever you are trying to import that data, use these functions to try out to get the summary that what your data looks like. Fine. Then we have sort values. Sort is also a very important function where we just wanted to find out any kind of duplicacy in your data. Data is often messy, guys. It is often dirty. The real-time data which you get it from your companies, from your stakeholders, right? So that is very filthy. You just need to format that data, remove the null values, and also remove the duplicates. First, you need to sort it out, and then you need to figure it out how many duplicate values are there, and based on your analysis, right, or asking your manager or team lead or some personnel which knows much about that data, you just need to understand that whether this data is really important for us or we need to delete it. It is often noted that duplicacy is removed, right? It is helps to understand your data better, and unwanted entries make no use of this. Right? Okay. Then there's another function called group by. Group by works on the aggregate functions. Let's say we wanted to have a group by function followed by sum, group by sum, right? By mean, group by some kind of a custom aggregations. We wanted to perform the operation on our data by grouping some entries. Then we wanted to calculate the statistics of that entry of that data. Right? For that statistics, we need some statistical functions, which is your sum, variance, mean, max, right? So these are applied on the group by method. Right? So keep that in mind. Whenever you encounter any data, head, tail, info, describe, sort values, and group by are the functions which you need to perform analysis. And also we will see practically also, right? Then apply. Apply is a function that is very commonly used, guys. Let's say you have some entry or you have some data inside a column. You wanted to apply the changes to that particular column. Then in the apply method, you can write some custom code that I want my data to be formatted in such a manner. This way, it will work, right? Then merge or concatenate. So as I already said that data is very large. Then you need to break down the data into multiple parts or chunk that data, we call it. Chunking could be done. After chunking, you perform the same analysis on one data set, get the output, then perform the same analysis on the second data, get the output. Then either you can merge or you can concat. These merge and concat operations are very important when you are trying to deal with your data. Fine. That is large data, right? Drop NA is basically we are trying to remove the NA. Drop is basically some labels, some rows or some columns has to be removed. Fine. So let's say you are working with that data and you feel that there are some unwanted columns which are no longer required for your analysis, so that you can get rid of. Okay. So either you do it manually, but manually when you are trying to open a CSV into your system, it will hang because opening a large CSV of so many records is really a very challenging task. Your resources, computational resources, your RAM may not support them, but your program will try to support it, and you can easily drop or add a new column into your data frame that can be imported or exported into your Excel or your CSV format. Fine, right? Okay. Then for the accessing or slicing, already we have discussed that lock, ilock, iat, right? So these are used for indexing. These are used for indexing. Similarly, for the data frame also, we will try to see this. Right? So these are some of the methods which are really very useful in case when you are trying to work on your data. Then the last, plotting. You have done, imported the data, performed some analysis, right? Cleaned your data. After cleaning, after performing analysis, you wanted to show it to your end customers. That what trends, is this trend upward or is this trend downwards? Then how you need to show it? By using your plot. The plot function consists of several options in which you can make a graph or a plot using x-axis, y-axis, right? Scatter plot, box plot, right? So this way you can make the plot. Then the shape and columns. So shape we already know. The shape is to check like what is the dimension of that data. Right, 2 cross 3, 3 cross 2, right? So this shape in your data frame will include your rows and columns. Fine. And your column, these are the attributes. So these are not the functions. So remember, the functions always come with the bracket. The attributes doesn't have a bracket. Fine. So this is the difference between your functions and your attributes. The shape you already know. And columns is basically it will try to return the number of columns. Yes, yes, Virender. Lock and iLock, we will try to do it up again. This is basically used for indexing, right? So this allows for indexing and slicing of rows and columns based on the labels. So this lock and iLock will be, you will get a better understanding when we are trying to deal with data frames. As we have already seen that I wanted to get the data in your NumPy, right? So NumPy, let's say slicing we have done. Yes. So integer based position, yes. Integer labels lock is working, and for the integer based iLock is working, right? If you wanted to work with the labels, then lock you need to specify. For the integer, so iLock is working. So I have given you a pandas example.csv, right? Okay. Yes. So this pandas example.csv I've opened up in this Anaconda. Okay. So it consists of three entries: name, age, and gender. Right. So it is a CSV that contains some entries. Okay. So now our task is to that this CSV could be a long CSV also. Okay, could consist of 1,000 documents, right? And the entries in which your rows could be multiple and your columns also could be multiple. It could have your age, could have your salary, right? And it could have additional entries also, right? So this is a sample data set. So let's work with the toy data set first, and then as the lecture proceeds and more in sessions, then we will try to make the complexity grow. Understood? Right? Okay. So now the first task is that all of you guys try to uh, copy this data, right, in your where your all the sessions are there, right? So let's say you are working in this Python data analysis folder, and here this is your 14th or 15th session, and this pandas example I have made it there only. Copy that into that same folder where you are working. So this normal practice follows, you need to make a folder and you need to start working with your notebook, and there itself only you keep all your documents, all your data sets handy there itself only. Okay, don't put it into the downloads folder, don't put it into the desktop, make it as a folder, like proper folder. Why I'm trying to tell you, let's say you are in a company or you must be working in a company, so there you are trying to handle different projects. So when there are different projects, so it is very difficult for you to manage different project structure. Okay, so it is better you make a folder, and in that folder you keep all the files and your necessary documents in that, so that you didn't get lost. And it is also looks neat and clean. Understood? We wanted to read this CSV. Okay, so this CSV is already been present here, pandas example.csv. Okay, so let me try to write here working with data frame. Okay, so I will say pd dot data frame. Okay, so let us try to understand first the data frame. Then we will try to see how we can import this into our normal system, right? So data frame. Right. So this is your empty data frame, right? If I try to check the type, so this is your pandas data frame, which is your empty data frame, right? This is how you can create a data frame. If I try to see the documentation, so here you can put any data, you can put any index, you can put columns, you can put the type, right? Okay, so there could be an example also could be written. So this we can construct a data frame from a dictionary. How we can construct? So this is your column 1, which holds two entries. This is column 2, which holds two entries. Right? So this is your default data frame. So we can also copy this and try to work with it. Then we'll say df2 equal to pd dot data frame, and we'll put data equal to d. Right? So now you can see this. Just try to do this and let me know which df you are talking about. So this, okay. This you are talking about, Hina. Okay, what about others? Virender, Inderjeet. Okay, great. Okay, so now what we have seen, we have created a dummy data set, right? So now our job is to read the data set which we have in the CSV. Fine. So let us try to do this. So pd dot read. So here, when you try to read, right? So you can see so many options. You can read from CSV, you can read from Excel, you can read from Feather, FWF, GBD, HTF, HTML, JSON, Parquet, Pickle, SAS, SQL, SQL query, table, XML, right? So these are the various data set. In the first slide, what we have covered, that your data could be scattered at multiple places, right? You can read from those many tables or structures, and then you can paste, or you can just take this data into one organized format, which is your data frame. Okay. So let's say our is your CSV. So I can just simply say CSV, then it is your pandas example, right? Then I wanted to have your data frame 3, right? So let us try to analyze this and see. Up till here, everybody do it and let me know. So read CSV is a function. Okay, so let me try to work on that function also. So these are the values which it will take. These are the parameters. So file path, it will take separator, delimiter, header, names, index, d type, right? Skip rows, skip footer, right? Sometimes you have some data where you need to skip some rows and then you need to read from that row, right? So there also it is given. If some data has well-defined format in which the skip footer information is there, that also comes along with it. So you just need to skip that information, right? Then NA values, keep default, right? And days, right? So there are many operations, right? So according to your use case, you can try it out and work on it. Okay. So every information it is being given, that every possible structure, right? Or the the option consists of some operation that you can just read it out and then you can use. Okay. Yes, Indrajit, what you have done is you have made a code in the starting, but you haven't closed it in the ending, right? Okay. So whenever you are trying to get some error, okay, make sure that you try to look at the error first and resolve it, right? Because these errors are your mistakes, right? Your typo errors, basically we call it, right? So just try to figure it out, that like your codes should not be open. Okay, great. Okay, so let us try to do tf dot head, head, Oh, df3, I guess. Then I will do df3 dot tail, right? Because the uh, tail and head is giving you the same operations because the data is small. Okay, in large data, so tail and head will work. Okay, tail is to give you five entries, and sorry, head is to give you first five entries, and tail is to give you first 5 or 10 entries. I'm not sure. Okay, so just you can see the documentation. Five, yes, 5 entries. Returns the first 5 entries by default. Okay, then df3 dot info. Yes. So it is giving out the info of the columns. Okay. So column name it is giving you, and it is data type. Like data type is object, right? So name is having object data type, gender is having your object data type. So though it look like a string, right? But here it is being referred as to object. Okay. So when you are trying to convert your data to your this thing, data frame, so the string types is being converted into the object. Okay, and your age is in the integer, so it is in 64, right? It is being converted. And it also gives you the memory uses that this number of bytes information it is being holding, right? This data is being holding, right? And in the described data set, what you are trying to get the for the integer. So this is your integer, right? So this is giving you the mean value, right? Not for the entries of your this thing, right? So only for the age entries it is giving, right? So it is giving you that out of this age, the 18 is your minimum age, standard deviation is your 9, mean is your 28.8, and count is 5, right? Then it will give you the percentile, 25 percentile is your 24, 50 percentile is your 28, and 75 percentile and your mass. So these basically gives you the statistical information about this particular column, which is your age. Yes. So that also it will try to calculate, right? And it will try to give you the information, right? You can try and make a new column and then look for yourself, right? Okay. So if you see that this describe function, what it does, and it can help you in which you can just, but it is for sure that it will give you the information of the integer column only. It will not work on the object data type columns. Okay, fine. Okay, right. So then after that, like let's try to see the ilog option. So data frame 3 dot ilog. So let us try to see 3, right? So I wanted to give the third entry. The third entry was Robert, sorry, Alex, right? So Alex, then age is 18 and gender is female, right? So this is your data, which is your object, and it has given you the third information for your ilog, right? Fine. Okay. So then if you wanted to have the values, so what we can do, we can just, so all the information you can get it in an array, right? This way, if you try to get only the value. Okay, sometimes it is necessary that this data does not contain object data type. This only contains the numbers. And the numbers you wanted to take it into an array, and then you need to perform some manipulations, object types, or something like that, calculations, arithmetic operations. And then you need to again store it in some kind of an array again. So this is how you can store it by using your df3 or df data frame dot values. Fine. Okay, yesterday code file. Okay, I'll share that also. Okay, and today as well, I will share it. Okay, so now let's say these names, age, and gender, we have already done it. Okay, so let us try to introduce a new field called salary. So I will put a salary to it. and I will say 10,000, right? So you can see your data frame has been changed to a new salary where you got a salary, and here you get all the 10,000 salaries as these persons are having, right? Automatically it will try to give you. Okay, so this is how you can introduce a new what we call new column, right? So this is your new column. Okay, so let's say you wanted to have only the name. You will only get the name. Okay, or let's say you want to get the name and salary. Uh, no, it will, yes, right? So this is how you can get the name as well as the salary. Only two columns you wanted to get it. Okay, so just quickly do this. Try to make a new column, which is the salary, and assign that value to some value. And then try to get the age and gender as well, right? So in this data frame, you are trying to extract the name as well as the salary, right? So this outer is for your data frame. This data frame you wanted to have, like this is for data frame 3, right? So you have name and salary. And internal, you are trying to get something like in this data frame, please give me only the name and salary. So this is the predefined structure. That is why we are trying to use this double structure. Okay. So also, let's say if I wanted to want the age, right? Give me the age of employees which is greater than 25, or let's say 25, yes, or let's say greater than 25, let's, yes, right? So what you can do is TF3, right? You wanted to work on age, right? And you wanted to get 25, right? So here you will only get true and false, right? But you are not getting the information what you want. So this is basically a condition. So similarly here also, like you are trying to put some condition that only give me the name and salary, and from the data frame extract me, right? So similarly, you get a true and false. So this, what you need to do is you need to put another bracket, and here you need to put it here, that this condition has to be applied inside this data frame. Similarly, this condition has to be applied in this data frame, right? So now you can see, now you can see, it has given me all the information, fine, right? And here, I guess, if you want only the names, so this also will work, yes. So I only want the name, right? If you specify here salary, you will get the salary. Here double bracket to be done, yes, right? So this is how you can get the information, right, from the data frame based on the analysis. Understood this point? Okay. So let me explain you again. So I wanted to calculate the age which is greater than 25. So what I will do is I will try to take the 3 and I will take age, right? First I will try to take the age. Then I will try to make a condition. Okay, if I try to run this, it will only give me true and false. But I want the complete data set. So this condition I put inside a bracket, which is our data set, right? So now you can see that this condition applies to whole of this data set. And this condition we are trying to apply with this age. Okay, right? And age is, so basically for the different for the two this thing. So I'll check and let you know on this, right? Because you are trying to make two conditions. So one condition it is working fine, but two conditions there could be another like a bracket or something like that. Like I'm not sure, right? So I just need to check. Okay. So then if you want the column, so you can put an additional bracket. Let's say for a single column, this work perfectly fine. Okay. But if you want to have multiple columns, so then you need to put a double bracket here, and then you can include a name and salary, right? Okay. We started with the NumPy and Pandas. So here in the first statement, we are having imports. We are trying to import that library as PD, which is alias, and import NumPy as NP. So this is the common nomenclature. Let's say we would be needing a library as well here. Here we try to create a list, okay, for x in range of 5. So this is called as list comprehensions, right? So what is happening is like it will try to generate a for loop, and it will have a range of numbers from 1 to 0 to 4, and it will be appended into a list like this, right? So this is the nomenclature in which we are used list comprehensions. From the list, I'm trying to create a series, which is a pandas object, right? So series and data. And here one thing to notice, the series S is capital. Okay. So then we have created a series object, and this is S1. And there you can see that this is your index and this is your value, right? Then we can access the elements of a series. Okay. So by their index position, right? So this is how we are trying to uh, uh, access the elements, right? Using their index, this is 1, 2, 3, 4, 5. And if we try to put some other index, so that may not work because it will say the index is out of range or out of place, something like that. Fine. So this we have created a series, Python series object or Pandas series object by using your default index, which is ranging from 0 to n, which is the number of elements. But here we can create our own custom index. We can give our index equal to A, B, C, D, E, F, right? Here we can create our own index. Then if we wanted to access the custom index, right? So just we need to put that particular index name or name to get the reference, and then we can use it. Then can we have duplicate index? Yes, we can have duplicate index, right? So at this index, two elements are occurring, which is your 1 and 2, and this is your index, and this is your value, right? So here clearly we can see C, and this is your index, and these are your values. Okay. So this is how we have created your series using your Python list and your index, right? And we can have a custom made index also, right? Then another approach is that we can create a series using your NumPy array. Okay. So here we created a NumPy array, right? So lb.arrange, and this you can see that it is a array which is your NumPy. And here we put it into a series object, which is your AL, which is your array one, into a series, and it's in the structure it got transformed into a series object. So three methods: series using list, NumPy, and your dictionary. Right? So what is a dictionary? Dictionary consists of your key and values pair. So this is your key and this is your values. Okay, right? Uh, then we can create similar to your list and your NumPy array, putting your dictionary into your series object, right? So same way we can calculate the series using your dictionary. Similarly, we can create your custom index also, right? So if the index is not present, if the sorry the value is not present to that particular index, it will give your NaN. Yeah. So NaN stands for not a number, right? So right, how it is being there? np.nan, right? If I try to say np.nan, so then it would be NA number, right? Okay, right. So then we try to see the ilog and log. Okay, so we can access the elements of an series using this ilog and log also. Ilog refers to the integer, right? I, and log refers to your normal value. This ilog we also see in the data frame also, right? So I will try to we will try to make a sample data set, and there I will also explain where ilog and log were given there. Fine. So this is your list comprehension. So in previous lecture, someone asked that how it is being worked, right? So this you try to take it for a for loop, and then after using a for loop, you have this x into, right, where you try to vector it, right? So then we can access using IAT also. So IAT is also similar to it, right? Here we are trying to calculate using IAT, okay, the elements uh, which are present, and then we have the slicing. So slicing is basically we have used slicing again, right? Uh, right. So we wanted to access the third row up till the seventh row. Okay. So this is what we are slicing works. Fine. Okay. So just give me 1 second. I just charge it. Just, uh, Okay, so what I was trying to tell you that when we have slicing in which we have the third row and up till eighth row, right? So we are trying to slice those elements, and then we are trying to use the where. So this where is very important. In where you are trying to uh, like write some logic, and then we are trying to format those data frames or those values according to those this logic, right? So I just wanted to find like if that number is being divisible by 2 and the result is 0, and make that number as 0. So you can see that the all the numbers which is not divisible by 2 is being replaced by 0, right? So here you can see that, right? And this operation will only occur when you try to do in place equal to true. Fine, fine. Okay. So then we worked with this missing values. So how we can handle these missing values? So there, this is NaN, right? So here NaN is being occurring, and we need to drop these NaN values. So the function to drop your NaN value is drop Na, right? It will automatically drop all the entries which is having NaN, and it automatically gets dropped. Okay. So this is very important function in which we are trying to drop all the Na values. Na means not a number values, right? Right? It may be NA also, or NaN, or NP.NaN, right? So all these values we can drop it by using your drop function. So this function is very important, guys. Fine. Okay. So there are two methods in which we can handle the missing value. So this what we are trying to learn is handling of the missing values. Missing values in the sense the junk values. So often it has been seen when you are trying to get your data set. Okay, there the entries could be present and couldn't be present. Let's say in some cases, so these entries were not recorded. Let's say these are temperature settings or humidity settings of a sensor data, right? At every hour, they has to produce some data and give a reading. And those readings you are trying to make some analysis, fine. But the thing is that the question is that like in at some places that recorder didn't work, that entries didn't get recorded, and in due course, if the entries were not recorded, and it gave us NaN values. Okay, and this is how your data set looks like. Now to filter your data, you have two approaches. Either you drop all the NaN values, or you replace those NaN values with some meaningful data. Meaningful data means if you are trying to drop these entries, let's say I have dropped all the entries. Now you can see that only 1, 2, 3, 4, 5. 5 entries have been there out of the 10 entries. In this process, your data set is you are losing some data. You are losing your data. And if you are trying to lose your data, then you cannot make some accurate predictions, right? So let's say it was like about 10 days data, and out of that, like 5-day data is already been dropped. Then how you can make some prediction because your data set is lost. So there you what you need to do is you need to fill NA. Fill NA means you can just make an average. First you take an average of those values, and then after that you can replace those values with the fill NA with the average so that your overall data is not hampered. So this is the ideal practice, guys. Okay, so either you can replace your data NA values with the mean, median, right? Right? So you can replace it with the mean, average values, or mode, or median, right? Highest values, or maximum values, or minimum values. It depends upon your use case, right? So you are your product manager and you know well about your data, and there you can just replace it by using your fill NA. Or if you find it that, okay, I don't want this data, I don't want some inconsistency on my data, I want my data to be true and accurate. So in that case, you can drop it if your business logic or your requirement says like that, right? So this is how you are trying to make some analysis. Fine, right? So this is the ideal method in which you are trying to make some analysis that how you can control the NA values by dropping it or either filling it. For filling, there are two options, either fill it by the mean or zero or by some highest value minimum value. It depends upon to your business use case. So then we try to work with the data frames, right? So now like we will be working with data frames itself only, and you know that what is a series and what is your data frame you have clearly identified. And I will be giving you some concepts also that as a data scientist or a data analyst, what exactly you need to look into your data and how you can correct it, how you can uh, just manipulate your data or do some corrections into your data. Fine. Okay, so this is your column. So this is how your data looks like. So this is your CSV. Let's say CSV, you have a column name, and in that column name you have multiple entries. So this is your column number 2 in where you have multiple entries, right? So this is like your data set in which you try to export from your CSV or your Excel, right? So this is your sample data set in which we can relate it in that fashion. This is your column 1, this is your entries, this is your column 2, this is your entries, and maybe your column 3, then this is could be the entries. So when you try to convert your data into a Pandas data frame, the data frame looks something like this. You have a column 1 and column 2 with your index 0 and 1. Okay. You can calculate the shape. You can calculate the columns, like how many columns are there. You can rename the columns also. We'll see. We'll see in a few minutes, like how you can rename your columns. Let's say this column name is something you don't want. You can delete your columns also. Okay, in that case, fine. So this is your how your data is look like. So guys, you just need to understand the working and the flow. Okay, so there could be n number of functions, n number of methods, right? Don't need to cram each and every function, but the methodology and the functions which I'm trying to teach you, right? So just like try to keep that in mind. These are the basic functions that is being needed for your data analysis. Okay, although there might be a long list of data functions which could be adding like every time like you try to upgrade your Python versions or your Pandas version. So some functions get added, right? Okay, but these are some of the common functions that you just need to understand. Then read CSV. So read CSV is a function which is being used by the Pandas, which is used to read any kind of a CSV and try to import into your data frame. So this is what we are trying to do. Here we are trying to read a CSV, which is your Panda CSV, and then we have imported successfully into a data frame, right? So data frame, if we try to see, so this is having your 4 entries, 5 entries.
starting with index 0, and you have three columns, which is your name and age and gender. Okay. So then the basic operations. Basic operation means like we are trying to see like what is the head, right? Let's say this could be your 10,000 rows. So I just wanted to see first five entries, which is your head, tail, the last five entries, right? And info gives you some kind of an statistical or some information about your data set, that which column it is having, and the column null count. Like let's say these values are not null, so it will try to give you that these entries are having non-null values. Okay. So why this info is very necessary to check whether your data set is having non-null values or not. Okay. So here your data set is small, only five entries. So let's say you have an Excel sheet or a CSV. It consists of 10,000 rows. So there you cannot see each and every data sample and check whether it is not null or not. Okay. So this function will try to give you, and it will scan all the columns, all the rows, and it will see that whether this name has how many non-null values, right? Then you just need to remove those values, or you just need to interpolate those values. Interpolate means you just need to fill those NA values, right? So maybe some name could be blank, or name could be there, age could be blank, name and age could be there, gender could be blank, right? So in that sense, what I have told you, that fill NA or drop NA, either you need to drop those entries, okay, because you don't have the name, you have the age, or you have the gender, or you have the name, you don't have the age, you have the gender, right? So it depends upon your business logic how you can work with that data, right? So that is the whole point of this info function or info method, that how you can just see that what all entries are present in your data and whether those entries are not null or not. And if they are not null, you just need to see, and you just need to remove it or interpolate that, right? So then we have the describe method. Here it will give us some statistical information about your data, and it will only give you the information regarding the integers or floating point values, the columns which is having your integer values or floating point values. For that only it will try to give you. It will give you the count, that how many entries are there, mean, that what is your mean age, standard deviations, that how much variation or deviation from that data set is there, right? And minimum value is 18, 25 percentile, that how many values are of 25 percentile, right? 50 percentile, 75 percentile, and max is how much, right? So this is give you some statistical information about your data so that you can perform some analysis, right? Okay. So then we have df 3 dot values, where we can have some values in an array object, and there we can do some operations. Okay. And yes, so this is how we are trying to create a new column. Okay. As I already told you, let's say this is your name, age, and gender. Okay. So this is the data set you have got. And after that, like you feel like I want another column which could process something or which could have a default value, that all these employees are having salaries as 10,000. Okay. Meanwhile, I could have another column in which their salaries could be processed, like or joining date or salary, right? Something like that could also be there. Fine. So there I can just include another column by using this data frame salary equal to 10,000, or some logic or business logic I could make it. So this is how we are trying to select some of the columns. So this is how you select a column. If there is a more than two columns, so then we need to put a double bracket. Okay. If it is a single, then you don't need to put a double bracket, only by name. You can just put a single bracket, and then you can just refer to it. Fine. So this is how you can just do it. Okay, so here we are trying to put some selection to it. Let's say in the data frame, I want the age and I want those employees where the age is greater than 25. Okay, if I try to run only this thing, it will give me all the columns. It will give me name, salary, your gender, right? But I only want name and salary. So there I have put another column to it, attached to it. Fine, understood, right? Then we are also doing some operations which is having your binary operations. Binary operations means so this is also combining with this, and it is an AND operation. Okay, so both the conditions need to be met. Both the condition must be true, right? And if they are true, and then it will return you the data. Okay, so this you are trying to make a selection out of it, and this is how you are trying to get some information. Yes, so this will be having some meaningful information. Let's say I wanted to select those employees where age is less than 25 and gender is equal is male. Okay, give me those information. Okay, so give me that list of information from the data set, and I could just process some information further. Okay, let's say my boss wants that give me those employees names, like which age is 25 and gender and is male and salary is less than 10,000, something like that, right? So there we can just try to make a selection from the data set, and then we can use that. Is that fine? Okay, up till here, any doubts, any questions you are having, just let me know. Any doubts, any questions you are having? So before we move to the next part. Okay, so let us try to create a data set, right? I will try to create a sample data set. Okay, so what I will do is I will try to create a sample data set with the employee ID, name, salary, department, and your joining date, right? So I urge you all to just try typing along with me, okay, and create the data set. Okay, and then based on that data set, we will try to look more functions of pandas. Okay, and also we will try to formulate some of the questions in that particular data set, right? Let me try to create a data. Okay, so now I have created this data set. Okay, so I urge you to create this data set. Okay, so what I will do is I will try to, okay, first you just import this into a pandas data frame. Let's say I will try to pd dot data frame, and then we will try to put a data. Okay, pd dot data. I haven't run this actually. All arrays 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. Yes, here I've missed it. Okay, so once you have successfully converted this data into data frame, just let me know. Okay. Okay. So now what you need to do is you just need to do the operations. Like once, let's say this is a real data set, right? Okay. So what operations do you perform? So first you will perform a head operation, what I've told you, then tail operation, right? Then info, then describe, right? Then you need to give me the shape, you need to give me the columns, right? And the d types. Okay, so let us try to do along with you. Okay, so what you have done is, let's say I will try to put df, right? Okay, and then I will say df dot head. Okay, and then I will say df dot tail. Fine. So this is how we are trying to get, because the entries are same. So that is why the head will give you first 5 entries, tail will give you first 5 entries. So there's another option called sample. Okay, just try the sample. Sample, what it will give? It will give you the random values. right? So it is giving you the random values. Okay, so just try it the sample also. Okay, so sample what it does, like when your data set is so large, so head will only try to give you, let's say, first 5 or 10 entries, and tail will give you first 5 entries, right? But since your data set is so large, so you cannot know, like, okay, the first 5 entries are correct, but what about the middle entries? Middle entries you cannot check. So this is your sample in which there is randomly some data. There you can check like whether your data is consistent. Yes. So your data is consistent or not. So there you can use the sample, right? So this also is very like good method in which you can check. Then you need to check your columns, df dot columns. Okay. So this is your columns which you are trying to have, and then you can also check the shape, that is 5 cross 5, like 5 entries and 5 rows and 5 entries, right? And then your d types, right? So here you can check like this is your integer, name is your object, and salary is your integer, joining date is also in your object. Fine. Then you can also have info, right? So here you can see that it is having your all the non-null values, right? So up till now, everyone needs to run this because this is how we are trying to explore our data set. We are trying to get some meaningful information that whether our data set is correct or not. Okay, so everyone up till here, just type it done in your chat. Okay, so I'll give you some time to complete this and just check, yeah, the data set, that all these columns and shape and d types you have gone through it or not. So I'm repeating. So this was your data set. Then you converted your data into data frame, and then we are trying to do some operations, which is your head, tail, info, describe, shape, and your columns and d type. So Inderjeet, in the columns you don't put bracket. So it is your this thing. So you don't need to put your bracket. So it is an attribute, not a function. So that is why you are trying to get an error, right? And shape also and d type. So these are attributes. So info is a function, right? Sample, tail, these are all functions. Okay. Okay, great. Fine. Okay, so now what I will do, I will make some small change in my data set, and here instead of salary, I will say n.nan. Fine. So here I will run this again, and I'm trying to run this again. So you can say that in the salary, so this is NAN. So here we will try to make this operation that our data is having some NAN values. Okay. So I will try to run this again, and then sample and columns, shape, d types, okay, and info. Yes. So here in the salary part, you can see that there are only 4 values, which is not null. So there you can see that this column is having values which is your null values, right? So here you can identify. So this is what was trying to say, that in the info method, you can just see that if it is having some junk values, null values, so you just see that how many values are not null. So there you can just see that, okay, salary information is somewhat missing. We just need to correct it. So this is how you need to correct it. Okay. So now next question is that, okay, now select me only the salary column. I wanted to see only the salary column. Okay. Then I only wanted to see select or see all entries or all employees which are from IT department. select me the name and the name of the employee as well as the department. So this what we are trying to do is we are trying to filter and select. In the previous session, so I've told you, right? So there we are trying to do a practical implementation where we are trying to select the salary column. We are trying to select all the entry. Yes. So NAN is basically not a number or null values. You can say that, sort of. Yes, exactly. Right. So these are the questions. Now I just want you guys to perform on this particular data set. Okay. Or we can just see entries from 1 to 3. Only entries ranging from 1 to 3. Top 3 entries.
Okay, so this I'm trying to give you that how you can select the salary, right? And if you want it, so how you can do it? So first you just need to select the department. Let's say department, okay, right? So you have selected the department. Then you just need to make sure that that department you are trying to select is from the IT, right? So let me check whether the IT is in the capital. Yes, IT is in the capital. So here you will get the true and false. Okay. After that, you try to make another this thing, and then you get all the entries which are from the IT department. Is that fine? Yes? No? First, you need to make sure that you select a department and that department is equal to IT. After that, you again put a DF where you get all the entries from the data frame that what is the employee ID, name, department, salary, or joining date. Is that fine? Yes? No? Okay. So this next was select me the name as well as the department. So how do you do that? Name, comma, department. Yes. So most of the guys have done like this, right? But it will not work, right? It will not work because for a single, if you try to do a single column, so then only one bracket is enough. But if you are trying to select multiple columns, then you need to put a double bracket here, right? So here you are trying to select the name and the department. Fine? Understood? Yes? No? Any doubts? Any questions here? So this is particularly what we are trying to revise. So the previous lecture only we are trying to revise it, but I want you guys to perform the operations along with me so that we can do it, right? So 1, 2, 3, right? So here by using your ilog, we can just select those entries which are from index 1 up to 2, not 3. 3 will I will not be using 3 because like this you already know. Okay, great. Okay. Now you can see in this particular data set, we have the joining date. Okay. So the thing is that like whenever you try to get a joining date, you just need to convert this joining date into your Python datetime object. Fine. Okay. So why I'm trying to tell you. So if you try, this is your Python, but if you try to convert into your Pandas datetime object, so then you have additional functions which you can use it. Okay, so let's say here we have the joining date, and my task is I want to have a column uh, where I wanted to have a column where I wanted to have the joining year as well as the joining month also. Right. So this way I wanted to process the data. I wanted to see like what candidates joined in the month of May or month of March or in which year they have joined. Right. So I just wanted to make an Excel or some do some perform some analysis. Right. So what I can do is I can just, when I'm trying to load this data set, so here I would say joining underscore date equal to pd dot to date time, right? So we wanted to make this joining date. Okay. So this particular column, joining date column, I wanted to convert into your pandas to date time object and make it back to your joining date. So now this joining date, when it is being converted into your pandas data frame, so this is your pandas data frame, but it will be your uh, you will see that it will be converted into your pandas object, right? So I will try to do a head and tail and columns and the type, right? So here your joining date is your date time. Earlier it was an object, right? So the first task is whenever you try to see any of the date operations into your CSV or your data, just convert into your pandas data date time object like this. Fine. So now quickly convert this to date time, and then we will try to see a new function where I just want to have another column which is our year or month. And I wanted to see that how many employees joined in the month of March. So there I can just filter it out. But first I need to convert this joining date into a date time pandas object. Are you getting my point? Right? Okay, so date time. Now you put a dot and you say date tt dot, and here you will say okay, or you can see here also. Okay. So now you can see that. So these are the years where your data is being done. And I would say yes. So you have your joining date, you have your joining year also. Okay. So I want to see those employees who have joined in the year 2025. There I could easily say, right? So you can also sort it like the employees which who have joined before 2024 or after 2024. So this way you can just make some data analysis very easy, right? So you have given the data, but you are trying to make a new column. So that is totally fine because you are trying to have that this thing manipulation done. Okay. So let's say day also. I want some day also. Let's say. So I will say df joining date dot dt dot underscore day of day name. Right. So this also you are trying to get it. So this I will also say joining. So here you can calculate the joining date, joining year, joining day, right? And also another function that I will teach you after this, that we can convert this to ISO format also, right? In your global timestamp, we can just convert that date also. So that I will try to tell you with another function. So first you understand this point, right? Okay. So I just wanted to calculate the salary, or let's say first I wanted to sort the values, let's say by salary. Or I wanted to sort the values by salary, but first we wanted to get rid of this NAN. Okay, so you already know that, right? How we can get rid of NAN, right? So first what I will do is, yes, drop NA or fill NA, right? But here there's a challenge, right? So let us try to see, like in the IT, you can see that like the IT has having a salary of 20,000. Okay, So either you can just make it as a fill NA as 20,000, or you want to calculate the mean of the salary and make this NAN to that mean. Okay. First, you will try to see the salary dot mean. Let us try to calculate what is the mean salary. So mean salary is this one. Okay. So I just don't want to disturb my data. What I will do is I will try to put the salary into NAN. So what I will do is df dot fill NA, and here I will say df salary dot mean. Okay. So right. So here you can see that the salary has been changed to this thing. First I calculated the mean salary. There I'm trying to fill the NA with the mean salary. Okay. So there you can see that the salary of Sunil has been changed. But it is not reflected. Guys, it is not reflected. Why it is not reflected? Can anyone tell me? In the original data frame, it is not reflected. So yesterday I told you, yes, df equal to, yes, but if I don't use df, then another option could be in place. Yes, exactly. You are 100% correct, Arunima. Yes. Okay. So here, what we need to do is we need to do in place. In place equal to true. Until unless we do unplace, so this changes won't get reflected. So this is only for the checking that okay, we are trying to replace it whether it is being reflected or not. Okay, so this we will try to make the actual modifications in your original data set. Right, so this you can see that. So now it is being reflected. Understood up till here? Yes, no? Quickly do a change this NaN to your mean and replace it by mean so that we can have that reflections done, changes done. Yes. So Indrajit, like it depends upon the business logic. Okay. So you can have any okay. So I'll repeat it again. Okay. So the problem statement was that in our salary there was NaN. Okay. And this guy Sunil, we don't know his salary. That is for sure because it was not recorded in our CSV or data. Okay. So now you as a analyst, you are a business analyst. Okay. You don't know the Sunil's salary. Okay. So you have two options. Looking at the data, you can just see that, okay, Sunil is from which department? It is from the IT department. Let us see the salaries of the IT department. The salaries are 20,000. Okay. You can just make sure that, okay, Sunil's salary is in the same department. You can assume that Sunil and Vipul are working on the same department. So let's make their salary 20,000. Okay. You can make their salary 20,000 and just proceed with option one. Second option is that if you are confused there also, that what should I do, because in this whole data set only one of the entries is NaN, rest all the entries are intact. Okay, so you just need to interpolate these entries. You need to just make a random selection that, okay, so that random selection you can just do it, that you calculate the mean salary and then you can place it. So why you are trying to take a mean salary? That if you are trying to do some analysis, so that mean wouldn't be reflected. So it will not make a huge impact. Okay. So and also it depends upon the business logic or the product, that what kind of imputation you need to do it. What kind of value replacement for that NAN you need to do. Okay. So these analysis you need to make on yourself on the go when you are trying to work on the data. If your NaN entries could be large enough. Let's say in this entry, there could be NaN here, joining date. There could be NaN in the department. Only name and employee ID is given. Then you can drop NA. You can drop NA and you whole entry you can drop it. Okay, that is the optimal way in which your data was missing. You don't want it to make your data filthy or incorrect value. But here, by the data analysis, we can do it that okay, the salaries of the IT guy are ranging from this and so. You can calculate the salaries of the IT guys first and take a mean of that, and then also you can replace it. Okay, that is also another option. You can just see, but here I have taken the salary of the whole of the department. But here, department wise, you can calculate, and from the department wise, you can make a mean, and then you can take it. This way also you can do. So we are working with smaller data sets. So that is how I can just make an example. But if you are working with larger data set, so there are so many possibilities and where you can just see that what values you need to make it replaced. Okay. Indrajit, Aniket, did you get my point or you want me to repeat it again? Yes. In place 2 is doing the update. Yes. Using in place. Yes. And Aniket, is this the accurate way to populate NA values? It depends. Okay, so this is one of the way. Okay, so this is one of the way to populate NA values. Either if you know from the business logic, let's say the IT guys have the salaries, let's say not more than 20,000, so you can replace those. So this is what we know. Like you get your data often at times there could be missing values. So you need to make a judgment. Either your manager also don't know, and the person who has given that data that also you don't know that what entries need to fill. So you are left with two options. Either you need to delete those entries, either you need to populate those entries with some arbitrary value. For arbitrary values, you just need to make some logic, correct logic, or understand some business logic, so that okay, so that your data is being retained. Okay, so you don't delete your data. Okay, so in that sense, you are trying to make some analysis and informed decisions. So there you can do. Okay, got my point? Yes, Aniket. Okay, great. Okay. So now let's try to sort the values. Let's say I wanted to sort the values. Okay, so I will say sort values by which, by salary I wanted to sort it. So I will say salary. Okay. So now you can see that your entries got sorted. Your entries got sorted by the starting from their lowest to highest. Okay, whole of the data set has been changed guys here in this manner. You can see that when you are trying to have your data set. So here, according to the salaries, right, your data set has been sorted. Right? Yes, exactly. So here, I could only say ascending equal to false. So let's say you are trying to pull the data from the SQL. Okay. So SQL has a default ID. Okay. So in that SQL, let's say the SQL guy has entry, let's say 1 to 1000, let's say, and he has given you that Excel, what we call data, and you are trying to get that Excel data from into your Pandas data frame. But in that 1 to 1000, let's say some of the entries, let's say from 50 to let's say 60, those entries are not there. And let's say from 100 to 120, some of the entries are not there, right? So these are some entries which are not present in your data, right? But when you are trying to convert your SQL data into your Pandas data frame, you will get as these IDs as your these SQL ID as your index. Okay, in that sense, some of the index may be missing. So there you need to use your reset index or your sort index, right? You can sort that index and then you can use your reset index, right? So there these functions are needed. Okay, so that is the correct logic where you can use those functions where your data indexes, dataset indexes are not consistent, and you wanted to make it consistent from zero, from ranging from 1 to 1000 or 1 to 100, something like that, and few entries are missing, and there you just need to reset the index and sort that index. So we'll also do a example with this sort index or reset index. Okay. Okay. So let me complete this. Okay, because we are in a flow. Okay. So that is why I wanted to give you an list. Okay, and this. Okay. So sort values. I'm trying to do it. Can I sort the values by department as well as your salary? Okay. So let us try to do it. So what I will do is I will try to do a salary and your department. Okay. Okay. So let us try to run this and see what happens. Okay. So this will not work. Okay. Because we are trying to give you two values and those values has to be contained in a list. So this is basically your sorting your values based on multiple columns. Okay. Whenever you are trying to use one column, so you can use it. But if you are trying to use multiple columns, so make sure that you just need to use a bracket. So this is your IT department, which is having your salary 20,000, and this is your 43,750. So average salary will come out to be this plus this divided by 2, right? So you just wanted to calculate the average salary of the IT department. Or the HR department, 50,000 plus 65,000, you just try to calculate and then divide by 2. Okay, right. But if the entries are so large, right, we are having two entries, right? But if it has HR, like in the HR, like how many employees are there? Could be 10, could be multiple, like, yes. Yes, Saurabh. In the MySQL, when there is auto increment column deleted, yes, then we can reset the index in the Pandas data. Yes, you are exactly right. Okay. So you wanted to calculate the average salary in the IT department. Okay. So there's another function called group by. Okay. So first we will do a group by with IT, and then group by will always work on the aggregate function, which is your mean, max, mode, right? So this we will try to see. Let us try to see. So we will try to see df dot group by. Okay, so let us try to see what it does. Let me see. Okay, so this is your like data frame, which is your animal, and this is your falcon, parrot, and your max speed. So we have the two animals, falcon and parrot, and this is your max speed. So we wanted to have a group by and calculate the mean, where we will try to get what is the mean speed of the falcon and what is the mean speed of the parrot. So similarly, here we are trying to utilize this in our use case also. We are trying to get the salary, which is your mean salary, it could be max salary in the IT department, in the HR department. So here, instead of animal, falcon, it is IT, and here we have your HR, right? If there are multiple columns in sense, these are your columns, and it has having multiple values. So then we can just have a group by, and then we can calculate. So group by alone will not work. Okay, it will only work with your aggregate functions. So mean, median, mode, max. So these are called as aggregate functions, right? Right. So let us try to see group by, right? So then we will have your department. Okay. So this will not give you anything. It is a function. And if I try to say I wanted to have the salary, okay, work on that salary. First group it by department and then give me the salary dot mean. It will give me the mean salary. Here we can get the max salary also. Right? if I wanted to get the all the operations, let's say group by and I wanted to work on the salary, right? And dot aggregate. So this aggregate is basically if you wanted to have more than one functions. So you can just type it here, mean, max, right? Or you can say min. Let me try with this. Okay. So here you can see. So what we have done here is that we are trying to group the department. Okay, so we are trying to group the department. Let's say there are multiple departments and we are trying to group that and the entries in that department are multiple. And I just wanted to calculate the salary of each department. Okay, or maybe here we can have the count also. That how many department entries are there. Okay, so you can see that for the finance there was only one entry. For the HR there are two entries. For the IT there are two entries. And here you are trying to calculate the mean, max, min salaries of those employees working on those departments. So department wise, we are trying to calculate those salary and spend. Understood? Okay. So this is very important function, guys. How we can try to calculate. Okay. So this is actual data set we are trying to work it out. So this is why I have given you a toy data set. That if you are trying to work on that a larger data set, so these operations are really very useful. Group by aggregate functions, okay, and these things. Not all departments. If you want to have the salary of the group by of max, okay, so you wanted to have the salary of only finance and HR. Okay, so let me check. Okay, this is giving you this thing. Okay, this way also we can do it. Yes, this way also we can do it. Else we can also do it like this way. Right. So this is your data frame which is being calculated after you having the group by. So there you can just formulate it and then you can just do it. So what we did is like we are trying to have a group by. So group by function is very important, right? And then we first sorted the values, right? So this is another function. Okay. By multiple columns, we could have inside your list the salary and department. If a single column, so then we can just mention that single column, right? Okay. So before that, we did joining by using date, right? Okay. So, okay. So let us try to see our data frame and now we will try to see another function. Okay. What if I wanted to see how many departments are there? Okay. Question. How many departments are there? Okay. So imagine this is a long list of data, right? Where only the five entries you are trying to see, but there could be HR, there could be IT, there could be your DevOps, right? There could be development, right? So there could be many departments where you cannot see in the first five entries, right? And if the data set is large, so you just need to see it. Okay, how many departments? Okay, so there, let me try to give you another function, which is data dot department dot value count, right? So here you will get a count of how many entries a particular department has. That HR has two entries, IT has two entries, finance has two entries. Okay. So this way you are trying to have a value count of each of the entries, right? So this way you can do it. Quickly do it and let me know how to check the entries, that the count of how many entries. But the question still arises that how many departments are there, right? So how to check whether there are how many unique departments are there? Okay, so okay, so now this department has having location New York, India, and Russia. Okay, and this is your original data frame, right? Okay, so this data frame and this data frame consist of the entries which are similar. Okay, so I just wanted to merge these entries. I wanted to merge into this data frame, right? How I wanted to merge on the basis of department, right? So let us try to merge it by using your merge. Okay. So here it has your left, right, on, right, which basically your index, right? And it also tells you that it is inner, outer, right? So basically in the SQL we have joins. So this concept follows the similar pattern where you have two data frames and on left entries or on right entries, how you wanted to make that join. Okay. How it is given left, right, outer, inner, cross. So default is inner and left only use keys from the left name similar to the SQL left outer join as preserve that key order. Right only use keys from the right frame similar to the SQL right outer join. Right. So this is basically your joins which you are trying to the concept is coming from your SQL. So how you are trying to merge that. Okay. And on is basically your label which is being present on both the data frames. Similar to your SQL where you have your one table and another table and one you wanted to join those two tables. Okay. Right. So this is how you can see. The example is also given. Let's say you have the L key and your right key and foo bar this thing and you wanted to perform the operations. So let us try to merge it, the data frame, right? And your department data frame. So we are trying to merge your data frame, this data frame and your department data frame, right? We are trying to merge it. On which column? We are merging on department, right? Then how we are trying to merge it? We are trying to merge it by using keep the entries of the left as it is, right? Left means this left. This is your right. Fine. And then we try to get the final merge. We call it. Yes. Now you can see that location automatically got updated by using your department, right? So here your IT is your India, Russia, and your HR is your New York. This way you can get your final entries merged. Fine. Just quickly do it and just let me know in the chat once you have done it. So this is how we are trying to merge two data frames. Okay, so this is basically a concept. So in future, if you find there are multiple data frames and you wanted to merge it by on your convenience, but there must be one entry or one column must be same in both the data frames. Then only you have a common what we call common link in which you are trying to link those two data frames. And then rest is your how you try to merge it by using left, right, or inner, outer. So this way you can just do. Okay, here are the data frame. So in the Python, what basically we have done, we have tried to use the for loop. So here also we'll try to use for loop for I in data frame, we call it. dot index. Okay, then we are trying to print data frame dot to iterate through each and every element. So here you can have your EMP ID. I want you to have EMP ID only. Okay, only the EMP ID I will get it. Okay. So try to iterate through department or salary or joining date, right? So you can just try to different variations. So here, instead of data frame, you can just take it final merged also. For I in data final merged. Just try to take final merge dot index. Okay. So I'm trying to iterate it through the index, each and every index. So that is why I have mentioned here lock, right? For the I lock index, and I want the values for the employee IDs only. Okay. So I lock I, right? First try it with this one, then you try with the joining date. So why this iteration is needed? Because when you are trying to work on the data set, there you need to perform some of the operations, right? Okay. So there, these operations are really very necessary where you can just change the some date format or year or salary, right? And there you can just make that data frame updated. Or I can do one thing. I wanted to make a bonus, right? For I in final merged dot index, right? Final merge dot ilog I dot salary, right? So this is my salary, right? Okay, and I take this as cell, right? Yes, dot cell cell bonus equal to 1000. Yes, right. So now I have this thing, and there I could say bonus equal to. Now it is not getting updated. Basically, fine. So now what I've done is like have iterated through each and every row, right? So this was my salary. So for 1 into 10,000 on 2,000, like I try to update it and then I try to append it. So now this is my column, right? So this is my column. And then I could do one thing. I could say df final underscore merged, and I will say bonus equal to bonus, right? So in the final merge, so you could say a bonus column also. So however, my calculation could be incorrect, but this is how this is a sample like toy data set in which I'm trying to explain you that how these for loops are really necessary in manipulating your data. And after you got your data manipulated, so you can make a new column out of it, right? So this is how you can make a new column. Move to the theory part, and what we have done, we have covered the describe sort values group by, right? and drop, merge and concatenate, apply. So this function we will see. Okay, plot also we will try to see. So drop. Okay, so drop we haven't seen it. Let me try to give you an overview of the drop. Okay. So let's say this bonus we are trying to see, uh, like this is incorrect. I wanted to drop this thing, right? So let us try to drop this. So final underscore merge station. So drop specified labels from rows or columns. Okay. So let's say you wanted to remove this first row. So this also you can do it, or either you can remove a particular column, that also you can do. So it is up to you what you need to do. Let's say I wanted to drop the 0th row, right? Amit. So Amit will get dropped. So here you can see that Amit has been dropped from your data set. So the drop will not be updated until you do here. Yes, anyone will not get reflected in place equal to true. Yes, yes, Arun. Fine. Okay. So that you need to make sure. Okay. Now the thing is that if you wanted to drop, let's say I wanted to drop this bonus, I will say bonus. Okay. Right. So this will not work. Why? Because the bonus was not found in axis. Okay. So you need to specify the axis. X is equal to 1. Okay. So now you can see that the bonus has been dropped from your data frame. For loop part. Yes, this is for loop part. Okay. Okay. So this I was trying to explain you. If you wanted to drop some of the entries, the row entries and the column entries. For the row entries, automatically the x is 0 by default. But for the column entries, you just need to specify that along the x is equal to 1, you are trying to drop some of the columns. So that you can specify. Okay. And the rule applies if you wanted to drop more than one columns, so then it has to be inside your this thing list. Okay. So let's say I wanted to drop the salary also. Okay. So now you can see that the salary as well as the bonus has been dropped from your data set, from your this thing. Okay. And in place true, that is for sure. And let's say you wanted to make another data frame, right? You don't want to disturb your original data frame. So in that case, you just put a df and equal to, and then you can just drop these columns. It will be a copy without having those two columns. So these were some of the common functions that we understood, like some of the series functions, right? So we have gone through the data frame functions, right? Sampling functions, plotting functions we have not used, right, up till now. So I will just try to cover that plotting function. And input output functions, that also will try to cover it. That input we are trying to take the data from some format, which is your CSV, your Excel, your JSON, could be your SQL also, and we are trying to put it back to your CSV or Excel or data, right? So this we can do it. Okay. So these were some of the input output functions that we generally do it. Then series functions, what we have done your mean, max, unique, value counts, right? So these are the series functions that we already did. So data frame functions, which is your filtering, your group by, right? Log, ilog, right? Fill NA, drop NA, right? Drop, right? So these were your data frame functions. Okay, right? Then this is your resampling, right? Resampling, reshape and your rename columns. So that could be also be done in the resampling, right? Then plotting functions. So plotting functions, basically we need to plot our data set, right? So that we will try to use it, but I'm trying to give you an overall picture that what all functions we have covered and what all is left, so that we are trying to slowly cover. Okay, fine. So these are the general functions. So let me try to give you the these functions overview, the input output functions. Then let us try to do the practical also. So Panda library provides several read and write functions, each packed with the utility of methods to tackle different file formats. Okay. So read underscore HTML, it reads an HTML file. To underscore HTML, it writes an HTML file. Okay. Right. And here you can see read Excel, read underscore Excel. So this reads an Excel spreadsheet. Okay. If you have an Excel spreadsheet and that contains some data, some rows and columns, so you can easily take that Excel into your Pandas data frame. And all those operations, all those filtering, all those selection, sorting, searching, which we have done, we can do it effectively. We don't want to do it in the Excel format, we will do it in your Pandas data frame format. And also similarly, after your filtering process has been done, we can convert into your Excel also. Right? Right? Similar to your Excel, we have your JSON data, right? Java object notation, JavaScript object notation, we call it, right? And there we could read the JSON format, and then we are trying to put back to JSON our data. So this is also very useful, right? Series functions, copy. So copy is basically we are trying to make a copy of the data frame. Okay. So instead of making doing that df equal to, just make a copy, dot copy. So this we have seen in Python also, that why copy is useful, why we cannot do as equal to operator. So this you just make sure that you do a copy operation every time when you are trying to copy one data frame to another, right? And then iloc, we have already seen that iloc for use for indexing, and that addition of series like add, subtract, multiply. So this goes with the element wise operation. Okay. And if you wanted to do merging and concatenate, so that there are separate operations for merging and concatenate. So that also you can use. Okay. So data frame methods, such as your data frame values, your info, your data frame dot size, right? So these are some of the methods. It provides you for the 2D operations. Okay. So plot is another method, which we have a whole dedicated lecture on Matplotlib and your this thing, which will provide you that how we can plot that data. Okay, you have your Seaborn, so there also so specifically used for visualization by, right? Price and y-axis we have another column which is your bedroom, and we also have line plot, like, right, bar plot, right? And then after that it will try to give you the visualization. So this is basically your plotting of your data set, right? General functions, we have general functions which we call it. So we have your data manipulation, missing data, conversions, right? So this we have used, right? Where we have already used where condition, where we try to put a condition. And if this condition is being successful, we try to replace those values with some values, right? So 0 or 1 or some meaningful values which we have done it earlier, right? And which we are trying to iterate across. And this had, okay. So let me give you an operation, this thing, okay? Okay. So let us try to see the final merge data set, what we got it. So this is our final merge data set, right? Okay. So now what we have done, we have done the data cleaning, data operations, we have processed that data, clean that data. Now you want it back to be stored as a CSV. Okay, so this is your data frame, and I wanted to store it back. So I will say to CSV. Okay, so if I see it, so you just need to give the file path. Documentation. So you need to specify out.csv or name of the CSV. Okay, and you can just keep that index equal to false. Okay, if the index equal to false, so these index will not be uh, present in your CSV, else it will be a additional column. So that you don't want. Okay, so let us try to give it a name as a final data frame dot CSV, and I will say index equal to false. Okay, so let us try to see it. And let me open this where I'm trying to work it. Yes. So this final data frame dot CSV got stored in my this thing. You can see. Okay. So you can also check it on your own, guys. Okay. That how we can store it back to the data frame, right? So this, just let me know in the chat whether you have done it or not. So how you can convert it into a CSV, your data frame, your final data frame. Okay, so another forgot to tell you. So let us try to see that also. For how while doing large data, how we understand that CSV exported successfully, it will be done, right? That is not an issue. Okay, Indrajit, what is the error? Just try to change the name to some other name, because like some file name it is trying to get. Yeah, so final underscore df. Okay, so change it to some other name. Maybe that will work. I'm not sure like what is the issue. It's giving that file name is your bad, right? So you don't. So maybe that is some, that could be some issue. Okay, just try it out. Let me know. Okay, and yes, for index comma rows in final underscore marks dot iterate rows. So this is how you can just iterate through the rows. So this like code is simpler than what we have done earlier, right? So this is by iteration through your index, but here you are trying to iterate by rows, and the rows for the column. So department, so you are trying to get all the rows of the department. Okay. So this way you can just easily take the necessary control, right? So whichever fields, even after changing the name, you are trying to get the same error. Okay. Try it with some other, like try to change, like let's say if I wanted to have the final DS, final merged dot, there are not many options, right? So you can convert to dict also. Okay, let's try to convert it to Excel. So this you can see that the Excel format for the final. This is how your data looks like. Okay, right? So I guess some issue with it, right? Okay, okay. So what I was trying to tell you, so for that iterate row, so you can just take take the rows, right? And then for that particular column, you can just see it, right? So this is also another way in which you can do the iterate rows. Okay, so this is how you can convert to one format to XLS or to CSV. There it will work. Okay, okay. Some name error you are trying to get it in the Jeet. Okay, just try to search on the internet that why this error is coming. So maybe it will not be some issue could be there, right? Okay, so just check it out. So conversion, indexing, iterating, and binary operations. So these all things we have done it, right? Okay. So conversion, like we are trying to calculate the mean, and indexing, we are trying to take the column name. Iterating, we are trying to have the row index in DF for iterate rows. And binary operations, so DF plus D1. So just you can just add two data frames and then we get the result. So statistical functions in Pandas. So we have these statistical functions, mean, median, mode, sum, standard deviation, and skew, right? So these basically tries to do perform the statistical analysis, right? And the mean returns the mean of the values over the requested axis. So we can just specify x is equal to 0. X is equal to 0 is by default. Okay, if you wanted to have the mean across the column, so then you can put it 1, right? So it will try to give you across the columns. Okay, median returns the median of the values, and mode, it will give you the highest most occurring value, and sum, it computes the sum over the values over the requested axis, right? Then we already see that terms x is equal to 0, x is horizontal, 0, x is horizontal, x is 1, it is vertical, right? So this you try to factorize from the NumPy itself only when we have done x is equal to 0 and x is equal to 1, right? Okay. Then standard deviation, covariance, and your skew and describe, right? So these are some of the functions which are used for to describe your statistical analysis in your data set, right? Covariance is basically you are trying to compute the pairwise covariance, right? So this we will try to see in your next sessions also, right? So this is a very important topic in which we are trying to see the correlation of one input point or one column with respect to others. And we will try to see whether these columns are of really importance or not. And we will try to judge that whether they could be deleted or removed in our data set for the analysis or not. Right? Okay. So skew, it will return an unbiased skew over the requested axis. Along the axis 0, we can just have a skewness that how much data is being skewed, right? In terms of the data points. And describe, we already seen it generate the summary of the descripted statistics of the data frame or series, right? Which Panda function is commonly used to calculate the summary statistical for numerical data in data frame? Just tell me quickly, guys. A, describe, B, count, C, mean, D, unique. Yes, yes. The answer is A. So A is basically used to describe the summary statistics for the numerical data, right? So time delta also we have seen, right? And right, so this I'm trying to skip, right? So okay, so this ISO format. So basically, these functions are important in which we are trying to format a time delta object into an ISO format, right? So this we will see. Okay, I'm trying to give you a list of this function. And py time delta, it converts a Python pandas time delta into a Python time delta, right? So you have converted your time delta into a Python into your pandas, right? And we are trying to see it, but you want it to convert it back to your Python time delta. So py time delta is the function, right? So this ISO format we will try to see in some few minutes, right? So how we will try to see it, right? Okay. Right. So this already we have tried to see. Uh, right. Okay. So I'm trying to skip some of the slides, guys. So this is only already we have done it. Appending new categories, setting new categories, removing unused categories, sorting, renaming categories, right? So this we already try to see it, right? Okay, so now let's try to see the working with the text data. So this is also very important. Let's say we are trying to work with some data, which is our column, which is our series. Okay, so pd dot series a b c d e f, right? So this we will try to see in practice, right? We wanted to apply some methods. Let's say string dot lower, string dot upper, string dot length, right? So this we wanted to apply. So this is it possible to apply string functions to data if the data type is an object, right? Okay, so this we will try to see. So let us try to see this in practice. Okay, so let's say we have your final this one, final merged, and we have department, right? Dot lower, right? So this series object is doesn't have dot string dot lower. Sorry. Yes. So here you can see that for this particular department, right? So I made this string dot lower, like all this in the lowercase, right? So similarly, I could also do final merged, right? Department dot str dot upper, right? Right. So this I could change it, right? Or I could only say final merged dot columns dot upper. This I'm not sure will work or not. Yes. So this way also it is working, right? So this is how you can just make this string, use of this string, and try to make this apply your string functions. You can do a split, you can do a join, right? So these operations could also be used. Okay, so let's say for this string dot split, right? So this way you can split it, right? Fine. Right? So this is your column, right, which is your series, and there is a method in which you can do it. And also you can do perform a split method also, right? So split method splits the string based on the character or a string supplied as a parameter, and the resulting object is in a list. Fine. Okay. And the cat and replaced method is used to replace specific values in a string or pandas series with another value. And the cat method is used to concatenate or combine the categorical data. Uh, this is your data which is inside your list, and you wanted to concatenate it. So this is basically a joint kind of operation that we have seen in your this thing, your strings. Fine. Okay. Okay. So which is your resulting object after applying the split method to a string? So this is very easy, guys. So option A, B, C, or D. A is dictionary, and C is list, or D is set. Are you guys able to hear me? Yes, no? Yes, the option is C, list. Yes, actually, my charging got elapsed. Okay. So iteration, like pandas provide many ways to iterate over two-dimensional and multi-dimensional data.
Some of the iteration method used in Panda are iLog, iterate rows, log, index, and apply method, right? So this apply method, we will see it now, right? So these already we have seen that iLog, we have seen iLog, we have seen iterate rows, iterate tuples, right? So you can just go through it. Okay, the basic operation is basically the same, right? So whether you take an index, whether you take an iterate rows, so just you need to change the columns, right? Okay, so let me give you an example where you can just do the iterate, sorry, this thing. Yes, so here, yes, final data, final merged. Okay, so let's say we have the joining date, right? So what I want is I want to have this joining date, right? And in the ISO format. So I want to another column, right? So to be applied on the df final merged, and here I could have a joining date, joining underscore date, and I wanted to do apply method, apply. So this is apply, and it could be a lambda x colon x iso format. Okay, right, right. So now you can see, so this is your ISO format. So on the joining date, right? So this is your format. Basically, every this is your minutes and seconds and hours, right? Okay. So if this column I want to convert into the ISO format, and this is basically a widely recognized format which is used. Okay. So I am trying to convert the joining date into the ISO format function. Then I could just simply say that final underscore merged, and this would be an ISO date, right, equal to, right, and this would be your final merged. Fine. So this is your ISO date format. Clear? Yes, no? Yes, guys. Any doubt in this apply method? So basically what we are trying to do is we have this particular joining date, right? I wanted to apply a lambda function and convert all the data into the ISO format. So what I did is I took an apply and this lambda x colon x dot, then take every entries and convert this into an ISO format and then move it back to the IOSA date, which is a new column. Rest, kind of a timestamp. Yes, yes, Saurabh. Yes, exactly. Right? So this is basically your ISO date format, which is a timestamp. Fine. Right. So this we already done it, index and using your ilog and log, and iterate rows. Also, we have covered this iterate rows and apply. Right. So we can use this lambda function, and here this is they have done in a different manner. That df dot apply lambda row dot medicine is plus, right? So this also you can do it, right? So once you understand this concept, so you can use it in any manner, right? Whichever way you like it. Okay, sort values. So this we already done. We are trying to sort values by price, by salary, right? And there we are trying to have the sort values, ascending, descending, right? Right. Okay.
So we are taking a sample data set, and from that sample data set, we are trying to use pandas right? And Pandas functions and operations, we are trying to do it. And also, what we are trying to learn here is that if you are trying to get some data, okay, so data could be of any format. It could be in the CSV, it could be in the TXT, Excel, or JSON. Then you need to load it into the Pandas data frame and do some analysis. And from the analysis, what are the basic steps? Okay, that we need to identify. Okay. So we will be taking one more data set. Okay, so today what I will do is I will be taking one more data set similar to the data set which we have taken yesterday. Okay, and based on that, like I would be asking you questions, and it could be a practice session where I will pose a question and you need to answer, and then we will together do it likewise, and it will be a learning curve for you guys, right? How to do the operation, how to match the data. Okay. And then uh, I would be also teaching you the plots. So today's agenda is plots, right? So you have done the data matching, you have done the data cleaning, you have done the data analysis, okay? But you wanted to represent your data to your end customers, to your clients, okay? So the best part is through the visualization, right? So first we need to visualize that data, and we need to make some visualization with respect to our data points. Let's say uh, department versus salary, which department there is a salary, max salary, right? So and so. Uh, Profits versus monthly sales, right? So this kind of analysis like everybody wants, right? If you are a business, your business is heading. It is heading in the right direction. Am I losing my customers? I'm gaining something. Am I making some profit? Okay. And in which year, in which month, my profit or my sales is increasing or it is not increasing? I need to do some analysis. Okay. And being a data analyst or being a data scientist, so you need to tell them, okay, that so and so dates and so and so months your sales was skyrocketing, and in the month of this, right, something happened and your sales dropped down, right? So these are the charts, high level charts, which goes to the project meeting company portfolio, and future decision has to be made based on this charts and your data, right? So now we are now trying to connect the dots, basically. So in the previous sessions, what we started with NumPy, and now we are trying to do it, right? So now you can relate to it, and now we are trying to connect the dots. If you try to get a sample data set or the real data set, so then we need to make some analysis and make some informed decisions out of it. Okay, right? Okay. So so this we are discussing. So right. So I want others to everyone join, and then we will start with the uh, revision, right, of what we have covered yesterday. Okay. Okay. So, okay, so we'll start with the revision, and then we'll start with the visualization libraries, right? And then we will, in the end, we will try to take a sample data set and try to do the activity again, which we have done it yesterday, and along with the graphs and the charts, right? Okay. Okay. So, so in the starting, we imported our pandas library and your NumPy library, right? So this, one of you are quite familiar with those things, right? And then we took data which is of dictionary type, and these are your key and these are your values. So note that the values are contained in a list. Okay, so this is all list, right? So list, you can consider this data as a employee ID as a column name, and this values the column is having values, right? So first row is having 101 Amit HR and 50,000 and this date, right? And these are the different columns, right? Which we are specifying. Fine. So this is your data. and this data we successfully uh, imported into your pandas data frame using your panda.data frame d and fr capital. Okay, and then uh, make sure that, like, if you have a joining date or a date value, right? So this date value is very important because it is a string value, right? So here you can see that it is a string, but actually it is a date, right? Okay, so it has some format of the date, and but it is actually just is a string. So in that case, you need to convert into a Panda data frame or a Pandas datetime object, right? So that this date is effectively changed into your Pandas uh, object. Okay, right? Then if once it is been changed into your Pandas object, then you can perform some operations. That is very easy. Otherwise, you need to do the string operations into that date, and which is very difficult to do. Okay. So the best way is that, like, first you have the date and you try to put this date into a date time object of the pandas pd.to underscore date time, and you specify which column you just need to convert it. So after converting, right, so you can see here the data types. The data type, the joining date has been converted into your date type. Otherwise it was an object, right? So object, why not string? Because, like, in the object we could have a mixed data type. We could have string also, we could have float also, right? So automatically it will take a object, okay, not a string specifically. Object, and then if we try to see the D types, so you can effectively see the joining date is datetime object. Okay. Right. Then operations, right? So first of all, we try to put some data to it, and then we effectively uh, convert this to your date time, and then you do a head operation. Head operation is basically we are trying to see first five entries. Tail, everybody knows that the last five entries, and sample. The sample is basically we are trying to get a random sample out of the whole data set, right? So remember, if the data set is large, right? So you only see got to see the first five entries or the last five entries, and the middle entries you don't know what is there, right? So sample is basically you are trying to check whether the middle entries are also consistent or not. It is not blank, it is not empty. Okay. So when you are trying to visualize it, it's looking okay. But for the middle entries, it might be there that it would be missing. It could be unstructured or dirty. Columns. Okay, so you have your columns, right, in which you can just see what are the columns, right? Okay, and your shape is your 5 cross 5, right? It could be first element gives you the rows, and the second entry of a tuple. This is a tuple basically. The second element of a tuple gives you the columns. D types. So you already know these are the D types. Which D types give you the data types, right? So what all data types it has? Like employee is integer 64, right? Name is object, salary is float, and joining date is date time, right? Okay. Info. Info will try to give you the uh, null null count of entries, right? So it is trying to give you how many entries are not null. Okay, and also the D type along with it, right? And you can see that, and it also give you the memory uses. Okay, so basically, right, when you are trying to deal with your large data set, so one more challenge which you can get is of the memory uses. Okay, so it is better if you have your date type, right? Date, right? Your employee ID, let's say. Okay, so here automatically it has been converted to integer 64 because all the employee IDs were of type integer. Okay, but let's say one of the employee ID was not integer, it was string, then it has changed to object. Okay. So just make sure that you try to make your data in such a manner that all the integers must be fall into your employee ID, not any string. Okay. And you change the d type from object to integer. Okay. Because object takes lot of space and memory constant is there, and integer it will take lesser space. So that is the reason. This is also another type of a memory management of your data. Large memory, it will take more time to process, right? So if it is has less memory and it will take less time to process, and effectively it will be faster. Okay. So make sure that if you have your data types and you are trying to see and visualize that employee ID will only get integer, not object. So change into a correct data type. Okay. So this is my suggestion, because at some time in when working with large data types, I have seen that there is a memory constant also, and we just make sure that has to be optimized. Fine. Okay. So then we started with some kind of an data selection where we only wanted to select the salary column, or we wanted to select all the department where it falls under the IT. Okay. So the normal process is that first you try to run this piece of code, df department equal to IT. Okay. Then it will give you true and false. Okay. So it will give you true and false. After that, it will give you the whole of the department where you are trying to get the employee name, department, salary, joining date, right? So here also, if you try to get, like, let's say I want only the employee ID names, so you can just pose here employee ID and you can get only employee ID. Fine. If you wanted to get the department also, you can pose here department, and here there's a challenge. It will give you error. Why it is giving error? Can anyone point it out? Okay. So I just need to put a double bracket, right? So there it will be gone. Right. If I try to go for a single entry, then one bracket would be enough. But it if it is a multiple or this thing, then you need to put a double bracket, right? So this is the common mistake, right? So explicitly I have raised this question, right? Because when you are trying to do your solve some of the programs or questions, so this might occur to you, right? So just keep in mind when you are trying to work with two columns, so make sure you put a bracket outside a double bracket. Fine, right? So here also, like if you are trying to have a name and department, just try to put a double bracket, not a single bracket. So this is the most commonly occurring mistake that students make. So I've seen in past also, right? So this is the commonly mistake done by my students. Fine. Okay. So make sure that in future you don't do this and you keep a note of it. Then there's iLog. So I stand for your integer, and we are trying to iterate through your first entry is up till 3, and 3 is not included up till 2, right? Okay. Then another column, we want another column in which I only want the joining date, right? So sorry, joining year, right? So by the joining date dot dt dot year, I can just take the years and just save it in a column which is your joining date, joining year, right? So this is a column inside a data frame, right? So that we are trying to make a new column. We are modifying our data frame, right? So here you can see that our data frame gets modified with the year values along with it, right? So this is what we are trying to do. Okay. And similar to that, we also have a day name, right? So we have a joining year, we have a joining day also. So dt.day_name. So this is the function in which we got that name also. Fine. Okay. So then we did some statistical analysis, right? We wanted to calculate the mean salary, right? And why we are trying to do it? Because there was some or is a name, right? So here also you can get, right? So you he in the is an it function, right? So you can get whether, or here you can see that here it is true. Okay. So so here, no, yes. So here you can see that here you looking at the data set, you can see that. So this column has a true value. Okay. Okay. So dot count also you can give it, right? So here you can see that one of the column in the salary is true, which is your is an a, which means that it is null, right? It is not an number, right? So there also you can check it by using this function, and here you can recognize that it is null, and you can look at it, right? So our main objective is that first look it into all the null values and then identify the null values and try to interpolate it or drop it, right? So that I have already clearly explained in the previous session that there are two options. First, you can drop it. If you don't want to drop it, you just can interpolate it. Interpolate means you can replace these values by the max, min, or mean, or median, right? So it is up to you based on your analysis, your intelligence, and your product requirement. So you can just make this value replaceable by some meaningful value, right? So you can put zero also. It depends, right? How you are trying to work with your data. Okay. So here what we did, we tried to put it by using mean, and we replace it and by using this method called fill and make. So in the salary, wherever there was your missing values or NaN, we have tried to replace it by mean and in place equal to true. So what it does, it will try to make some changes into the original data frame. Until and unless you do in place equal to true, so your data frame would not be reflected. Okay, so remember in place true is a very important function. If you are trying to work on it, so it will try to show you a copy, but the original data frame is not reflected. Okay. So this is how we are trying to replace it, and your mean value got replaced in this particular cell. Right? So then we also do sort values. So sort values, we are trying to sort the values by your salary, and by sending false or your true, we can just sort it. Okay. Right. And we can sort by multiple also by salary and department. So here, if you are trying to put a salary, and here you need to put a list. Okay. So just remember, if you don't put a list, it will give you an error. Okay. Right. So similar concept, like if you are trying to work on two columns, so there is a bracket attached. Okay. So then another question, that what is the average salary in the IT department? Okay. So you can just do a group by. Okay. So group by department, and then we are trying to find the salary. First we need to do a group by department. Okay. So this group by department will try to figure it out all the departments, right? HR, finance, and IT. Then we wanted to work on the data set, which is our salary. Okay. So, and it will try to give us the mean salary of each and every department. Okay. So this is how you work on the group by. So group by some column and work on the another column, which is our a statistical function. Okay, so department could be your categorical, guys, right? Categorical means you have your male, female, your department would be finance, IT, or HR, right? So group by has to be some kind of an categorical value, and salary and where you are trying to work on it, it could be your statistical analysis, salary numbers basically. Okay, so this group by function will work on some categorical value and based on your statistical uh, column. Okay, and this is what you are trying to work on your aggregate function. So this is your aggregate functions, like what I have shown you here. So this is your aggregate functions. So these aggregate functions will work on this salary. Okay, right? So it will not work on the department, it will work on the salary. Okay, great. Okay, so then we also do let's say we wanted to only have a group by, right? In the case of Department of IT. So here all the departments were shown, but only the IT department we wanted to show, and we wanted to calculate the mean, max, mean, and count of that particular department. So here we have tried the filtering, right? So this filtering you already know that we can just filter it out by the IT department, and we can group by and salary and this. So this kind of a question could be asked, right? And this is how we need to do some analysis on the data set. Okay. So let's say we wanted to calculate how many departments, right? So value counts is the function. It will give you the count of department. Let's say HR is 2, IT is 2, finance is 2. Okay. And this unique, this is also a very important function where it will try to give you unique values. Okay. So why this unique value is important? So let's say you have a large data set, right? And this could be IT, finance, HR, right? And in some places, the finance spelling is misspelled. Okay, right. So in the large data set, you don't know like why this. It could be a typo error. It could be data error, right? But the data is correct. Only the typo error is there. Okay. So then this unique, it will try to give you unique in this particular thing. Then you can go to that column and search it, and then you can correct that. Okay, and then you have corrected your data. So this is what the data correction look like. Okay, so you have your data. You just need to first identify that is there my data loss is there or data is incorrect. Okay, so then you need to make some changes to your data so that you can correct it. So that is why these value counts and units are very important, where you can find that my data departments are correct or not. Okay, right? Okay, and this salary, right? So you can see that salary is all in integers. By looking at the data types, you can judge, okay, if some string value is there, so the data type might change to object. Then you might wonder that why this object data type is coming in salary, although the salary should be in float or in integers. Then you can just do a quick check or analysis that why the salary is in this thing, and you can correct it. Okay. So these are some of the things practically, like I'm trying to tell you that where you are dealing with your data and how you can fix your data. Okay. Right. Okay. Right. Then and unique is also another function where we can try to get it how many unique departments are there. Okay. Then another thing which we did is like department, and we wanted to merge this data set, right? So this we wanted to merge this department with this original based on the department, right? So this is your key, right? So which is be present in both these data frames, right? In the department also in the original data frame. So you wanted to merge with respect to this key, right? And here what we have done is we have used the merge function. So pd.merge, here we have used the department and df. So this is your left, this is your right, and on is your indicator in which column you wanted to make the changes. You wanted to merge your data, okay, on department, right? And how you need to keep the left entries as it is, right? Okay. So you wanted to merge and you wanted to keep the left entries and merge and make the department merged with the left entries. So this is what your merge operation says. Okay, so there could be another operations left, right, inner, outer join, right? So that is like you can just explore it, right? So this is basically the concept, which is your MySQL joins concept, right? Okay. Okay, so this is your finally merged data set, which we have got right after merging it. And then we are trying to iterate through your data, right? Data frame, basically. So iteration is also very important, guys, right? When you are trying to work with your data, so there might be some scenario you wanted to iterate and you wanted to process, right, each and every record and just do some analysis, right, one by one, okay, and then try to store some value, right, make another column, okay, right. So this is how like we try to make some salary and perform some operations, right. So this way also we can do. Okay, so this is basically on the runtime. We are trying to get the data, we are trying to process it, and then we are trying to update that data, and finally we can store it somewhere else. Okay, so this individual records also you can store it into some kind of an external database or AWS or MySQL, right? So you these entries you just wanted to first uh, parse those entries, convert to some meaningful information like a JSON or this thing, and then you can just move that entries and the run on the fly to some external database connected, or maybe your AWS, maybe onto real-time analysis also. Okay, right? So this is basically in the larger systems. What really happens is that you have your data. Okay, understood this point. You have your data, which is in the JSON format. Generally, it is in the JSON or your Parquet format, which is basically takes less space. Okay, generally it is not in the CSV or Excel because Excel and the CSV takes larger spaces, right? So generally, this data is in your JSON format, which is basically uh, close to your dictionary, right? So JSON is your JavaScript object orientation, and it works well with almost all the programming languages. So they have agreed to a basic structure, which is a JSON. Let's say when we go outside, right? Let's say out of India or any country, right? So dollar is widely accepted. So similarly, JSON is your structure which is widely accepted by all of the programming languages. So all the programming languages, whether it is a Java, whether it is a .NET, whether it is a front end, right, or a Python, or a or a, or your uh, uh, what we call Node, right, Node.js. Right? These all programming languages understand these basic JSON structure. Okay. Now, and Python also understands your JSON. So you have your JSON, you converted that JSON into a data frame, you try to give it back to the particular like I say a Java guy or a .NET guy or a front end guy, right? And that is very easy to gain and process. Okay, so this is what we are trying to do. So here also, when you try to get some data, whether it is in JSON format, you process that right. Okay. So this is for the drop in which you are trying to drop some of the like columns, right? On a salary, we are trying to drop it along the axis, right? Okay. Like, and this is how you are trying to convert your data to a CSV, which is your uh, CSV, like you can convert to some CSV format or JSON format likewise, right? Okay. So another iteration, which is your iterate rows. So this is also relevantly easier as compared to your df.index, right? So df or merge index, right? So this is basically you can just iterate rows by a department or by a column name. Okay. Right. So then we did some operations on string operations. So this is your string operations, dot string dot lower, string dot upper, right? String dot split, right? So on the department, on some column name, you can do these operations. This is also very important, and you can just try to change some of the column names, right? And try to add also, right? For example, you wanted to add underscore to each and every column name, right? And then you just wanted to rename that column, so that also we can do. Okay, right? Okay. So so this is your lambda, right, function, and this lambda function is being applied on your joining date, right? So what we are trying to do is, first we have created a lambda function. What we need to do is each and every element of this joining date, we need to take it and we need to convert into an ISO format. So this is your timestamp format basically, right? And this apply function is being done on your joining date. So after applying this lambda function to your joining date, so we have made a new ISO date column, right? So that we have put it into the final marks, right? So this is what we have done yesterday, right? Okay, okay. So I guess everyone is being now refreshed. Okay, so now, what we will do is, right? So we will try to take the data set and we will try to do some plotting, right? So today's agenda is your plotting, right? So we will plot some graphs, we will charts. First, we try to understand like what is this plot, right? How many types of plots we can use, right? So the normal practice, like let's say we wanted to import pandas as PD, then we need to import your NumPy as numpy. Then this is the most important, which is your matplotlib library. Matplotlib dot py plot, right, as plt, right? So these three libraries are very important, in which we already know. The first two libraries and the third one which we are trying to learn today. So this is the Matplotlib library which is being used for the visualization part, guys, right? So they offer a wide variety of your charts, graphs, right? And you can do some graphical visualizations with this. Okay, okay. So everybody try to import these libraries and let me know. And meanwhile, I will try to create some sales data, right? So this is your sales data in which I will try to take some let's say month, right? And we say Jan, Feb, March, April, right? And then we will try to say sales, that in these months how many sales we did, right? Let's say 20,000, 30,000, right? 1,60,000, 22,000, right? Okay, fine. So then let's try to take the profit also. Let's try to take like in this sales that how much profit we are trying to make. Let's say the 3,000, and here we have the 500 here, and here we have, let's say, right? So this is what we are trying to make the profit. Then let's say we have the region. Okay, so let's say we have the north region, south, east, west, right? So this is how we are trying to make the region also. And okay, so there are four. Let's say May and June also I do it because it will try to make some quarter also. Okay, so you also make this data, guys, and incomplete input. Yes. Okay, fine. Okay. So what we have done is we are trying to make the data, and now I'll share this data to you. Okay, just make this data. Okay, okay, right. Okay, so everybody done. Just let me know in the chat once you have done it. Just convert this data frame to your data frame. You have sales data. Yes, yes, Saurabh. For the first time when you are trying to build it, it might take some time, right? Okay, so don't worry. So just give it a time because when you are trying to make it, sometimes it happens, right? Okay, I'll give you some time. Okay, okay, let everybody try to convert this data into data frame. So then we will try to work on your Matplotlib library. Okay, so now, so look, in this particular data set, right, I just wanted to, I am the owner of this company, and I'm asking you to give me the monthly sales. Okay, so monthly sales, what do you mean by? Like, just try to give me in that how much sale has happened in this following month. There are 5 months or 6 months basically, right? In the quarter, right? Basically. So how much sales has like are there? What numbers are there? Okay. So can you just create a graph out of it? So this is what I wanted to show some representation, right? So to my manager, to the CEO of the company, that looking at the graph, they could analyze that, okay, but here you can see that if you try to see in the month of January, there is 20,000 sales, 30,000 in the March, so it has rose to 1,60,000, right? And April, it suddenly went down. Then May, it jumped up, and in June also it jumped up, right? Right. So this kind of a trend. So you wanted to take a trend out of it, your month and sales. So these are the two columns which are of really important to you. In which month it was the sales and on and your sales in the sales and your month. So these two columns you wanted to show the trend over time, that is monthly sales. Okay. And these two columns are of important to us. First of all, you just need to understand this. Okay. Are you ready? Right? Everybody has imported this data frame? Yes, no? Just type in the chat. Yes. Okay, great. So let's say I wanted to make the sales analysis monthly. This is monthly, right? So what I will do is I will say plot plt dot plot, right? So in this plot, right? So this is basically you are trying to plot x-axis versus y-axis. So in the x-axis, you wanted to have a month, and in the y-axis, you wanted to have the sales. Okay. So this is what you are trying to do. So plot y-axis x as the lines or markers. So lines, you can make it as a line also, or you can make some marker. Marker in the sense you wanted to point something. So let us try to understand it, right? So you are trying to plot x and y. Okay. And your markers could be, yes, so these are some markers. These are point markers, circle markers, pixel markers, right? Triangle down markers, right? Try markers. So these are all your markers which you can specify. And you can also specify line styles also, right? And your color also. So let us try to see first your data frame. First one, you wanted to have a month. right? Then you wanted to have a sales, right? Okay. Then let's say you wanted to have a marker, right? So I put a O to it, right? And then you wanted to have some color also, let's say, right? Okay. So this is basically your normal plot, right? Which we have done it, right? So this will work when you are trying to do plot dot show. So this is your normal plot in which we are trying to make the month as well as your sales. And this is your how your sales grew, right? And then it came down suddenly, right? There is a sudden jump in your sales from 1,60,000 to 20,000, right? So this trend, so they wanted to analyze this trend, like why it happened, why this is a sudden jump, and then it tries to increase it, right? Okay. So what happened in the month of April? After March, what it happened, right? So they just wanted to understand this. So these are the points. Okay. Okay, so now let me ask you one thing. So, do this graph looks nice to you? Because it is not looking nice to me because like it doesn't have like the what could be your 20,000 could be your employees also, so it doesn't have some labeling attached to it, right? So it doesn't have some title attached to it. If you try to show this graph to your CEO, so he will just uh, uh, shatter you in pieces. He will say that what kind of a graph you are trying to show me, it is not having some kind of a valid nomenclature, right? So it should be presentable. So what you need to do is you just need to add some title to it. Let's say what we have, right? So what is this monthly sales? Okay. So then we just wanted to have the label X label. So on the X axis, what is present? So it is present month. Month is present, right? In the Y label, what is present? Sales is present, right? Then there's another thing which is a grid. Okay, I wanted to make the grid as true, and let us see now. Now it looks something you can see sales is on the this on the y-axis, your month is on the x-axis, right? And your monthly sales is your basically your title of this particular plot, right? So now it is looking nice, right? Okay, okay. So marker, let us try to change. So this dot zero, this marker, you can see now. So this is your marker basically, right? Okay, so let us try to see what all markers we have. So let us try to change one of the markers. Okay, so there's a long list of markers. So this is your circle marker. Here we are trying to have a circle. Okay, so let us try to have triangle marker or star marker. Let's say star marker. Okay, I will put here star. Right. So now you can see that there's a star. So this is star which is appearing. Right. So here. So let's say I try to put a V to it. V is not there, I guess. Yeah, small V actually. Yeah. Small V or a point also we can put it, right? Okay. So plus marker is also there, D, right? So we can put plus also, right? So let us try to put a plus, right? Okay. Yes. Right. Okay. Okay. So background lines like grid. Yeah, basically this is a grid. So actually we are trying to divide this into a grid, right? So line, okay. So somewhere what happens is that like now you can see that. So this is your 20,000 and 40,000. So it is somewhere like close to 30,000. We can see that, right? So this is this your grid, like it gives you a line indicating that it is somewhat uh, uh, like larger than 20,000. Okay. So this is how your grid appears. When these lines are not present, so it has a difficulty in there. Okay. So this is what your grid shows. Okay. Label there those markers. Okay. So I didn't get you. Like you wanted to label this with some value, right? So you are trying to say that. Yes. So you can also do that. So there could be additional function which could be there. No, on that label. This I didn't get your point, Pooja. Label the marks. No, on that label. These marks, right? So you are trying to say that you wanted to label this on that mark, right? Okay. That also you can do it. I'm not sure because I haven't done labeling. Yeah, graph with values. Yes, yes, you can do that. Okay, because like this is the basic Matplotlib library, right? Okay, so this is the default or the basic. So in the visualization part, so there are multiple libraries in the market. You have ggplot, yeah, also coming, right? PyPlot, right? So these are some of the visualization library which are advanced, very advanced, and it will create you nice graphical charts. Okay, so I have not given you that understanding because first you try to understand the basic level that what all graphs are there. Then you can just like try to enhance your graphs. Okay, so these is like let's say these are 5 lines of code when you are trying to generate a graph, a simple plot you are trying to generate it. But when you are trying to do with data frame, it could be a single line graph. Okay, when you are trying to generate with your SNS or Seaborn library, it is a single line or a liner code. Okay, right? But I am trying to understand this. So this you need to understand this. So your question is valid, Pooja. It is perfectly fine that I can whether I can do some additional modifications to my graph to present to my customer with some additional knowledge. Yes, you are absolutely right. You can do that. But for that, you need to look for that particular function or particular operation, right, in that particular library. Or if that library doesn't provide it, you can go for another library which can provide. Okay. Okay. Fine. So let's try to do another thing. Like we will see. I wanted to compare. I wanted to get the monthly profit. Okay. So monthly profit, I wanted to get it, but I don't want to get it by a plot in which you have a line plot. So here you are trying to make some analysis, monthly sales, right? So profit, you can just have a bar chart, right? So we can just plot it plt dot bar. Okay, by the name descent, so it has some kind of a bar. So I will take the month and I will take the profit. Okay, great. Okay, so this I try to copy it, right? Let's try to see another graph which is same, but instead of bar, we take a horizontal bar, right? Horizontal means you are trying to have, right? So this you need to change it, right? So this is your not profit. So this is your month, and this is your profit, right? So here X label I wanted to change it to profit. So you include a H to it so that you try to see it. So this is basically a representation. Yes, Saurabh, we can also save these graphs actually. Okay. So once you have this thing, right, and ELT dot save, actually you have an option, save figure, and there you can just save this thing. Okay, one dot png, something like that, right? Save figure. Let me see the documentation. Let us try to save this. Let's save one. Just check it out, guys. Like run this command and try to save it. Like whether this is been saved or not. One dot png or what like because in my system is showing me, but it is not showing the picture actually. So I just need to go to my, one second, I'll just show you. It is blank actually. Yes. You just need to put that format also. Maybe PNG, PDF, or SVG. Yeah, try it with the PDF. Yes, PDF is also blank. So this is saved actually. Actually, it is not coming. So I need to check why it is not coming. Okay. Okay. Okay, so we'll figure it out. Okay, so let's try to complete this theory part first, like this practical implementation of all the graphs, and then we will try to see like how we can save it, right? So that is not an issue, right? Maybe in the Matplotlib, right? So this same figure like want some additional parameters or some thing, right? So that I currently don't remember right now. I need to just search it and check it out. Okay, then we can just save it. Okay, fine. Okay, so this everybody has done. Okay, so it is coming, right? Okay, so for me it is not coming. So maybe Saurabh, it is coming. Okay, fine, great, great. Okay, okay. So uh, everybody done? Yes, no? Just type in the chat. So next we'll move to the pie chart. Okay, along with the code it is coming. The graph is coming. You are trying to say this. Okay, okay, great, great, fine. Okay, I'll just check it, right, and then let me know, right, for the PLT save, right? The option to save it is this only, right? Okay, fine. Okay. So the next, it is your pie chart. Pie chart, it will give a round figure in which it will try to give you the distribution of each and every uh, uh, categorical figures you wanted to check. So let's say I wanted to get the regional sales, right? Region-wise sales, right? And also I wanted to get the percentage out of it, right? How many percentage of sales has been done region-wise, right? So then what you need to do is, because there are like different regions, first you need to do a group by. Group by you need to do it via region. Okay, then you need to calculate the sales and total sales by this region. Let's say north, how many sales they have done it, and you need to sum it. So you need to calculate the first you need to do a group by region, and then you need to calculate the sales, and then you need to sum it. So it will give you the total sales region wise, right? Okay. So let us first try to understand. Right, let's say df dot group by, right, and here you need to do it by a region, right? So this you will try to do it, and then what you need to do it, your sales. Okay, then dot sum. Okay, so this is your region sales. So this is your region sales, right? So north, west, south, and this one. But this you want into a percentage wise and in the form of an what, pie chart, right? So let us give these as the region sale, and then I will say plt dot py. Yeah, I will put this region sale. Then it is labels dot index. Okay. Then auto percentage, right? Equal to, we have percentage 1.1 as double percentage. Okay. plt dot title sales region. Yes, not wrong. Fine. So this, like when you try to show this, right? So now understand this. So this is your region stage, what we have calculated group by region and stage, and we are trying to calculate the total sum. So total sum, it is being converted into your auto percentage. Auto PCT means percentage, and this is your precision of the percentage, right? So here, like this is 1.1 F, right? So this is what we are trying to do it, right? So here you need to put it 0 also. Then you can see it has got changed 10 up till 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So here you can put it 2 also, right? So 2, right? So this is how you are trying to get the figures changed. And this is your title as usual and your plot also, right? So this is basically your pie in which we are trying to get the overall distribution of your categorical with respect to your numerical or a quantitative analysis of your data with respect to the percentage. Fine. And region wise, it is trying to display that your west region is only 5%, but your east region is higher in sales, right? Okay. It is auto percentage. And here, this percentage is 43.01, right? If you, this is point 0.1, right? And this is your second, right? So if you try to put 3, now you see 0.11914, so 3 decimal, right? So here also 3 decimal. So you can just see how much decimal it will try to get. Yes, it is defining decimal basically. Yes, Pooja, right? So you can just take it. Okay. So this is your pie chart. It will try to show the proportion of categories, your regional distribution, right? Okay. So this is your pie chart basically. Okay. The G is done. G is also done. Okay. Great. So let's move to this another plot, which is your scatter plot. Okay. Okay. It will basically, scatter plot is basically you wanted to have a relationship between two variables, right? So in this particular data set, what we have, your sales and profit. I wanted to try out a relationship between your sales and profit. I wanted to scatter that how much, like how much sales and how much profit we have got it, right? Okay. So sales versus profit, I wanted to just take these feature. Okay. So what I will do is, I guess you are now familiar that you can just say scatter. Okay. Then two variables, you can just say data frame. Let's say you have your sales. Okay. Then you have your data frame, which is your profit. Okay. then you can just give a color which is let's say red. Fine. So plot dot title, sales versus profit. So here you can see that like there's a graph, right? So there's a distribution, right? Which is coming on, right? Sales. Your as your sales is getting increased, so your profit is also getting increased, right? So you can make some analysis out of this, right? So this is basically a trend, right? So which you can make it. So your sales has been increased, your profit also has increased. Okay, so this is what you are trying to achieve. Okay, so this is pretty straightforward. You have a scatter plot in which you provide a relationship between two values. So I give you another example. Let's say the cars. Okay, so the car manufacturer companies, the most uh, old car will not give you anything. The price of the old car is very less if you try to purchase a old car, right? But the new car, the price is generally more, right? The you can just make a relationship between the age of a car and a price of a car. As the age of a car increases, the price decreases. Okay, so you can just make a relationship out of it. So this is how you are trying to get a relationship. So positive skew and negative skew is something different. So that is basically you are trying to have a distribution of the data. There you are trying to have like let's say uh, 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 bend towards one thing, right? You can have a positive skew or negative. So this is your negative scaling or a positive scaling. You can say that, right? You are right on that terms. I must say, but skew is not the particular word you can say. Okay, you can say have a negative slope or a positive slope. This way you can just say that it has a positive slope in which the trend is upward, it is rising, and sometimes the trend is backward or it is diminishing. So this way you can just relate. But skewness is basically your shift towards your data, which is your positive or your left skew or a right skew or negative skew process. So this way you can just say that. Yes, exactly, Pooja. Directly proportional or inversely proportional. So that is basically we are trying to judge by the scatter plot. Right? It is basically this you need to understand where these plots are necessary. Now you are trying to learn that at what point of time you just need to make a plot, whether it is a scatter plot, it is a bar plot, right? Whether it is a pie chart you need to make, right? And horizontal bar. So that is basically same, right? Bar. Right? This is your plotting. So this is your analysis also sales, right? So this is simple. Okay, got it, right? Okay. So another plot is your box plot. Right. So box plot is basically for the outliers we try to give it, right? Box plot, right? So let's say, so here in this graph, you will not get any outliers, but if there is a larger data set, so then you can get a generally your outliers, your data points which may be deviated from the normal. Okay. So let me first write it down, and then I'll explain what is basically outlier is, and then yes. So this you can see that like this is a outlier. Okay. So clearly all your profit is being ranging from, let's say, this range, right? Okay. But here, right, this is basically a point which is being deviated from the normal. Okay. So why this block? Like, let's say, first understand what is an outlier. First you do it and let me know once you have completed it and made the graph, then I will explain to you what is an outlier and how this block box plot is very necessary and how to interpret this. Okay, great. So now the thing is that guys, like let's try to understand this profit. Okay. So if I try to go through this, right, the profit. So let's say profit is 3,000, 3,500, 3,500, 3,100, 4,400, and 6,000. Okay. So in all those months, the profit was below like 6,000, right? Now suddenly there was a profit which is close to 50,000. Okay. So either this entry could be wrong also while trying to make that data. So this might occur that instead of 55,000, they have written 50,000. Okay. So now if you try to change one number, the whole of your statistics might change in a company. Okay. The all in a company, all that matter is your numbers. Okay. So if you try to put an additional zero or remove one additional or remove one zero, so that may impact a larger audience. So that is the case. Yes, the sales is higher. Yes, I can tell that sales is higher, but whether this data is actually correct or not, so this we need to compare with the sales. Then we can tell that. But here the sales is higher, that why the profit is larger. Then we can do it. But let's say if the sales were less and the profit is again 50,000, so then we can say that this is an outlier. This is a standard. This is not something we predicted. This is away from some normal deviation. So this is basically like an outlier. We can call that, right? Which is not a common, which is something beyond the normal listening. Yes, we need to investigate. Yes, exactly. Yeah. Okay. So now let's say you are trying to make for a manufacturing company. Let's say so data you receive for a manufacturing company. So there you trying to get the dimensions of a particular part or an item. So there you are trying to make some trend or analysis. So there you see that okay, so these are the parts which are being outlier. And if they try to release to the market with an outlier, so this can make a huge impact on that manufacturing company. Let's say if you talk about, like, let's say this is a Ford company. So Ford company has some specifications of an part in bit, right? So let's say this centimeter and this centimeter. And the scientists were trying to analyze that data with that parts and all that stuff. And suddenly he found that in some of the cases, so there was an outlier of some of these parts. And if these parts would be released to the market, and if they are not specifically or technically fit for that particular specifications, they may cause an accident. Okay, the boiling temperature, the heating temperature, or something like that. So these are regarded as outliers. So these points are really need to be investigated, or they are need to check in your data whether they are correct or not. If they are correct, then it is okay. If they are not correct, then you need to just remove it and correct your data. Okay, so you cannot release that data. Okay, and if I try to tell that, okay, our sales is this thing, it could be directed part. Yes, 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 exactly. Pooja, you got your point. So it could be a defected part. Yes, exactly. And then it has been released into the production, and then we just need to roll it back, or either we need to make some informed decisions so that this part may not go to the production. Right? So that is why these outliers and box plot are very necessary because all your data fall under less than 6,000. And this is how your distribution works at zero. Then this is your middle point, and then 75 percentile, 25 percentile, and your max value, right? So this is how your data is being occurred. And this is your outlier point, which was occurring there, which was present there. And you need to investigate that data, and that is why this box plot is very important. So we were on this box plot. Okay, so everyone has got an idea why we are trying to have a box plot to identify the outliers so that we could just focus on the potential what we call outlier or points which are deviated away from the normal distribution or the normal data, right? So as we can see that the profit actually was not larger than 6,000, but suddenly jumped to 60,000, and there is a potential chance that this could be an outlier. Might be there could be a wrong in numbers. Then we need to cross verify or cross check like whether the sales is greater, that is why the profit is larger, or if the sales is not larger, then this is actually a typo error that could be a 6,000 instead of your 60,000, right? So this is what the box plot gives you a picture. Okay. So now there's another kind of a distribution or a graph or a plot which we can say that which is a bar. And so yes, so the bar we have already done it, right? So this bar, right? So we wanted to include two bar plots inside a single graph, right? So that also we can do it. Okay, so let me try to give you an overview. Let's say we wanted to get the sales and the profit in a single bar graph. Okay, according to the months, I want the sales and the profits. So on the x-axis, it could be your months, and on the y-axis, it would be your sales as well as your profit. Okay, so I wanted to give a different color to sales and different color to your profit, and then accordingly, I could just decide like I could do the math, and then I could present that particular thing, right? So what I will do is first I will need to have the months, which I will try to save it in DUF month. Okay. Then there's a sales also, which is your DF sales, and your profit is also right. Then let's say we wanted to have a bar, right? Okay. So bar on the x-axis, we could have the months, right? So what we will do is we will try to have the length of the months, right? So we will say x equal to np dot range, right? And there we put x, and then we put sales, and then we put a label, right? To identify this is the sales. Similarly, we need another bar plot with the x same, which is your months, and this time we need a profit, right? And we also need a label, which is your profit, right? Then we have plot dot x x, which is x. We wanted to map this length to the months. It is basically 2 month to map this, right? Then similarly, we have the title, sales and profit. Okay. Why this legend? Because we are trying to have two bars, and this two bars we are trying to put it into inside a legend. Legend we call it as a framework, you can call it, or a what or a system we can call it, in which these two bars could be fitted together, right? So this is what we need to put it, right? By label. Yes. Okay. So you can see that like the sales and profit are already in place in the months, and you can see that the sales and the profits are shown in blue as well as in uh, orange color. Okay, and the distribution of amount and your month, right, respectively it goes, right? Okay, so just try to do it and let me know in the chat once it is done. Okay. So a few things here. What we have done is we have introduced two bars inside a single graph. So this legend is very important because this try to uh, map these two things together. Okay. right? So we wanted to uh, so labels can and artist are also being explicitly list inside your label legend, right? So this is really helpful in which we are trying to do multiple things to our graph and then it can combine it, right? Okay. So this is your line one, line two, and then legend. It will also handles your line one and line two and labeling existing plot elements, right? So this also we will try to have that first line or second line, something like that, right? Okay. So this documentation you can read further because every library comes with some additional methods or functions. So you cannot learn or cram each and every function, right? Okay. Say for these libraries, you just it is basically a visualization, right? As someone pointed out that if I wanted to change the color, I wanted to do some beautification, I wanted to add some markers or data points inside your markers. How can I do that, right? So this is all about your beautification. Okay, but the only thing is that as a data scientist, you are only concerned about showing your data and representing your data. And for that purpose, you just wanted to know these 5 or 6 types of graphs or the plots which I have told you. Okay, one is your box plot, then which is your bar chart, right, pie chart, right, and scatter plot, right, and normal plot, right. So why these are important? So it gives you uh, a relationship between one variable to another. Okay, sometimes it gives you group by distribution of some data points. In some, you are trying to calculate your mean or you are trying to calculate the sum. Okay, so this way, these plots are really helpful, and right, you can just explore on your own also if you wanted to do some beautification of these plots. Understood? Yes, no? Yes. So X fix is basically you are trying to map your X with months, right? So this is your X, which is your length of the month. So here you have the months, right? So here you are trying to map it with your months and X. You are trying to map it. So this is which basically your X tick is. You get or set the current tick locations and labels for the X axis. Okay, so this is what it does. Okay, so let us try to now this is your matplot library, right? So what we have done is so this is your matplot and we have tried to make a plot and title, label, X label, grade, show, right? So these are some of the commands which we have done, right? Okay. So then the second type of plot we have done is bar, which is basically your categorical with respect to your this is your numerical, right? So numerical representation. So this is your horizontal. Basically, we try to do it. Pie chart gives you the distribution, right? And you can group it by some region or a categorical value, and then we calculate the sales or some uh, numerical distribution, right? And calculate some mean average, right? So this we can do it and show it as a pie chart. Right? Fourth is your scatter plot, in which the points we try to represent the one variable with respect to another variable. So this is regarding as one variable, which is your sales with respect to profit. So how is the trend going on? Whether the sales is increased, the profit is increasing, sales is increasing, profit is decreasing. So upward trend, downward trend, constant, right? So this we wanted to figure it out by using a scatter plot. And then box plot to finding the outliers. And the fifth one is that we can arrange the similar part, right, two plots in a single library. So this also we can do it. Right? Okay. So this was basically your matplotlib library, right? Okay. Yes, relationship trend basically to that. Yes, thank you. Okay, so next let's try to import your Seaborn library, right? As SNS, basic nomenclature is this. Okay, and here I wanted to do a basic right? Uh, you can have a plot, this plot, right? And heat map, right? So these are basically various types of plot which can you can get it, right? Right. So there are n number of plots, right? So you can get pair plot, palettes, plotting context. So every regression, right, or regression plot, right? So this you can get it. Okay, so basically what I'm trying to tell you that like this libraries of this Matplot is the advanced version of your Matplot, this Seaborn library, right? So Matplot library is the basic one, and this Seaborn library is your advanced one, which you can get the nice visualizations and you can have lesser amount of code also. Okay, so let us try to do it with a normal, let's say, uh, bar plot. Let's say you can have a bar plot, and here let's try to check the documentation. Here you need to put the data, then you have a x-axis, then y-axis, right? So let us try to put data equal to data frame, then x is equal to your month, and y is equal to your profit. Okay, and then we can say uh, plot dot show, right? So this is your profit and month, right? So this is how you can show it. Fine. Right? So basically here you don't need to specify the x-axis or the y-axis. You automatically gets displayed like your month and profit based on these parameters. Okay, right? So basically it comes with some uh, very uh, more properties like palette is also there, saturation, weights, right? Right, and like all the UI things which you can think of, right? So that can be done here. Okay, right? So you have the palette name. Colors could be of different levels of the hues. Variable should be something that can be interpreted by, right? So this you can is basically an extension. So why I'm telling you that like Matplotlib is the basic library, right? And if you know the basic, so you can just go to the advanced library and then majorly the variables and the data is same. Okay, only the UI part will change. Okay, then you have a much more rich representation of your data. That's it, you can show that. Okay, but if you are a data scientist, you only concerned about the values and this thing. You are not concerned about the UI part. Okay, so if you are working on the UI part, I don't feel like these UI modifications will really be necessary when you are working with your data. Okay, this is only for the representation. So normal representation in which someone can understand, that is fine. But if you wanted to go ahead and explore it, so that is up to you. Okay, right? So this is what your bar plot is, that if you have a count plot, so SNS dot count plot is also there. You can count the let's check the documentation like data x and y. So similar to that, right? So we can just, right? So this is your count of regions, right? So you can just see, right? Okay, so then why we can put sales, right? So it is not working. Cannot pass both. Okay, count plot you cannot pass both the values. You need to pass only one value, right? Okay, because you are trying to count the number of regions. Okay, right? So right. So this is how like your matplot and your this Seaborn library works, right? Right. So now what I want you guys to do. let me share you one guided practice, okay? And the data set is also I will try to share you, okay? The data set is your sales data, right? So I've shared you some sales data, and I will also share you the, okay. So two things I've shared you. Let me open this guided practice here. Yes. So this is your sales data, right? Okay. So what this is exercise is that like so we will be taking to a real data analyst part, right? So data set includes the fields like your date, product ID, quantity, sold price, and your customer ID, right? So similar to what we have in our uh, uh, like what we were working with, right? Okay. So now your first task is to load the data set into a Pandas data frame, right? And then we need to analyze the sales trend over time to identify any pattern or seasonality, right? Sales trend, guys. Okay. So this you wanted to analyze. Okay. Convert the date time column to date time format. This you already know. And then we wanted to have another column which is of total sales, which is your quantity sold into price. Okay. So then we can have the group data by month, group by month, and then calculate its total sales for each period. Okay, month total sales dot sum. Okay, visualize the trend using a line plot or a bar chart. This also you can do it. Okay, so I want you to do this 5 to 6 steps. Okay, on your own. Okay, so then you wanted to get the group the data by product ID and sum of the quantity sold for each product. This is also very easy. Group the data by product ID, group by product ID, dot quantity, dot sum. Okay. Sort the products, sort by, visualize the top selling products using a bar chart or a pie chart, right? Okay. So these all questions you need to do it yourself. I think it is a very interesting part. And although we have worked much upon that data on the toy data set, and this is also similar to that. Okay. All the options we have done it already, right? So how then we can just analyze the customer purchasing behavior to enhance the customer satisfaction or retention, and what are the effective ways to communicate the insights gained from the analysis to stakeholders, right? And what are the challenges basically in cleaning and pre-processing the data set before conducting analysis. So basically the whole activity is that like you wanted to uh, analyze the trend. Okay, and then you also want the stakeholders to tell that which part of your this thing data was sold and what uh, decisions you can make to improve the customer satisfaction and retention. Okay, so this is how you are trying to calculate the purchasing habits of an customer, purchasing behavior of the customers. Understood? Start doing this activity. And let's first try to load this data set, convert into data frame, and then we add a new column, right? And then get the data by month and calculate the total period sales and visualize the trends using a line or a bar plot, right? And give all the answers to me personally in the chat. Don't try to share the answers to everyone. Okay, just try to give it in the chat personally. Okay, so let's do this. So it's 9:24. Okay, I think like 9:45 or maybe 9:47. Okay, so we'll try to share the answers and then we'll try to conclude this session. Okay, so Jalendar, what it is happening is just are in front of, okay, uh, or put a double slash. Okay, so the reason which I'm trying to understand is that I got your point. What is the issue? Okay, so let me. Okay, so this is your pd.read CSV, right? After that, you are trying to put some bracket, and here is your C drive, right? And this is colon, right? Okay, so basically this colon is causing problem. Okay, you just put an R in front of it and then check it and let me know. Okay, you just put an R in front of it. Now it is working. Yes, Jalandhar. Yes. So this is basically your this escape all the characters, and this is like if because the C has a problem, right? Because this is your what we call escape character, right? So you just need to put a extra hash, or either you put a R in front of it. Okay, and every time you put, let's say, this was your directory, like let's say users, then you have document, right? Something like that. Okay, every time you need to put a double slash in front of it. Okay, or else you need to put a R. Okay, and don't put a double slash. Yeah, that's strange in the deep. So don't know why it is looking like this. Yeah, can anyone tell why it is looking like this? Yeah, what about others? Saurabh, Dan, Jalandhar, Sudhir, Inderjeet. Okay, once you know the full controls of a scooter or a bicycle or two-wheeler, then only you can jump onto a car. So this is what I'm trying to suggest. Like first you have a familiarity with your basics, right? Matplotlib, and then you can do the beautification and UI part. So that is just all matter of red, green, blue, and colors only, right? Okay, so that is the whole point. Yeah, so Saurabh has given a nice monthly trends, sales trend, right? Okay. So like very good guys. Like I'm very much impressed with you all, right? So this is what I want, right? So these things you have understood it and you are trying to do it as applying it yourself. So that is the whole motive behind these sessions, right? Okay, that you can just keep on working on it, and day by day you can improve yourself in these areas because lot many libraries, lot many functions are coming into the market, and you just need to take that control and learn it yourself, and also try to explore it on your own also, right?
And with that, we have come to the end of this course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn.